हे तुम्ही हे करून घ्या ना ब्रेकफास्ट.
मला हे लावायचं आहे. किंगशुक का भेटलो नाही कधी. यू आर नॉट मेट बिफोर. ओके 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 ओके. हां
स्क्रीन आहे. स्क्रीन
सटकणार 100% नाही, पण स्क्रीनचा तोटा म्हणून असेल तर
नाही स्क्रीनला काही प्रॉब्लेम.
कारण आय एम गोइंग टू राईट हिअर.
हां
पेन
आउटपुट येतोय का बघा. हां ओके येतोय.
येत आहे.
हां
तिथे नाही प्रोजेक्ट
तिकडे येईल होणार दोन्ही.
गुड. आय एम ऑल सेट. नमस्कार. येस येस येस. नाही पण आय बी यू हॅपी. सॉरी.
ते तुला डुप्लिकेट करा. येईल हॅलो मागे नाही आलं ना. येईल ना त्यांचा फोन नंबर आणतो. केलं मी डुप्लिकेट केलं आहे. इकडनं खाली केबल Hello, good morning. We will start the program and we will go live 2 minutes from now. Yes. And ते पाहिलं तर बसताय बरोबर. Yes, yes. Hello, Namaskar. Good morning and good evening. Good morning to all who are here offline at ICT, and good evening because this program is going live for those our friends, students of Professor J.B.J., faculties, well-wishers who are from different places across countries would be watching this. Welcome all to this function. We are here to celebrate 75th birthday celebration of Padma Bhushan Professor J.B.Joshi. So first and foremost, on behalf of all of us, those who are here, as well as those who are online, sir, many, many happy returns of the day. Happy birthday. We wish to also celebrate similar kind of Sahasra Chandra Darshan in appropriate time. So well in advance, we are indicating our wish. I am here to give some kind of instructions and informations and also share the outline about the program. As you know that ICT is a temple of Saraswati. I mean, if you can see at the right hand side, there is a Saraswati idol which is being well maintained here. And UDCT, now ICT, is known as the epicenter of education, excellence. And we are going to see throughout the day different sessions in which different speakers who now have their own kind of a standing in the scientific fraternity, they are here to share their technical sessions. And all common DNA among all of us who are here is ICT. And we are also very blessed that we have special dignitaries who are here. And they will be also gracing the occasion as a chairman for a respective session. So I would like to personally make a mention of Padma Bhushan Professor M.M. Sharma sir. Welcome to the function. And Padma Bhushan Mashelkar sir. And Padma Bhushan Kakodkar sir. Welcome to the function. So you can imagine that there is a heavy loading in this KV auditorium. There are 4 Padma awardees as at this moment of time, 3 Padma Vibhushan and Padma Bhushan, and they will be here. Let me share you some instructions and kind of the flow of the program so that everybody would be well aware. As this program is going live, those who are also online can understand, and those who are going to be speakers, I would request them to see the online so that they may know exactly at what time they need to pitch in. And all those who are there online as speakers, the Google Meet connections and access link already is being given. So welcome again to this program. As we have a Saraswati Ma here, always the goddess and God, they always have their representatives in form of somebody who can do a mentor, who can teach us, who can make us from an individual into a character student or a professional. So I think there are 3 strong representatives which are here in form of Professor Sharma, Dr. Mashelkar and Kakodkar sir. And we also have our beloved Guru, J.B.Joshi sir here. As far as individual understanding about Professor J.B.Joshi is, I mean, personally, we all know that the most simplistic way of his handling the overall any activity, because it is always said that most difficult thing in life is to be simple. And he is very modest, he is very humble, and we are still learning this from sir. That is one thing. As Dr. Mashelkar always narrates him as a solution engineer, personally I have seen that I'm taking this opportunity to express my reflections about Professor. So he is a solution engineer and he always try to work with different communities, grassroots level people, people at tier 2, tier 3 cities to create a scientific temper. Currently he is also a president of Marathi Vignan Parishad. By the way, as you must be aware, that this entire event is being organized, hosted jointly by ICT, where Vice Chancellor Professor A.B. Pandit himself is here, and Marathi Vignan Parishad, where many of the officials from Parishad are also there. So Professor Joshi is being seen as a solution engineer. He is being working on various research projects. And he always says that look for the pain list, look for the challenge list, go for a social immersion, understand the problems. And many of the current areas of his research is about farming, building the efficiency, and making farming also as a successful profession. So a lot of things many speakers and definitely the dignitaries are going to talk about. So that is something. Now I am aware that you must have all got the kit. That kit contains, as always we being learning from Professor Joshi, taking is always a pleasure, but giving is also a pleasure. So if you see in that kit, there is a book which is being by Professor Joshi. It is being a copy which he wanted each one of you to get it as a climate change. Along with that kit, along with that book, you will have a writing pad. Because after every sessions, there will be some question answers, which collectively we are doing once all the speakers complete their task. So that is there. There is a pen to make the notes. There are some kind of a printouts like this, which will be very handy for you to understand how the program is going. Are we on the time management? So it is like an internal pressure for organizers also, because we are all very clear that every speaker will be given 15 minutes. I also have 15 minutes only. So that we will maintain so that entire event for the program goes with the appropriate flow. In addition to this, there you may find some coupons. These are only as a very basic kind of administrative controls for our catering. So these coupons carry a breakfast coupon, 2 tea and coffee breaks, and 1 of a lunch. It is not mandatory that even if you miss it, but by chance, if it is there, you can keep it handy and it will be well controlled. That is the only purpose. We are trying to make how the event can be better, and we are open to all suggestions. We have also tried to see that this function is not like kind of a very flashy, the way, we wanted that to happen in a typical ICT way, simple, homely. So you will now see that if you look at the program schedule, there are 4 sessions which are there in the program. And I have also shared the soft copy to all those who are live from different places across the globe. So first session after my kind of opening remarks will be with session 1, where we will have Dr. Kakodkar sir as a session chairman. And there will be 4 speakers. First speaker to come up is Dr. Kinshuk Dasgupta. Second to follow is Professor Yogesh Joshi. And there are 2 other speakers who are online. One is Professor Samir Mitragotri from Harvard, and then Vivek Ranade, one of my contemporary, my good friend from Ireland, University of Limerick. So this is how the flow is. As far as the overall structure about the every session is, as in the entire day, there are 4 sessions. First session, second session will be all technical papers. Each speaker, as the schedule program depicts, he will come up. I will give a small introduction. Looking at the time management, I will be giving only excerpts out of their introduction. And then the speaker will be given 15 minutes. He will be making the presentation from here. One presentation support system always will be here from organizer's point of view. After the end of 15 minutes, we expect that the entire completion of the presentation will happen. And at that time, the session chairman will felicitate that respective speaker. And subsequently, we would request him to go back to the original place of his own sitting. Second speaker will be called upon, introduction, presentation. Likewise, all 4 speakers, online, offline, whenever they complete, then I would request them to come up to the dais, and then we will have a question answers collectively. And then would request the respective chairman of that session to do the narration and the summarization parts. So entire session is of 90 minutes, first session, second session. After 2 sessions, then we will have a lunch break, if you can see the schedule. And then there is a third session, which is very special. For the second session, we will have Dr. Mashelkar as a session chairman. And for the third session, Sharma sir would be the session chairman. And there will not be any presentations. Because the people who will be standing itself is an identity. They are all industry speakers, owners. So they will talk about their kind of an experience and how the organizations is being benefited. And as you will all agree that all great people who are in the first row, they are directly and indirectly doing nothing but the nation building. Because if we are in a position to create a scientific temper and develop something out of a simple student, I think we have many speakers who reflects about what I am telling about. So they are going to validate about what ICT and the teaching has been from these great gurus here. So likewise, the third session would be about from the industry people. There also the number of people who will be coming there, they are all there. Only Ravi Goenka sir is traveling, so he is on the way from Europe. So he has updated us. It will not be possible for him even to join online. After that, we will have the last break for the day, tea break, after the third session. And the fourth session is like a homely kind of some informal. And there we will have the sir's family members, some surprise element you will see who will be also speaking there, which is very close to sir. And then subsequent to that fourth session, number of speakers would be there. Again, there is no presentation. And at the end of it, there will be a felicitation function, which will happen. And 3 Mahagurus, all 3 Padma Vibhushans would be doing the honor together. And subsequent to that, there will be a response speech from Professor Joshi. In between, we have 1 or 2 book releases, which at appropriate time I will do the announcements whenever that event is happen. So that is all about the overall outline of the program. If I believe the time is 2 minutes still. So if at all there is any doubts, our volunteers will be here at the corners. So any point of time, couple of ground rules, which also I must tell you. In addition to the KV auditorium, the next classroom we have taken additionally, because we expect about 160, 170 participants as the day progress. There also, entire streaming is going live, audio, video at a real-time way. As far as the infrastructure is concerned, next to the classroom, there is the restroom for the ladies. If you go ahead, there are appropriate visual displays and the direction marks which are being given. There's a washroom, restroom for the gents. Additionally, there is behind. I would also like to bring your attention, and if you can take a time whenever there is any tea break, coffee break, or a lunch break, organizers and the volunteers have taken a lot of efforts. There is a rangoli which is being made yesterday night by an artist. There are a lot of visual displays which are also being done, where you will find a photo collage at about professor's overall lifespan as an academician and as well as in personal space. Then you will find couple of posters about him. There will be one display because some of professor students have given a gratitude note about gratitude is the best virtue. So that also we wanted to display. That is also displayed at one corner. There are schedules which are being displayed. And there are LCD wherein every program is getting also flash with respect to the posters, displays. So those who want to understand when what program is happening, everything will be visually displayed. So that is from my side. I don't think I have missed anything. If it is there, I will appropriately update you. So with this, welcome again to all those who are here offline. Welcome to the special dignitaries and also those who are attending this online. So then now I will open up the session 1. And for session 1, we have 4 speakers. First one to make the speech is Dr. Kinshuk Dasgupta. So Kinshuk Dasgupta is very much here. And I would request Kinshuk, if you can, please, please. I request the chairman of the session, Dr. Kakodkar sir, if you can please take. Will it be okay? Yeah. Yes, presentation. Okay, sir. So he can watch it. Kinshuk, please come up here. I'm going to make 1 minute to give a small introduction about Dr. Kinshuk Dasgupta. Dr. Kinshuk did his B in Metallurgy and Material Science from Jadavpur University. He did his PhD in Chemical Engineering, of course, at the same temple, ICT, under the guidance of Professor J.B.Joshi and Professor Sri Kumar from BARC, Sri Kumar Banerjee. He then also visited University of Cincinnati as a visiting scholar. Lot of research interest. One is carbon nanomaterials, composites, coatings. With his standing, he has to his credit more than 130 research papers in international journals, around 80 plus conference papers, 2 book chapters, 2 patents. Awards. He is also recipient of Shanti Swarup Bhatnagar Award in 2020, Young Metallurgist of the Year 2007 Award from Ministry of Steel, Young Engineer Award in 2012, Scientific and Technical Excellence Award in 2017 by Department of Atomic Energy, DAE, N.J. Suchak Innovation Award 2019. By reading this name, it also becoming bit very personal to me because Suchak, Naresh Suchak, Professor J.B.Joshi student and a contemporary at our time. So we have lost him, unfortunately. So in his memory, there is an award which we are very happy, N.J. Suchak Innovation Award. Dr. Kinshuk is a recipient of in 2019. Distinguished Alumnus of ICT in 2022, Vasvik Industrial Research Award in 2020, and currently is head of Advanced Carbon Material section at BARC and professor of HBNI, Homi Bhabha National Institutes, and he is also chairman of Industrial Carbon Society, Maharashtra chapter. So welcome, Dr. Kinshuk. If at all I have to give more introduction to each of the speakers, like in our college days, I may require a supplement to the answer sheet. So I'm taking some excerpts out of that. I hope you will not bear with me with respect to cutting down the introduction. Kinshuk, all yours, please. I request you to take the presentation, and you are audible, and 15 minutes we would request you to cover. Thank you.
This side is okay. So thank you, Dr. Yoglekar, for the I think it's okay. For the nice introduction, and respected Dr. Kakodkar, session chair, Professor Joshi, Dr. Mashelkar, then Professor Sharma, Professor Pandit, and other dignitaries, Madam also. And indeed, it is a great honor for me to be the first speaker in front of this August gathering on the occasion of 75th birthday of our Guru, Professor J.B.Joshi. So, as you can see, the topic of my talk is Carbon Nanomaterials, a Journey from Science to Technology. So, I'd like to highlight the journey from 2008, when I got admitted at ICT under Professor Joshi as a PhD student, along with Professor Sri Kumar Banerjee. He was director at that time. And I joined BRC in 2000 when Dr. Kakodkar was director BRC. So just to start with that, where I should this thing? No. Yeah. So I would like to say that carbon is actually a very versatile material, and it can have a wide range of structures and properties. It can be crystalline, that means there will be long range order of the atoms, which can be naturally occurring like graphite diamond, or it can be synthetically made in lab like carbon nanotubes or fullerene. And at the same time it can have non-crystalline, that means where the ordering range is short range. So like soot, carbon black, glassy carbon. And the beauty of this material is that depending on the application, we can tailor the structure and the property. So come to the next slide. So if we see the building block of all these carbon materials, which are mostly sp2 hybridized, is called graphene. Graphene is a single layer where the carbon atoms are arranged hexagonally in a planar form, and then if we stack them one above another like AB kind of stacking, we end up with graphite. If we can roll them, like if a single sheet is rolled, that is called seamlessly, that is called nanotube, because the diameter is in the nanometer range. So this is called single wall carbon nanotube, and if there are concentric multiple tubes, they are called multi-wall carbon nanotube. And again, if we can give a carving like a cage-like structure or football-like structure, we end up with fullerene. And again, we can add some kind of heteroatoms like oxygen. So it is called oxidation of the graphene structure, and we call it graphene oxide. So I would like to show these are the carbon nanomaterial family what we are working on, and mostly I will be concentrating on carbon nanotubes and graphene. So next slide please. Now if I compare the properties of all these carbon forms, if you see the last column is steel, because steel I have kept, it is the material which every day we use. We can easily compare, we can have an understanding that how much with respect to steel the different properties vary. So see the strength with respect to steel, carbon nanotubes are having almost 10 times higher the strength, and then graphene is almost 60 times higher the strength. And another last is that density. See, density steel is almost 7.8 gram per cc, whereas carbon nanotubes in the range of 1.2 to 1.3, maximum 2, that is the graphene. So the specific strength, that means strength per unit weight, is enormous for this material. And for this reason, we get different kind of, next slide if we can. So we get different kind of application of this material, but now as I told, my focus will be mainly on two materials, carbon nanotubes. So carbon nanotubes, there are various methods of synthesis of carbon nanotubes, but out of them the CVD method, that is chemical vapor deposition, that is the most attractive method because it is scalable. So for a CVD method of carbon nanotube preparation, you require a carbon source like hydrocarbon, you require some catalyst, generally in the nano form, which is mostly transition metal and their alloys, and you require a catalyst support material to disperse this nano catalyst so that they don't get agglomerated. People generally use alumina, magnesia, silica, zeolite like this, so porous kind of materials. You require a carrier gas so that you give a proper dilution of the hydrocarbon, and then you require temperature to give the necessary kinetic, overcome the kinetic barrier. So next slide please. So now this is the starting point in 2008 when I came. By that time people used to make carbon nanotube in lab in very small scale, milligram scale and all those things. So we thought of using fluidized bed technology because of the fact it can have high solid and gas interaction area and good throughput. So we designed a fluidized bed to make carbon nanotube in larger scale. And then to start with, so in the lab scale what we did, we studied various parameters, like these are the carbon sources we used, acetylene, support material as carbon black. There is a beauty in choosing carbon black as the supporting material. So you need to choose a support material which should be nano in the primary size range, but at the same time they must be fluidizable. So carbon black is a material where the primary particle size in the range of 30 nanometer, but they self agglomerate into soft agglomerate in the range of 150, 100 to 150 micron, which is fluidizable. So that is why we use this material. And come to the next slide, and we studies various parameters. Lot of experiments were done. Come to the next slide. And then what we found, we proposed there are 11 steps in the fluidized bed synthesis of carbon nanotubes. Few of them are related to mass transfer. Then for 4 to 9, these are related to chemical reaction, and then again mass transfer. So we proposed various mechanisms. Next. And also we developed mathematical model related to different steps, and then finally we could found out that what is the rate controlling step. That was the most important at that time, because if you can find out that, then it is easy for the scale up. Then can you please come to the next slide? So here you can see if I plot at two different temperature ranges, like up to 800 degrees centigrade, it is kinetic control, chemical reaction, and then above 800 there is a diffusion control for the synthesis of carbon nanotubes. Next. And based on that, we could make a fluidized bed reactor which can produce 1 kg per day nanotube. It is there at BIRC, and it is still producing, which can cater all the need of the DA. And if you see here, the image is not good, but if you see that slide, screen, you can see the carbon nanotube TM images I have given, transmission electron microscopy. If you see naked eye, carbon nanotube is like a powder. It is a black powder, but then if you see under microscope, you can see the tubular structure, and then in high resolution microscope, which is the third one, you can see the number of walls. We could show up to 8 to 13 number of walls are there. These are almost 15 to 25 nanometer diameter, length in the range of 30 to 500 micron, and purity in the range of 98%. Now once we got these are powder form. So my PhD ended there almost, where I could develop a fluidized bed reactor. We could propose the reaction mechanism, we could do the scale up. But then what next? This program went on. Then next, no, come back to the last slide. Yeah. So we started doping of carbon nanotube with different heteroatoms. Like here you can see the nitrogen doping. The next student from ICT joined BRC lab, Anita Sharma. She, along with my lab colleagues, she continued. So we could dope nitrogen, disperse palladium over that. The application was for the accidental release of hydrogen from the nuclear reactor. And we could show that with doping of nitrogen, the hydrogen storage behavior improved. Come to the next slides. And again we went on doping. No, next slides. So in the next slides you can show we then went for the boron doping. Boron doping, Srilekha did the job. She is there. So wonderful work she carried out. And by boron doping, we could show that much improvement in the hydrogen storage. I have given the comparison, and then we could publish in a very good journals. Come to the next slide. And then what are the other applications of this powder nanotube? So far we got the nanotube in the powder form. So a very important application is the rare earth. You know, rare earth is a strategic material. India is working on that. There is a country which dominates the rare earth. So we tried to develop carbon nanotube polymer composite beads for the separation of the rare earth from a lean solution. So these are some of the composites bead where carbon nanotube was added in making the bead, and in the hollow core, if you see, in the hollow core, we entrap the DEFA. DEFA is, which is very much specific to rare earth, the extractant. Can you come to the next slide? Yeah. So here I could show that with the addition of carbon nanotube, small amount of carbon nanotube, which is 0.25% CNT in the composite beads, along with DEFA, for the yttrium is a representative rare earth. So we could show the separation of the yttrium went up to almost 6 times with respect to that where no carbon nanotube was added. Next. So similarly, we could remove the Nd. Nd is neodymium from the scrap magnet by using functionalized carbon nanotubes. Here I am showing the scheme and as well as the TM image of this neodymium nanoparticle which we could recover from the that magnet scrap. Next, come. So similarly, from the BRC perspective, we could separate actinides also. So the carbon nanotubes were functionalized with specific group, like here amidoamine. So we could show that by functionalizing with specific ligands, you can separate out like americium, then plutonium, all these things from the solution. Next. So I showed that how carbon nanotube, functionalized carbon nanotube can be used for the separation science. Then we used carbon nanotubes as a powder material as a reinforcement in the composite. So how we can improve the property of the composites. Here in the ceramic what happens, ceramic is a very strong material, but the disadvantage is the fracture toughness. So by adding carbon nanotube, we could retain the hardness of the ceramic, improve the flexural strength of the ceramic, and fracture toughness to almost double. And by that way, how we utilize that property, I will come in the next slide, come to that. So we showed that the crack propagation behavior changed. Like if the crack in the ceramic, it goes very straight like this, and the failure is easy. But by adding the carbon nanotube, you could bridge the crack, branch it or deflect it or bridge it, and by that way the energy is dissipating in that these activities, and the fracture toughness improves. Come next slide please. Also we disperse carbon nanotube in the polymer matrix, like we took ultra high molecular polyethylene. I would show the exact application of that. And we made ultra high molecular weight polyethylene and CNT composite, and we showed that how carbon nanotube improved the stiffness of the this composite. Next, come. By using these two, that is carbon nanotube boron carbide and then carbon nanotube polymer, we made a bulletproof jacket called Bhava Kavach, and I want to just show the result. This is the Bhava Kavach. And this is that time what CISF used to use the bulletproof jacket. And this is a test where this is a plasticine. Plasticine resembles our body muscles. And by the shot of the bullets, see the dent. So these are called backface signature. So by addition of the carbon nanotube, see the dents, it has come down heavily reduced. So in the next image, you can see here in the next slide. No. Come back to the last slide. So here we showed after pumping 3 AK-47 hard steel core bullets and 3 SLR. So all these bullets were trapped by this called hard armor panel made up of boron carbide, carbon nanotube and polymer composite. Next slide. And in further details, even 8 bullets were pumped, and you show this. The bullets are trapped. These are the X-ray radiographic image. Bullets are trapped inside the armor panels. And come to the next. So we showed that comparison, that how the ballistic performance improved when we used carbon nanotubes, and we gave a comparison when carbon nanotube was not used. So even if the bullets are stopped, there is another parameter that is called the thirst or backface signature. So if that is very high, then also the user they can die if the impact is heavy, because it can damage your internal organs. So carbon nanotubes also reduce that backface signature, so it could minimize the protrusion backside. So that also we could show, that is we could show that if you compare them, these are highly reduced. These are almost negligible amount of the backface signature. Come to the next. So this was publicized that time in the media. Next. And also we gave this Vava Kavach, next come, for the CISF who are at BARC. Come next. 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 So we gave to the different forces. The Bhava Kavach was given to different forces. If you see all the Northern Commands and other DSF, CRPF, NSG, everybody did their field trials. Next. And TOT of Bhava Kavach also given to several companies. Now, so far I was talking about the powder form of carbon nanotube. But what it does, can it utilize the actual potential of the carbon nanotube? No, because the actual potential is in the nano dimension. If I use them in the composite, the matrix property is enhanced. Not we are utilizing the actual property of the carbon nanotube. So we need to make a macro structure only out of carbon nanotube if we want to actually utilize its full potential. If you remember, I showed that diffusion was a barrier at high temperature for the synthesis of carbon nanotube. The barrier was removed by a process called floating catalyst chemical vapor deposition, and by which we could make a macro structure of carbon nanotube. Here I have shown the actually what is the mechanism what we proposed recently, and here Manish is there, who is also assistant professor at ICT, who did lot of work on this when he worked at BRC under Professor J.B.Joshi's guidance, along with me in my lab. So next, come to that. So here I would like to show one video. If you see that this tap-like what is coming, this is called carbon nanotube aerogel, where this long carbon nanotubes, they are self-assembled and entangled to one another. In the gas phase, they are coming, and we are basically collecting them inside a globe box on a drum. Next, come. Yeah. So we get a sheet like this. In this sheet, these carbon nanotubes are self-assembled, only carbon nanotube. They are aligned in a particular direction. We can give a randomness also depending on the processing parameters. And this sheet we have used in sensors, in filters, in mask, in EMI shielding, and also in ballistic. I have shown the microstructure of these tubes. The nanotubes are here randomly oriented. We can give a directional property also. Next. Come to the next slide. Yeah. Even we could convert this carbon nanotube, fine carbon nanotube, into fiber, which is continuously kilometer long fiber, and I could show the fiber is highly strong fiber. This is almost 700 gram weight. With the fiber we can, and it is a highly conducting also, high strength, high electrical conductivity. Yeah, isko play kijiye. So this I would like to here. So we are glowing a bulb by using the carbon nanotube fiber from a USB port. So I wanted to show that this is highly conducting. Next. And recently we are using this carbon nanotube fiber for making composite for the application of the windmill. Professor Joshi also gave us lot of importance to these activities. Here I want to show, this is called, time is up now. This is the last, I think last slide. This is FIB image. FIB means focused ion beam. So through the focused ion beam, you cut a particular portion, and you see here, you see the across the thickness how things are distributed. So in a ACM, that is scanning electron microscopy, here I wanted to show the network of carbon nanotube and the polymer. Next. So we also worked on graphene. Manish is there, he made this one, fuel layered graphene by CVD. Then still we are working on 3D graphene. 3D graphene is having lot of application for energy storage as well as desalination purpose. And Pratiksha is there, who worked on graphene oxide, and then we made graphene flower kind of thing. Next. And very good application of graphene oxide is in the concrete. This is a very good application. We added very small amount of like 0.05 weight percent of graphene oxide in concrete, and we could show almost 40% improvement in the compressive strength, very good improvement in the fire resistance of the material. So with this application, as the time is not there, I would like to conclude. So I would like to say that carbon is a material which plays a significant role in India's atomic energy program. I have not talked about graphite, which acts as a moderator and reflector in the nuclear reactor. We work on that. There is something called triso coating, which is a barrier coating for the high temperature reactor fuel. Carbon nanomaterials play vital role in front-end and back-end fuel cycle, recovering metal ions that I have shown. Doped CNTs I have shown for improved hydrogen storage. Then carbon nanotube reinforced ceramic matrix and polymer matrix that I have shown and showed their ballistic performances. Then fluidized bed CVD for large-scale synthesis. And carbon nanotube sheet and fiber, that's a macroscopic structure. These are the futuristic material. So these also we are working on that. And then graphene oxide that showed a huge potential in the cement, means concrete, improvement in the strength of the concrete. So I'd like to, before I finish, I'd like to acknowledge the contribution of my team members and the ex-PhD students. Manish is there, Anita, just backside here. So these are the current research associates and PhD students, also the collaborators and BRC and other institute, and my mentors. And above all, next slide is definitely Professor J.B.Joshi, who started my hand-holding from 2008. Still he is there with me for my each journey. And thank you, sir, for that. And thank you all for your kind attention.
Thank you, Dr. Kinshuk. We really appreciate the kind of work and innovation which this entire research work has given us to the country by use of carbon nanotubes. And we are all aware, because all dignitaries over here always make a mention of this bulletproof jacket. And not only it is being given and handed over to the army, Indian Army, but we are now in a capability of exporting these also to various countries. So round of applause for this great work. Couple of compliments personally, which all you must have observed. One is, as I said in the beginning, gratitude is the best virtue. He makes a point to refer to each of his research collaborators, and he made a point to see that his slide also remains for some time about the people who've been working with him and who had worked in the past also. So I request the session chairman, Kakodkar sir, to felicitate Dr. Kinshuk. Kinshuk, can you please? We will have a photograph. Volunteer will. So there is a memento from Marathi Vigyan Parishad, a traditional way of giving something which you know it, very scientific gadget, and a dry fruit basket. Great. What we will do is, as I said in the beginning, all the questions for respective speakers, we will park it for now. And maybe once in the session, all the 4 speakers complete their part, we will collectively take the question answers so that, there is a continuity and we manage the time also. Great. So as Professor Joshi and all Mahagurus and dignitaries always talk about, India has to grow up in the innovation index and happiness index. I personally feel that the first chapter technical session was apt with respect to what really innovation is all about. And India is really turned into a Bharat. So great. The next speaker I would like to request is Professor Yogesh Joshi. I would request him to come up to the dais from IIT Kanpur. And after Professor Yogesh Joshi's presentation of 15 minutes, I'm sure Professor Samir Mitragotri from Harvard, you must be online there from Harvard. So it will be next for you, a small intimation so that, there is no technical snag or something like that. So I would like to introduce in brief Professor Yogesh Joshi. Professor Yogesh Joshi from IIT Kanpur, he has done his BE from Pune University in 1996. He did his PhD in chemical engineering, NCL Pune, along with IIT Bombay in 2001. He did his PhD under the guidance of Padma Bhushan Dr. Mashelkar. He is also adjunct professor at ICT, where we are all here. He also did his postdoctoral fellow at Benjamin Levitch Institute at New York. He joined IIT Kanpur in 2004 and currently is Sir J.C. Bose Fellow and Pandit Girish and Sushma Rani Patak Chair Professor at IIT Kanpur. His research interests are in the areas of rheology, rheology of complex fluids, colloidal glasses, clay dispersions, polymer science and engineering. He is a senior editor of Langmuir. He is on editorial board of some of the great international journals like Physics of Fluids, Journal of Rheology and on. The awards, he is the another speaker who is also Shanti Swarup Bhatnagar awardee 2015. He is also fellow of Society of Rheology, USA. He is also fellow of Society of INSA. He is also fellow of INA Engineering, Indian National Academy of Engineering. He is also a fellow of Academy of Science. He has a lot of interactions, intense interactions with industries. So the person who is an expert in the rheology of complex fields, but simple in his living and academic profile, Dr. Professor Yogesh Joshi, please.
Thank you so much. Let me begin by conveying my namaskar to Professor Sharma, Dr. Mashelkar, Dr. Kakodkar, Professor Pandit, and of course today's Utsav Murti, Professor J.B.Joshi. I'm not a formal student of Professor Joshi, but just in a formal way. I happen to be his nephew, and ever since, of course, I have gained some consciousness or some kind of understanding, little bit happening around. I have been hearing stories of his greatness from everybody, but more so from my grandmother. And she used to tell so many stories. And ever since I have started understanding, I have been in awe of his stature. Then eventually, of course, I completed my engineering and joined PhD with Dr. Mashelkar and Dr. Lele. And the person who was his nephew by relation became his nephew by academics. So I was born in family of Joshi, but then by PhD I got into academic family of Professor Sharma. And that is how it became, and then of course got very closely associated with ICT also. So okay, I had written many things to read actually, but now with such an audience, I'm also getting anxious and I'm forgetting. So what do we learn from Professor Joshi? So two aspects particularly I mentioned. His extraordinary capacity to do hard work. So whenever I visit Mumbai, he's busy up to 10 o'clock in the night. Even though I get tired, he doesn't get tired. And that is something that one should, at his age, so one should learn from that particular aspect. One should learn that aspect. Second thing is of course, all of us know that he's almost a saint. And huge humility. So that is something that also I happened to kind of learn from him. And when I was young, when I was in my teens, I needed his advice. When I got in 20s, I needed his advice more. Now soon I'm going to get into 50s and I'm going to need his advice even more. So that dependence actually is kind of growing as far as his guidance is concerned. So with this, let me come to the academic talk that I'm supposed to give. Can I have a presentation on that one also? Okay, so Thixotropy is something which my group is working on for last 20 years. And now somebody will say that why somebody is working on the same problem for 20 years. Because it happens so. Thixotropy is a 100-year-old problem. It's reinventing itself in every decade, and more so in last 4 or 5 years. And now Thixotropy has become a buzzword in rheology research, and more so with advent of 3D printing. I'll show you how, I'll tell you how the 3D printing is very closely associated with Thixotropy. But before going to Thixotropy, let's talk about yield stress fluids. Can I have presentation there? Okay. Oh, okay. And all of us know, and when any chemical engineer, he is introduced to yield stress fluids, first thing that comes to mind is toothpaste. All right, so a small experiment over here. So what you do over here is that you take toothpaste and you just hold it upside down and you see that nothing comes out, because a certain minimum amount of stress has not been overcome, so it doesn't flow. But when you press on the tube, you realize that material does come out. Has it stopped? Sorry. Problem with these new gadgets is when you want them to work, they don't work. Okay, it's not working. No, if something is problem is with my, yeah, now it's working, yeah. And you can see that when you press upon it, the material is coming out. All right, so this is a very simple experiment that anybody can do. These materials are called yield stress fluids. All right. Okay. So who invented yield stress fluids? He's also called father of rheology. His name is Professor Bingham. In 1916, he published this very famous paper wherein he introduced yield stress fluids, or the observation of yield stress fluids, and the corresponding law, of course, is known as Bingham law, and all of us in chemical engineering fraternity know about this. So he essentially introduced the concept of yield stress. He did series of experiments on clay dispersions, and he observed that a certain minimum level of pressure is required to make these particular clay dispersions flow. And he distinguished plastic flow from viscous flow by need to overcome some finite friction. All right, and this is a very famous fluid, and this is the typical constitutive relationship associated with this, which simply says that below the yield stress, material has infinite viscosity. In other words, material is actually elastic below the yield stress. Above the yield stress, it flows. If it flows more rapidly, means it's shear thinning in addition to flow, then we'll call it Herschel-Berkeley, and Herschel-Berkeley published this particular paper in 1924. Both these models are very popular. All right. Now let's try to understand what is the origin of yield stress. All right. So any soft material like toothpaste, like various kinds of creams that we use in our day-to-day life, material possesses yield stress because there is an inherent structure in that particular material. And when that structure cannot be broken with applied stress, material doesn't flow. The moment the stress is able to break the structure, material starts flowing, and that is what we call yield stress. Thermodynamically speaking, these materials are out of thermodynamic equilibrium, and that is a new angle that is now coming in picture as far as studying these materials are concerned. Thermodynamics of these materials. So every yield stress fluid is thermodynamically out of equilibrium fluid. All right. Now, if the constituents of this particular fluid are athermal in nature, athermal means by thermal motion there is no thermal motion, then it's a dead material. It does not evolve as a function of time, and it's in quasi-equilibrium state, it remains there forever. But if material has thermal properties, which means that it can undergo thermal motion, Brownian motion constituents of the same, then any out of equilibrium material will evolve, all right? And that yield stress fluid then transforms itself in something called thixotropic. So this is how thixotropy is born out of the yield stress materials, all right? So what is thixotropy? A thixotropy is that property wherein material evolves as a function of time. These are inherently out of equilibrium materials. They evolve as a function of time, and when you apply deformation field, that evolution goes in the opposite direction. So structure formation under quiescent conditions, stationary conditions, and under application of deformation field, structure breaks down and they come back to the original position, and that is shown here by a cartoon. You can see here that the structure formation is taking place in this direction, and application of deformation field essentially breaks down that particular structure. Okay. Now this is a typical method is used in today's 3D printing. What does 3D printing do? When the material comes out of the capillary, you must make it flow. So that fluidity has to be there when the material comes out of the capillary or the needle of that particular 3D printer ink. But once it sets on the surface, it must become solidified. All right? And that is the thixotropic property, and thixotropy is an inherent aspect of any 3D printer. All right? So this is a simple demonstration of thixotropy. Now, thermodynamically speaking, these are out of equilibrium materials, and any out of equilibrium material under constant temperature and pressure must lower its free energy. Under deformation field, when you flow it, when you deform it, it should increase its free energy. All right, so this is a typical thermodynamics. And so how this free energy behaves essentially dictates the nature of thixotropic materials. And based on that, we came up with a simple model in 2015, wherein this is a normalized free energy. This is increase in free energy under quiescent conditions. And this is decrease in free energy under application of deformation field. I shall not go into the details of that, but then free energy is related to relaxation time and modulus. And then we use this into a simple Maxwell model in order to obtain a constitutive equation. This is a simple constitutive equation, which very interestingly shows non-monotonic flow curve. What is a flow curve? Flow curve is a steady state stress versus steady stress strain rate relationship. And when it is a non-monotonic, when it is a negative slope, that simply means that it is linearly unstable. It's a very significant property that now has come forth. And one of the, one of the papers that discusses this particular aspect is this particular paper, that it has a negative slope in the low shear rate direction. It has many consequences and many serious consequences, as I will show you. So, what are the kind of characteristics of thixotropic material? Non-monotonic flow curve. Shear banding. You may think that you are flowing a material and there is a homogeneous flow field inside the flow field. But no, that may not be the case. There may be bands. Some bands may be flowing at a lesser speed compared to the other bands, further causing problems. It has time-dependent yield stress. We just talked about Bingham's yield stress, which was a constant. But these materials show time-dependent yield stress. And very interestingly, these materials show stress buildup, which is also a very intriguing aspect of these particular materials. All right, so let's just take a look at these particular aspects one by one. For that, we use a material called laponite dispersion. Kingshuk showed his carbon nanotubes. Apparently, this laponite clay is even smaller than nanotubes. It's 1 nanometer in diameter and 25 nanometer in 1 nanometer in thickness and 25 nanometers in diameter. It has charge inhomogeneity, therefore it forms a network structure. And it's an oblate particle. Nanotubes are perolate particles. And these are the TEM images, and you can see that they form a beautiful network structure, which is of course shown over here by a cartoon. And what happens is something quite dramatic. So you take laponite, extremely small concentration of laponite. 3 weight percent means 1 volume percent. So I'm adding 1 volume percent laponite in water. And 99 volume percent is water there. Those who do not understand other things that I'm talking about, just look at this. 1 volume percent of this clay, 99 volume percent of water. After 10 minutes, material becomes so transparent that you will not be able to differentiate it between pure water and this water and this dispersion. And then we put that in a plastic foil, and after 8 hours, it becomes so stiff that 99% water gets converted by just addition of this 1 volume percent of clay into a soft solid. All right, and we have done independently a lot of work on this particular aspect, but this system happens to be thixotropic in nature, and that we show in this particular next video, wherein as you can see that this is again very close to 1 volume percent, and when you put it upside down, it doesn't flow. And you apply deformation field. Deformation field is a very typical scientific jargon, which simply means that you shear it. You put a rod in it and shear it, and it becomes liquid. Again, it has 99% of water, so it flows. And then again you keep it on your shelf for a while and you realize that it has again solidified. This is the thixotropic property. All right? And so what we observed is that it shows this particular non-monotonic flow curve, which means that if we shear material in this particular region with applied stress less than this particular minimum stress over here, which means there is no steady state shear rate associated with this, which simply means that the viscosity of material should just keep on increasing. In other words, shear rate, the rate at which material flows should keep on decreasing. And so for stresses below this, in this case 7 Pascal, material starts simply becoming solid, but above that stress, material starts flowing. Okay? This phenomenon is called viscosity bifurcation. Model also beautifully predicts it, and our Laponite dispersion also beautifully shows it. So this is one of the signatures of thixotropy. The other one is time-dependent yield stress. So we just saw this particular yield stress value. It's 7 Pascal associated with 50 minutes. But if we do this experiment at different times, then you will realize that the yield stress starts increasing beyond a certain point. That's also a characteristic feature of the non-monotonic flow curve, but that's a more detailed topic. And our model, which we published in Soft Matter in 2015, predicts this particular behavior beautifully. Now I come to this particular very peculiar phenomenon. So what is done over here? You take a material and you shear it, and at some point just stop that particular shearing. Okay, material has stress built in it, and when you stop shearing, stress starts relaxing. Usually for all materials which we come across in our day-to-day life, stress relaxes. All right? If material has significant solid content, then it may show a residual stress. What we observed is stress build up, stress decreases, and then stress starts increasing again. And that 2015 soft matter paper that I showed, it was the first paper to theoretically predict this particular behavior, which we later observed experimentally. And when I presented this, the senior scientists in the rheology community, literally speaking, they questioned my findings, and they told that if such thing happens, such state buildup happens, then it's violation of the second law of thermodynamics. So before publishing this result, I had to worry about taking care of that violation of the second law of thermodynamics. And a couple of years back, we published this particular paper where we show that such stress buildup does not lead to violation of the second law of thermodynamics. Now I'll come to the final part of the presentation, and that is which is related to 3D printing. What is 3D printing? 3D printing is essentially, it's like an injection process. In the barrel of that particular injection syringe, you have material. You push that particular material through some kind of a syringe. That material comes out of the needle and it solidifies on certain substrate or surface. That is 3D printing. So the most apt 3D printing is a rheological topic. All right? Capillary rheometer, which is of course an age-old technique, we manufactured this particular in-house capillary rheometer, a simple injection syringe. You monitor rate, which leads to gamma dot. You monitor pressure, which leads to stress. So this is capillary rheometer. All right. Now, if a material has non-monotonic flow curve, then if you are applying shear rate in this region, then of course you are expected to get a steady behavior, which any student of fluid mechanics will tell you. But if material has non-monotonic flow curve, then there will be a shear rate below which you will not get a steady flow, and beautifully we observed it for this Laponite dispersion. So below a certain shear rate, it shows flow oscillations, which means that a steady shear flow cannot be maintained. Again, confirming that material indeed has non-monotonic flow curve, which actually we predicted in 2015 in our soft matter paper. For another Laponite dispersion, this is what we observed, that it undergoes flow oscillations. What are the take-home messages? You have to be extremely careful if you want to do commercial 3D printing. If you have thixotropic material, and by tuning some properties of it, the thixotropic material becomes non-monotonic, then if you happen to print with low speed, then keep in mind that you are going to face obstacle in printing. It's going to undergo oscillations. It will show various kinds of instabilities. All right, so these are the aspects which come out from the fundamental study that one should keep in mind. So with this, let me conclude. Of course, I'll not go into now the definition of thixotropy, which simply means that it's structural evolution under quiescent conditions, stationary conditions, and structural breakdown when there is flow. It shows these very peculiar behaviors like non-monotonic flow curve, time-dependent yield stress, pressure flow oscillations, stress buildup, a very critical behavior that we observe. So therefore, before trying any thixotropic material for applications, particularly for 3D printing, a very careful rheological examination is necessary. That is essentially the take-home message. And this is my group. And I thank you so much for your attention. Let me again say namaskar to all the dignitaries and Professor Joshi. And again thank organizers for giving me opportunity. Oh, yeah.
Thank you very much, Professor Yogesh Joshi. It was indeed a very interactive session, very much with full of your commitments to the subject. Can I request the session chairman, Dr. Kakwadkar sir, to felicitate Professor Yogesh Joshi with our memento of a microscope from Marathi Vigyan Parishad and a dry fruit basket. Thank you. As said earlier, we will park all the questions and maybe after all the 4 speakers complete their presentation, then we will collectively take all questions, answers, and then afterwards I would request chairman then to do the summarization part. Well, the third speaker is attending this event online, Professor Samir Mitragotri from Harvard. Samir, can we see you, AV person? Can we see Samir here online? Can we get him online? Yes. Good evening, Samir. Good evening. Professor Samir, can you hear us?
Yeah, can you hear me okay?
Yes, please. We are connected well. We are connected well. So thanks again for attending this from that place. I know you just reached Harvard. You were in Korea yesterday as the visiting person, and good evening again to you. Professor Samir, just to give a brief, there are 3 dignitaries who are already there and they would be also equally eager to see your presentation. Professor Sharma, Dr. Mashelkar, Dr. Anil Kakodkar, and of course J.B.J. sir. I am going to give a small brief introduction about you and then I will hand it over to you for taking up your session for 15 minutes. Is it okay, Samir?
That sounds great.
Yeah. So let me introduce Professor Samir Mitragotri from Harvard. PhD from Chemical Engineering, MIT, USA in 1996. Before that, Bachelor's in Chemical Engineering from a Temple of Excellence, ICT, 1992. He is a global leader and pioneer in the field of drug delivery. His research has led to many new technologies for treating ailments like diabetes, cancers, and on. To his credit, he holds 400 plus research publications, like in the magazines internationally renowned, like Science, Nature Medicine, Nature Biotechnology, and on. His research has been cited over 67,000 times. So H index is of 129 for Professor Samir Mitragotri. He has given 500 invited lectures at various countries, universities, conference. Day before he was in Korea for the same. He holds exceptional record of innovations and commercializations. And these 2 terms are very, very close to the heart of Professor Joshi. What you do for the society, what innovation index you carry, and how we can scale it up. So Samir also is exceptionally high in the record of lot of innovations and commercializations. He is an inventor of more than 225 patents. He has co-founded 14 companies, including Sontra Medical, FQueb, I may be wrong in pronunciation, please bear with me, 7th Biosystems and many on. His laboratory has a strong record of training graduate students and even postdocs. He has trained 130 plus graduate students. The awards and accolades which Professor Samir holds, he is a recipient of being member of US National Academy and Engineering, NAE. He is a member of US National Academy of Medicines. He is a member of US National Academy of Inventors and many on. He also received Edison Award for Innovation. He is an effective leader and he is also a founding director of UCSB, Center of Bioengineering. He is a chair of bioengineering at Harvard. He is a board member on several companies. So I will stop here because I don't want to take more time from Professor Samir. Samir, thank you very much for being here online. And please, you can start with your presentations. Thank you, Samir.
Thank you so much, Hemant, for the kind introduction, and thank you for the invitation. My warm greetings to Dr. Kapoor, Professor Sharma, Dr. Marshallkar, Professor Pandit, and the celebrity of today, Professor J.B.Joshi and Madam. I'm sorry I couldn't be there in person. As Hemant mentioned, I was in Korea yesterday, and my daughter's graduation is tomorrow, so I couldn't travel. So I'm calling from Boston. It's about 1:30 in the morning. Absolutely nothing better I would do than participate in this conference and symposium and speak in the honor of Professor J.B.Joshi. The picture you see in front of you is the one taken about 2 years ago when Professor Joshi and Madam visited on the induction into NAE, and had a chance to meet with them in Boston. So I had known Professor Joshi for almost 36 years now. I came to then UDCT in 1988. And one of the first things I learned from Professor Joshi was fluid dynamics. He taught us fluid dynamics, and that really turned out to be a, can you see my slides advance? Can you see the next slide? Yes. Or is it stuck on the first slide?
Yes, first slide, second slide.
Okay, let's see, cause
now so we can see where first slide.
can you advance? Yeah, there we go. Thank you. Yeah. And that turned out to be a really transformative experience in many ways. At that time, I did not know, but fluid dynamics later turned out to be. Can you go back to the first slide, please? I'm sorry, second slide. Sorry, can you forward to the second slide?
Sir, you need to change slides.
Yeah, okay.
Sir, you need to change slide.
Okay, because from my slide, I see the second slide, but maybe it's not advancing on the screen
Sir,
on
we
your
can see
side.
second slide.
Oh, you said, okay, sorry. That's great.
Samir, we can see that.
Maybe there is a delay.
Yeah,
So I'll just ignore
no problem.
the YouTube feed. Maybe there is a delay.
Control of transition is with you. So, yeah.
Okay, great. So that was a really transformative experience in many ways, which I did not fully realize at that time. But fluid dynamics turned out to be a central part of my professional existence, both in terms of teaching as well as research. When I became a faculty at UCSB, I taught fluid dynamics for 17 years, and I used a lot of learning that I had from Professor Joshi's teachings when I was an undergraduate student. And a lot of my research is based on transport phenomena in the biological systems. I'll tell you a bit about it. So I owe a great deal of gratitude to Professor Joshi for all he has taught us, starting from the undergraduate days and the fundamentals of fluid dynamics and transport phenomena. But his impact on me has gone much beyond undergraduate education. I have learned so much from him, uh, see him preach and practice his principles. And I wanted to highlight three things which I learned from him, which I really found to be extremely helpful in my life, both professional and personal. The first thing I want to highlight, if you can see the next slide, is what I call chemical engineering dogma. And what I mean by that is when Professor Joshi used to teach us in the classroom the fluid dynamics, the physics of fluids, how do molecules move, how can we fundamentally predict what molecules do.
So please slide show.
Can you see the next slide?
Yes. Sir, do slide show.
Yeah, so I'm doing slideshow on my side. Not sure why it's not showing up on your side. Are you seeing the slides? Okay. So in the classroom, we were learning about the basics and the really fundamental details, and that turned out to be quickly complex depending on the system. And when he would leave the classroom, he would design the reactors, which were really complicated and really large, and would be responsible for moving millions of gallons of material. And that difference always kind of puzzled me. How do we live in a world where on one hand, fundamentally, it is very difficult to describe the transport properties and the behavior at the molecular scale. At the same time, we have to design systems which can deal with the society's needs at a very massive scale. And that really led to what I think is the key sense of chemical engineering, is that whenever we have a problem in front of us, we try to understand what we can. Those are the first principles. Fundamental understanding is always important. It will always come in handy. But realize that we cannot understand everything. And then we have to approximate what we don't understand, either by correlations or approximations, and appreciate how things are connected. Nothing works in isolation. And when we put these three things together, we can solve problems which are far beyond what we can fundamentally understand. And this learning, which I really gathered from Professor Joshi's teachings, has turned out to be a transformative experience. Because later on, when I started dealing with biological systems, many things in biology are very poorly understood, compared to the physical systems. But having this principle gave me the confidence that we can actually take on the problems which we don't fully understand. And going beyond that, this dogma, I think, is applicable to many situations in life. Heyman mentioned the companies we have started. So how do you go from being an academician to starting a company, and how do you deal with the business world? And I think the same dogma works. We don't have to fully understand everything to get into the problem, but if we approach this problem in these three steps, I think it is possible to take on very complex problems and be able to meet the needs. The second thing I learned from Professor Joshi is the importance of translating ideas into products for societal needs. Professor Joshi, even then, back when I was a student, and even now, is, as you know, tremendously passionate about using technologies to meet societal needs. In fact, when I was a student, the balance between the fundamental science and the application to industry was so well done that I didn't realize that there are two different worlds of fundamental research and applied research. It felt like there was one big continuum. It was when I came to do my PhD at MIT, that's when I realized the world is kind of divided into these two situations, or these two buckets. And it took some time for people to realize that there is this continuum. And in the beginning, when I was trying to convey to people what I had learned and seen Professor Joshi do, it was met with some surprise, because people always thought that academicians study fundamental problem and industry does research, but this continuum was completely missed. It wasn't until mid-2000 when the National Institute of Health introduced the concept of translation in the context of biomedical engineering, where converting ideas into products became interesting and admissible in the academic world. But until then, these two were really separate worlds. So in many ways, I feel that what Professor Joshi was doing in those days was truly ahead of his time, and I'm deeply thankful to him for kind of teaching it us to us and kind of getting this in our DNA. And the third thing I want to highlight that I really learned and admire about Professor Joshi is the power of simplicity. I live in Boston, and about 15 minutes from our house, there is an area called Walden Pond, where Henry David Thoreau lived. And I visited there recently. The picture you see in the middle is a picture of a hut where he lived in a very simple way for a long time. And he was a big proponent of simplicity, and his thoughts went on to influence Mahatma Gandhi and Martin Luther King, simplicity and civil disobedience. And before I was formally introduced to sort of theory of simplicity and theory of simple living, I had seen Professor Joshi practice that as a student when I was a student. And it is very difficult to be simple, right? That's what they say. It's happy to be simple, but simple to be happy, but it is so difficult to be simple, because in the flashy world, it is not very easy to be simple. And what I learned from Professor Joshi is that if you are rich in values, if you are rich in thoughts, if you are rich in knowledge, you can live simply. And I'm deeply grateful for him, because I'm a big admirer of that, and I have tried to follow that in every possible way in my ways of dealing with science and life. So this is a great occasion for me to see this celebration and participate and really share my deep admiration and gratitude to Professor Joshi for all that he has done, and congratulations again. What I would like to spend a few minutes on is talking about what we do. So after learning about transport phenomenon, fluid dynamics from ICT, I switched my research area into the biological systems, and we work in a field of drug delivery. So drug delivery is really the science of figuring out how do we convert molecules into drug products. So if you take any drug product, there are two components. There is a drug molecule, which is the active ingredient, and then there are technologies that really make sure that the drug can reach the right place in the body at the right time. Because if it doesn't do that, the drug can be either toxic or not effective. And those technologies are really engineering technologies, and that's what we've been working on. And the challenge is that the body is not designed to carry our drugs. It is designed to carry its metabolic functions, and they most of the time pose as barriers. So if you take the drug orally, there is no guarantee that it will end up in the blood. There is no guarantee that it can go into the brain. There is no guarantee that it can go into the bone. So we have been working to figure out how these barriers work, what are the principles, and how can we develop technologies to overcome these barriers. And more recently, we have been using body's own cues to figure out and overcome these biological barriers. Now, if you introduce a drug in the body, let's say a small molecule or a protein, these are materials. So they either transport by diffusion or convection. So diffusion is very slow. At the length scale of the body, it is very difficult to rely on diffusion to take the drug where it needs to go. And convection is restricted to the bloodstream. It is very difficult to get into the tissues. So we thought, why not take use from body's own cells, the immune cells, which are very effective in overcoming these barriers. These immune cells, there are 6 of them listed here. These are body's own immune cells. They are very capable of getting into any tissue they want. they have their own properties, and collectively they are responsible for health and the disease. So when they're working fine, the body is healthy, the body is fighting infections, it is fighting cancer cells, it is fighting trauma. But when they stop dysfunctioning, infection takes over, cancer takes over, autoimmune disease takes over. So we started using these cells as body's own transportation vehicles, and we designed a system that we call backpacks. So backpacks are polymer patches. So what you see in front of you is as an electron micrograph of a T cell, one of the most important immune cells in the body, that is shown in purple. And on it is a polymer patch about the same size of the cell that we call backpack. And the backpack has the right cues in it. We use cytokines which tell the cell to get activated when it wants to. It has the cues to deactivate when we don't want it to. And this backpack goes for a ride wherever the cell goes. And because the cell can get into the tissues that it wants, the backpacks can go as well. So by using these backpacks, we have designed strategies which are very effective in treating cancer. We have designed strategies which are very effective in treating traumatic brain injury, which is a very common disease worldwide. We have used these backpacks to treat multiple sclerosis, autoimmune indication. So all in all, you can see these backpacks as a way to train the immune system and make sure that they do their function they intend to, or they need to, so as to control the disease outcome. So we have shown over the last few years that these backpacks work very well with multiple cell types. We have worked on in different animal models, and currently we are looking to advance this technology into humans for treating multiple indications from autoimmune diseases to cancer. So we are hoping that we can get there over the next few years. So let me end here again by thanking Professor Joshi for all his teachings over the years. This picture I had taken in my latest visit to ICT in January. This wonderful corridor reminds me of my wonderful days at ICT. Many students like me have walked in this corridor, have learned from you, Professor Joshi, and on behalf of all of them, I want to thank you for all your teaching that have been extremely helpful to us in professional as well as personal life. Happy birthday. Thank you.
His personality and teaching has impacted in your personal and professional space. Thank you for being here at the event. I understand it is a midnight around at your place, and thank you for being all the time waiting for this. We will definitely miss you. If at all next time when you come, we are having a felicitation to all the speakers, but as you are on the online, we will really miss that part of it. Thank you very much again. The next speaker which we will take it on the online is Professor Vivek Ranade. Professor Vivek Ranade, can we get him on the line? Yeah. Yeah, is he online, Vivek? Yeah, he's online. Yeah. Okay, so I will give a brief introduction about my friend Professor Vivek Ranade. He is joining us from Ireland, University of Limerick. He is a Bernal Chair Professor of Process Engineering. He is experts and leads multi-phase reactors and process engineering group there. This group is developing fluidic devices and by the name MAGIC, which means modular, agile, intensified and continual processes. He has a platform which he calls as a factory in a box. These innovations are used to realize better healthcare and in nutrition field. And before moving to Ireland, University of Limerick, Vivek was a deputy director of CSIR at NCL Pune. He also worked with ETH Zurich, TU Delft, University of Twente, Netherlands. He is a recipient one more speaker who is a recipient of Shanti Swarup Bhatnagar Award. He is Swaran Jayanti Fellowship from Department of Science and Technology. He is a fellow of Indian Chemical Engineering, UK. He is a fellow of Indian National Academy Science. He is a fellow of Indian National Academy of Engineering. He holds more than 250 papers, 20 patents, 9 books. Vivek has co-founded 2 technologies and technological areas where he call it as a tridiagonal solution, and one by name VVRA. Because I know Vivek VV Ranade, so he has used that VVRA, Vivek Ranade, as his own identity as a technology known as VVRA process technology. He is on the editorial board of many journals and currently is a deputy editor of ACS Engineering AV. So I request Professor Vivek Ranade to take us through his presentation for next 15 minutes. Vivek, please.
Yes, sir. Sarang, do you want to say something?
Yes, we can start, sir.
But right now, Samir is there. Yeah. Okay. Good morning. Am I audible? Hello. Am I audible? Okay. Great. Good morning, and thank you for giving me opportunity to participate in today's function. Because of the time constraint, I'm going to immediately start on the topic which I want to say today. I'm going to speak on multi-phase reactors and process intensification. And therefore, I have titled my talk today as Professor Jeshtaraj Bhalchandra Joshi. As probably all of you know, with his more than 5 decades work, his name has become synonymous with multi-phase reactors and process intensification. And what I'm going to talk today on multi-phase reactors and process intensification is kind of partial reflection of what he taught us, using machine learning for many applications in multi-phase reactors. Another example I'm showing you here is on factory in a box for excipients or a drug delivery platforms. In IndusMagic program, we have developed various processes for synthesizing APIs or dyes or any other properties. We were not focused on excipients or delivery systems. So this is an example where we are developing this factory in the box platform for drug delivery platform. So you can tailor the slow release or fast release by manipulating the particle properties, porosity, surface charges, pore sizes, and so on. And we use again continuous processes, process intensification, and multi-phase reactors. So we have a patent filed on this process. And again, we are following the teachings of Professor J.B.Joshi for commercializing these kind of factory in a box platforms. While we are working on some of these translational research, we are also continuing the work on fundamentals. Again, Professor Joshi emphasizes that you can in no way you can substitute fundamental understanding. So we are using computational models, not just CFD, but also other kinds of computational models and machine learning for simulating variety of continuous flow processes. The specific area which we have chosen here is on continuous crystallizations, because some of those clogging issues are quite troublesome for many continuous operations, and we are handling and developing new strategies to get rid of clogging and encrustation issues in continuous crystallizations. And we are translating that understanding for a variety of different continuous processes, which either solids are part of reactants or solids are part of products. And those kind of learnings from continuous crystallizations are quite handy in doing this industrial projects on continuous reactors. Just one slide on waste valorization, which I essentially started after I moved to Ireland. I was not doing this work at NCL. So we are now using hydrodynamic cavitation and other pre-treatment processes for extensively increased valorization of waste biomass. And In fact, it is quite interesting that while I was at NCL 26 years, I never worked with VSI, which is right there in Pune. After I moved to Ireland, I took a large project with VSI, Vasantdada Sugar Institute, on valorizing bagasse and press mud, which are like a big waste biomass generated from sugar industries. And we are now, the pilot digesters are running at near Abhima sugar mill now, and we hope that this will be commercialized in the coming years. While I'm doing work at sugar mills in India, I've also worked with dairy industry here in Ireland and trying to translate some of this work here in Ireland. So that brings me to the end. So our research here at Ireland is organized on two axes, the people and planet axis. So what we always say that the group of my group, the research of my group here, multi-phase reactors and intensification group, where we use experiments, computational modeling, and machine learning to generate new insights, translate that insights into innovations and intensification strategies, so that we contribute to well-being of people and planet. So in my case, I need to say that my research is organized for contributing to well-being of people and planet. I want to stress here that Professor J.B. Joshi has all his life has spent his efforts on contributing to well-being of people and planet, and his research speaks for itself. I never heard him explicitly saying that he is doing that, but I think he has all his life he has worked with the goal of well-being of people and planet. I just want to say thank you so much, Professor Joshi. One last thing I want to say here, that apart from his teachings in academic and chemical engineering, with all his lifelong work on well-being of people and planet, I believe that he is an embodiment of these five niyamas which were written in our Yoga Shastra. I recently read book by Taimini on science of yoga. I had read that earlier, but I think I have now understood it better. And I truly believe that Professor JB is really an embodiment of Shauch, Swadhyay, Tapas, Santosh, and Ishwar Pranidhan. I hope that I will continue to learn from him. I will continue to be inspired by him, and I will continue to be blessed by him. I wish him the very best, to him as well as to Madam Joshi. Thank you very much for all you did for us. Thank you.
Thank you, Vivek. Thank you for being there. I know it's a very early morning for you to be there online and give the lectures. We have also not met for a good time, but virtually to see you here. I'm very sure your magic works everywhere, Indus Magic, and your complete package of solution of factory in a box really becomes a great value addition to the companies. Thank you for being here. If at all you were to be here, we would have loved to do a felicitation, and definitely we are missing that. But we request you to be there online and see the live streaming, because this is the last part of session 1. And after you, we are going to have a summarization, and if at all, any question answers. So we will not. We will only do the summarization? Sure, sure. So we are 5 minutes behind the schedule, so we will not have questions. We will do a summarization by the session chairman, Dr. Anil Kakodkar. So can I request Dr. Kakodkar to please? I'm not going to be stupid enough to introduce either of these Mahagurus. The name itself, Nami Kafi hai. Dr. Kakodkar, Professor Sharma, and Dr. Mashelkar. Kakodkar, sir, please. Sir.
Well, before I talk about the excellent session that we just witnessed, let me at the outset express my felicitations and compliments to Professor Joshi, a great friend, a rare teacher, and of course the session that we have seen is a true reflection of what a good teacher does to his students, to this propagation of knowledge, and to the development of the society and the country. And I think in all the 4 presentations, that aspect came through very, very clearly. The presentations both by Dr. Kinshuk Das Gupta and Professor Yogesh Joshi, who are both here. Uh, it so happens that I'm somewhat exposed to that kind of work. Kinshuk, of course, belongs to BARC, and the Bhabha Kavach story has made a big impact for our security forces, both military and paramilitary forces. But I think that work has many further ramifications, and I'll come back to that in a minute. Professor Joshi's talk on thixotropic materials, in fact, that word itself was very intriguing for me. We had at Indian Rare Earths huge stockpile of quote unquote a waste, which was right on the bank of a river, stored in a building which was under distress. And the fear was one day this whole waste will flow down into the river. And then, of course, the task was to clear that, and that clearing was equally or maybe much more difficult. And then I knew that that is difficult because that's a thixotropic material. So it was interesting for me, and I'm sure it would have been interesting for you to listen to both speakers. Unfortunately, we don't have time to go through a question-answer kind of session, but they are here. So during the tea break and all, you can always take advantage of their presence here. The other two presentations, Professor Mitra Gotri and Professor Ranade, they have been online. Professor Ranade is still with us. And I think these two presentations, just as the two previous presentations, as I said, in terms of impact of a teacher, and I would say all around impact across all the full spectrum, all stakeholders involved, the students, the institutions where they work, and the society at large. That was very clearly visible. I particularly like the term which Professor Mitra Gotri used on, in fact, as a teaching, he learned from Professor J.B.Joshi on the chemical engineering dogma. And I think that is something, central message, not just for chemical engineers, but also for all, I think all scientific community, but more importantly, the engineering community. You know? And also, as Professor Ranade mentioned, what he learned, the compute, innovate, and develop, as a key learning from Professor Joshi. And in fact, I recognize that has been the basis for the collaboration that was developed between BARC at that time and ICT, or was it UDCT at that time when Professor Joshi was the director. And it was very nice to see from Kinshuk your presentation that that trend is continuing all this date. So I think for want of time, and we don't want to eat into subsequent maybe equally or more interesting sessions to follow, I would not go any further, but just want to make a comment, particularly on Dr. Das Gupta's nano carbon structures. And I'm not going to, just 2 or 3 sentences. See, carbon has become a villain when it goes into atmosphere. And carbon is going to be a great boon for mankind when it comes as CNT, carbon nanotubes, or for that matter, other forms. And carbon has capability of replacing all kinds of materials, call it structural, call it textiles or similar other things, not just for our own personal use, but also for industrial use. And also for the more exotic materials that we use in electronics and the new technology. So the question is, if carbon is such an important thing, why can't we just make sure in the days when we are worried about net zero and chemical engineers are here, so why can't we make sure that we keep using fossil materials, fossil energy, and translate or transform or move the entire carbon, instead of it going into atmosphere, it goes into our daily use and replace, call it iron, call it aluminum, call it plastic, or for that matter, other material. And think about it, and I'm sure Professor Joshi will give you 110 solutions. So, and I'll leave it at that. Thank you very much.
Thank you very much, sir, for the entire summarization and your insights to all the presentations. And definitely this will be a source of input for us to take this forward. I request the Vice Chancellor ICT, Professor Aniruddha Pandit, to do the felicitation of our session chairman, Dr. Anil Kakodkar. And a memento also. Thank you very much, sir. I think we are behind by 7 minutes or so. We will take a tea break, tea coffee break here and just outside the hall. Yeah. And I request all the speakers who are offline, please, we will quickly have a photo with, because that is something which will go on the memory lane. I think Professor Yogesh and Kinshuk, you both can come. I request all three Padma Vibhushans and the Vice Chancellor and Professor Joshi also, please. Because this is a moment, this is a frame which they would also like to have them.
काय झालं चहा प्यायला गेलो का हां सर प्रेझेंटेशन
Because you don't need the Google Meet to. I don't need to join the Google Meet. No. That is only for the guest who are joining online. Okay.
ते त्यांचाच लॅपटॉप लावतो
Clicker आहे. हो. I'll try it. झालं नाही तर मी सांगेन. ठीक.
हां बोललो सर सांगा पोस्टर लावायचं तर सेटाचा वॉलपेपर करून टाक ना तुझ्या याच्यात तसं समोर काहीच नाही वॉलपेपर करून टाक इकडे ते सगळेच होते एकच आहे ना याच्यात पॉज करून ठेवायला पॉज करून ठेव स्लाईड नाही हां त्या नाही आता स्टार्ट कर हे करून देत ना हे एका स्लाईडमध्ये टाकून ते इमेज आणि करून टाकलं नाही ह्याच्यातच टाक ना अमोल सर स्वतःचाच लॅपटॉप हे पोस्टर घेतलं तिथं काही चालू नाही हां ते शेड्यूल लावून झूम होऊ नको बरं हां बसलेत कसं नाही सर
शर्मा सर आहेत काय विचारू सरांना डायरेक्ट
इकडे शक्यतो ज्याचं पुस्तक असतं ना तोच सही करतो बाकीचे करत नाही
त्यांचेच गुरु आहे
Welcome back. I understand you are taking a photo of the entire team of Marathi Vinyan Parishad. So, huh? Sir, should we start? Yeah. Yeah. So welcome back. We will have to be very precise with respect to timing now because we are behind by 20 minutes or so. So I request session 2 speakers to be ready. And in session 2, if you see the program schedule, which is given as a part of your, you may call it as a kit in the delegation point of view, attendee kit. You can see we are going to have 4 speakers. First is Dr. Parasu Veera, followed by Dr. Prasad Kokil, who would be in US but would be joining us online. Then we have Dr. Amol Kulkarni and Dr. Nitin Deshpande, both being here. So out of 4, 3 speakers offline, 1 online. So can I request the first speaker, Dr. Parasu, to please come up on the dais? I will give a brief introduction about the speaker and then I leave it to him for 15 minutes to take through his presentation. Please have a seat. Dr. Parasu is a chemical engineer with 24 plus years of experience. He has done his PhD in chemical engineering. Before that, he did his bachelor's and master's from Jawaharlal Nehru Technology, Hyderabad in chemical engineering and biotechnology. He joined then UDCT for PhD Tech in 1996 for the subject expertise of reactor design. He joined University of Twente, Netherlands as a postdoctoral fellow and in turn he also served as assistant professor. He worked with Reliance Industries Limited, Hazira site for 12 years. He was also at the chairman's office of Reliance Industry. You can imagine what kind of the power center that chairman office would be, where the organization is contributing to good percentage of India's GDP. He was there at the chairman office of RIL for 3 years. Lot of awards and recognition to him. Many came from his stint at RIL. He contributed very much into the iconic liquids. He has got to his credit 70 plus inventions and 400 plus patents. So we have a speaker with around 400 plus patents. He has also been on the government committees on intellectual property right, technology, HR, as per the ICT, IIT Bombay, IIT MHRC. He has taken the 250 crores to 1500 crores when he joined UPL in 2016. So around in 6 years, the progressive top line from 250 crores went up to 1500 crores. In 2022, he joined SK Iodine Private Limited as a CEO. And he is again back to UPL as he is again back to ICT for a moment. So he is back to UPL as a head of new technologies and business. He is also fellow of Maharashtra Academy of Science and he is also fellow of Indian Chemical Society. So I request Dr. Parasu to take us through his presentation, please. Thank you.
Good afternoon and thank you Dr. Joglekar for kind introduction. So respected dignitaries, Dr. Kakodkar, Dr. Mashelkar, Professor M.M. Sharma, Professor J.B.Joshi, all my gurus, and then of course Professor Pandit, and many other dignitaries, and also the friends, and many of my lab mates and friends here also here. I'm very happy to see some of them physically could come and we had an opportunity to interact now whole day. And also I'm excited that we are meeting some of them after a long time. So it's indeed an honor to speak here on this day, and thanks for giving this opportunity. At the outset, I would like to thank ICT also for at least remembering that I could contribute something today. First of all, I would like to thank Joshi sir for admitting PhD under him when I came from Hyderabad to meet him. And he just simply nod his head in one of the corridors, said, you just wind up in Hyderabad and come and join me. He didn't even listen much about what I have done or other things, except that he asked me 3-4 questions. I think he could assess so well in such a short time. And that always tells us that the man of simplicity, that's one thing everybody spoke about it. But I think more important that we always listen to respond to the opposite person. But what he taught me is always listen to understand opposite person. That's, I think, that's what he teaches us. He is patient listening to the opposite person. He actually translates his own, information in his own way, and then actually tells us a lot. So have a patience, have a patient hearing is what it teaches us every time, rather than just listen to respond. I think that lesson for me goes a long way, because when you listen to opposite person, you understand what he means, rather than what you wanted to say is not that what you process the information. And I really thank you, sir, for accepting me as a student, and that changed my life. Whatever today I'm professionally and personally, it's because of you and ICT. And I have no problem in saying in any forum, and I keep telling that again and again everywhere. Actually, as a famous saying goes, people always says that teach people how to fish, so it goes long way. But I would say Professor Joshi teaches plus one of that. It's not only just how to fish, but he also teaches the tools to fish. Especially those tools, for example, I would say the inner strength that one has to build to do that. So either by your own way of, Vivek put up those 5 tattvas or whatever, those principles. So those things we practice every day and every time in day-to-day life. So that teaches us that it's just not only the general tools, but also that how to react to the situation, how to take the situation as it comes. I think, sir, that goes a long way. And when Dr. Joglegar asked me that you need to give a talk, then I was just thinking what title I should give. But then I decided I will not put any title, because if I put any title, it undermines his contribution to the industry. And then I would like to just leave it as an open, and then I'm going to show some of the numbers. And this is mostly I'm going to show his contribution in industry, and then actually some numbers. And then actually how this practice of his industrial consulting changed the chemical industry at large. I think that we will see in the next coming slides. Yeah. Yeah, next slide, please. Can you show that? Yeah? No. First one. Yeah, this one. Yeah. So diphenyl methyl phosphonate is a molecule which UPL manufacture today. It goes into a fire retardant chemistry. Customer from US wanted it because they have a patent, and they don't want to manufacture in US because they don't have basic chemicals. UPL has a basic chemicals. But what they have is only deck of 4 slides. That's it. So we have to put up the plant with that. So we did the basic chemistry, but then when we went to Sir and sat with our engineering team, we went many iterations, but then the trick was that the specification of the product, 99.9%. Though it's a 2-step, I think to achieve that 99.9% is the critical. So after 10 iterations or so, sir, we don't have enough information about the distillation. We didn't do much. He said, just leave it to me and give me 2 days time, and we will design the column. And when we designed, and then it's a nickel column with the internals, completely nickel MOC. And the first batch, we achieved the quality. In fact, people who are not willing to even look at that, and they came and then said, how did it happen? I mean, we didn't have any information. I think that's a contribution. and then I would call as a story of a design. So I'm just tell these 5 slides and different areas. That's what I said. I don't want to put any title to it because he touched upon every aspect of a chemical industry. The next slide, please. Yeah. So this is another molecule where mancozeb. So UPL had a 30 ton per day capacity plant, and it's kind of converted in batch to semi-continuous. And then by capacity increased to 30 to 140 metric ton per day through the process intensification. And then he did design the largest spray dryer in the industry. So which is very, very critical to achieve this particle, because when you spray dry, the CS2 that is excess, which has to emit out of it, and then which will otherwise will not work on the field. And the design is so critical, and then the largest in size. So amazing results, and then the kind of savings that company could get is unimaginable. And then so it's an example of a PI. It's just that amount of work it goes. And then I still remember when I was talking to many people, he suggests something, it takes till next meeting 100 to 150 experiments people have to do to meet his expectations. You know, that's a kind of hard work which used to go behind his thinking. Yeah, next slide, please. So another story is DVACL and cypanmethrin. It's absolutely non-profitable making a molecule. But then what he identified was basically go back to the one more molecule, DVACL, and let's improve there to make a cypermethrin as a profitable. I think that's where that absolutely 15 to 20% yield improvements where quality issues were addressed, and there's a lot of sodium cyanide which is handled. So all the complicated chemistries have been handled, and then they turn around the situation through the several process developments. So design, process intensification, process development. So you touched any topic, I think he has touched in the industry. Next slide, please. Yeah. So this again the acephate molecule, which is a blockbuster today, along with the mancozeb as well for a UPL. And similarly, there's a lot of pressure from China to sell that. And then so there's a decreased profits were there. So again, they went back with the previous molecules, DMPAT, and then entire turnaround has been done by working on the chemistry, working on the improvements, and then so on and so forth. So in fact, maximum number of new equipment was designed in this process by Professor Joshi. If you go and see that today at Unit 2, and this is one of the real molecule which makes that unit most profitable for a UPL. An amazing story and amazing inspiration behind that, and then they're still going on. Next slide, please. Yeah. So this is a very old molecule which is of course banned in India, but I would still give that. And those days, monocrotophos was manufactured by the solvent, and then there was a pressure to shift to reduce the cost, and then they developed the process based on the water. And then that actually, this is one of the basic molecule which turned around the UPL those days in 2000, 2001. So if you just look at it, he touched upon every aspect of it. But most important is fundamentals he used everywhere. I think even earlier speaker Vivek also mentioned that. Always use the fundamentals, but solve the problem. So solution engineer is really coming out in action when he really talks to us. So these are the simple 5 examples, and there are many such examples we can speak in industry, especially in UPL and in Reliance. And then just one statement from Reliance, I can tell that when we were in discussion with Mr. Kohli in Hazira, he's no more unfortunately, and he said, Professor, are you sure that what you're suggesting it works? You know what sir's statement and respond to him? If it doesn't work, I will stop my practice, chemical engineering. Everybody stood in the room. So that's a conviction that with that conviction, sir actually designs and then work with that. So I think that passion combined with academic excellence and actually is the most important thing to have, and that's what driving him and then his students. Thank you, sir, for teaching all of us that kind of principles. And then today, many of industries are really following. And then we will see the next few numbers based on that. So the common factor in all these things is basically the cost reduction, cost savings, efficient manufacturing, and so on and so forth. I would say very important, very good for an industry. But then, next slide, please. So what has been that achieved? Without fail, 50 to 70 crore annually on budgeted cost, because every year when you make a budget, so already improvements have been done, cost reduction is there. On top of it, again, every year, that much amount of money is to be saved year on year. So one can calculate 2002, even if I just take a baseline, 22 years, 50 crores, and then look at the compounding effect. One can calculate. I don't need to teach anyone that kind of numbers here. I mean, they're just self-explanatory. So that's the kind of contribution he did for the industry, a single industry. And then it has gone long way in building that. Yeah, next slide, please. So how did he do it? It's an alignment and process inside. It's just not that he was telling and then going away and people doing what they want. He aligned internally, and that's the most important. So every Tuesday, there's a meeting happen, and next Tuesday, people come up with the results and experimental results, and then what has been found, what has been said has been tested or not, so on and so forth. But most important in the whole process, the division called Max Pro was conceived and born, and then that has become a culture and now in industry, and it is being continued. So I would just see in this chart below, if you just go and see innovation, I would say there's a round of applause for him as an innkeeper. He is the one who's actually maintaining it for internally, coming from outside. And for outsiders to do it is very difficult in any company. I think hats off to you, sir, and a really round of applause from all of us as friends. Next slide, please. So this Max Pro now has become a practice in the industry. People call it as differently. Some industry may call it a process simplification, some industry call it improvement cell, whatever we call. So it has become a division in most of the companies. And cultural change, that's a big shift that he brought into the industry. And now that is a big contribution to the society, because most of the industry, at least I can name here, either Atul you take Lakshmi Organics and many companies, all of them are now following the similar principles, and they all have these groups who are looking at a continuous improvements, what the growth strategies, and how do you reduce the cost. So I think it's not just that what he did for UPL, but I think what he does culturally changed the whole thing in the industry is now being practiced and recognized. I think that's the biggest contribution from him to the society and chemical industry. Yeah, next slide. So I think with this, I've just covered what has been done to the industry and then other thing. But beyond that, I think is taught all of us how to live simple life, and then also how to use fundamentals in life and chemical engineering, and as well as your regular practices of simplicity to lead a most effective life. So thank you, sir, and we wish you all the best and also very good health coming years, and we continue to see you hopefully that producing another 100 more PhDs, and then we celebrate. Yeah, thank you very much.
Thank you, Dr. Palsuvira, for enlightening us on all the achievements and the learnings from Professor Joshi. As you talked about the numbers, I mean, he's in that sense very unstoppable. We are 132 of his students, and he has a lot of projects still in that challenge list, and I'm very sure it will go on. Can I request the session chairman, Dr. Mashelkar, sir, to felicitate Professor Palsuvira? Thank you. Thank you, sir. So the next speaker from the session number 2 will be joining us online. He is in US currently. Prasad Lakshmikant Kokil, Managing Director from Sanjay Group of Companies. So can we have him on the online? Prasad sir? Yeah. So we have Prasad. Yes, we can see that. We can see here. So Prasad sir, I am going to give a small introduction about you. First and foremost, thank you very much. At a very odd time, you are joining us virtually from US. Prasad sir is a managing director of Sanjay Group of Companies, Sanjay Techno Products Private Limited. He is an electrical engineer graduate and post-graduation and diploma in business management. He started his entrepreneurships in 1997 with plastic injection mold parts used in automotive and appliance industries. Now, as on today, the group of Sanjay Industries has got 9 different manufacturing plants pan-India, and the revenue overall is 300 crore plus. He is also a source of employment for about 1,000 plus the Sanjay Techno Group employees. He initiated the interactions with IISc and ICT for joint research and commercialization with respective areas of mutual interest. He is a past president of Chamber of Marathwada Industries and Agriculture. He is a past chairman of Confederation of Indian Industries, Marathwada chapter. And he is also on the many board of management studies and board of management in government college engineering colleges in Sambhajinagar. He is also associated with various academic institutions all across that region. He is director in social organizations like Marathwada Environment Care Cluster, Marathwada Auto Cluster. He is also a founder, director of Incubation Center Magic by CMIA, wherein the startups and incubations for 20 plus startups is being facilitated. He is establishing 20 Atal tinkering labs in various schools and in 8 different regions. 8 are already established. He is being awarded as a Padma Bhushan in 2018, awarded as Plasticon in Delhi, and he strongly believes with the principle of what he calls as 3 T's, time, talent and treasure, for city developments through initiatives like different areas of clean and green energy, clean city. So welcome Mr. Prasad Lakshmikant Kokil, Managing Director of Sanjay Group of Companies. We really appreciate you being here virtually and going to make a presentation for next 15 minutes. Sir, it's all over to you. Thank you.
Thank you, Dr. Juvekar, for nice introduction. I'll start with the shlok, Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwara. Guru Sakshat Parabrahma, Tasmai Shri Guruve Nama. Tasmai Shri Guruve Nama. गुरुंना वंदन करून मी पहिले चालू करतो माझे गुरु प्रोफेसर J.B. Joshi. Today we all are blessed to have our gurus in our life. My guru, Professor J.B. Joshi sir. Sir, blessed to have you in our life. As teacher, scientist, advisor, wealth creator, duly appreciated by Government of India as Padma Bhushan. Today amongst us, we have so many Padma awardees, and I am sure so many to get in near future through ICT work. I had an opportunity to host Dr. Kakodkar in Aurangabad through our industrial association CMI Masia on live industries problem solving with academia. Similarly, with Dr. Mashelkar on his lecture famous E is equal to K, education equal to knowledge. Professor M.M. Sharma on chemical engineering in human body, and of course Professor J.B. Joshi sir several times on energy, sustainability and other topics. But I need to mention his PPT presentation in front of school and college students on how to cultivate mindset so that it goes generations to generation together with Dr. Prakash Amte and his social work and Dr. J.B. Joshi and his scientific work. And that day, everyone in the city was amazed with the vocabulary, and students were not ready to leave him alone. And we have to pull him for the dinner. So that day, I remember the power of a scientist to motivate, inspire young generation. I remember our association since long when we came to ICT to seek help in ethanol production, exploring ethanol production, me and my partner Sunil in 2007-8. Though this project doesn't see light of a day because of then policies of the government, we were so upset. While coming back from Mantralaya with a negative approach, and we sit with Professor Pandit and Joshi sir, with our passion and with our sincerity, they find out something in us. We were MSME, that too from tier 2 city like Aurangabad, started recent business, but they said that inspiring words, if we can do a joint project in combustion, in cooking vessel optimization if you are interested. And we immediately said, yes, we are interested. Since then, from 2007-8, we are associated with ICT, with Pandit sir, J.B. Joshi sir, and I always enjoyed energy group discussions. Every month, we have a discussion in a lab, and going to those discussions, staying in hostel 5, eating in a cooperative mess with so positive vibrations of a young talented minds, I think industry person like me get always amazed with ICT phenomena. And this made us to think that MSME can also make a dent in research, and we started investing our time, talent, and treasure in research. Our first product comes as outcome of these days is eco cooker and cooking vessels. So we have a patent on that along with ICT. We have also continuous cooker work along with, I remember students who are PG, PhD, Mr. Gudekar, Yogesh Shinde, Rahul, Amol, Jakir, Yogesh Urunkar, and many more who gives us a energy that an industry people can get energy from these students, and we are ready for custom commercialization of these. Then we worked with biomass stove, we worked with milk thickener system, and all these are problem statements which are being discussed in energy group and work together. These are few pictures. We did a lot of work with Professor Joshi on pyrolyzer, and I remember he keep on dialing me from Gandhinagar, from Jammu, and telling something which I need to experiment for 10, 15, 20 days and give him a response. So hardworking, as mentioned by many speakers, he makes us hardworking, he inspires us, and whenever we are upset, we say that the experiment is failed. He laugh, he giving smile and says, "Then we will have a learning." And that's a specialty of Professor J.B. Joshi. He always takes learnings from the failures. So while designing these products, we have a biomass stove which was having thermal efficiency around 38%, and he gives us a target of 60% plus. 60% plus we never thought of, but today, after 3 4 years of work, we have reached to 52.5% of the thermal efficiency, and I'm sure with couple of years we will reach to 60%. And he always tells us that yes, we have to do this at this excellent level, and that's how we go on making the things. Another sanitary pad incinerator, it's a problem that we waste it. We make a municipal waste of all sanitary pad, and he gives us an idea on incineration, and that's how we are doing a lot of work, and those are commercialized products. So we are still doing a lot of work with Professor J.B. Joshi on continuous experiment with Marathi Vigyan Parishad. continuous paralysis study with Manipal University. I am sure Professor Abhishek is there. He gives us an opportunity to work on Himalayan homes for space heating and cooking solutions with MIT Boston. And my R&D team goes every month on the territory and do some research work so that the Himalayan terrain can be fetched. He also gives us a sustainable village cooking solution with Pidilite Industries in Kalsar village as an experiment, but we are taking it to another 3-4 villages. Improved cook stove, I mentioned about the efficiency target of 60%, and also he has given a thought on technology development around hydrogen extraction. So these are some peaks of 2013 when we launched our eco cooker in Aurangabad. And that time Shirish Bhai, Bhagwat Devi Dayal, JB sir, Pandit sir came. And that day I remember a lot of Aurangabad people were inspired by the sessions that sir taken. Shirish Bhai, Bhagwat Devi Dayal sir and Pandit sir. And after that, so many industries had taken interest into a research project. Our lifetime learnings from J.B. Joshi sir. Select pain area problem statement. Write a right problem statement. Frame proper hypothesis. Design your experiments to prove either this is wrong or this is right. Then vigilant and scientific observation are must. You should write it down, tabulate. Mathematical modeling will give right conclusions, and he always gives a formula which runs into 1 page, 2 page, or sometimes more than that. And that explanation on mathematical modeling and the formulas gives us a confidence that it will work. And the sentence that he said, that he is always certain on the results, and he always says failures will give more learnings than a success. So whenever there is a failure, you should be happy that you have something to learn. He always gives us a balance on energy mass, also on life and science, and he always insists that these are the most balance in the life. Wealth creation for self, family, society, and nation is responsibility of scientists. Sir, these learnings gives us a lot as MSME, and we have great dream that we will grow to next level. So you must be wondering why I am making this benzene structure all the times in my presentation. Sir, as C6H6, you taught us not only as chemical engineering, but life engineering as well, where curiosity is mother of science and you should be always curious like a small child, like a small student. You should be always curious, and curiosity is mother of science. Caring is humanity. You taught us caring of everything. Calm is necessary in learning science. You should be calm, composed so that you can understand what science is going to tell you. Courageous to experiment is DNA of a learner. Capabilities can be built through above 4 C's, but don't forget to be considerate. These are all 6 C's that we take us in our character so that we want to be a ideal person for the person. Your approach to science shall be holy, to make at least few happy, to bring harmony around you with your hard working. You should be hopeful all the times. All the times whenever we come to him, sir, we are not getting the desired results, and he always tell some more work will give you definitely good results and you will be successful. So this hope always keeps us live. You should be hopeful But if you adopt these 6C and above 5H, you get honor and you become honorable in the society. And that's how this C6H6 model keeps us live, always energetic, and always useful for the society. Sir, we wish you a long, healthy, and meaningful life for the society, for the nation, and for the humanity. And all your journey, Madam Joshi is always with you. Whenever you visited our plant, whenever you come to Aurangabad, Madam was with you, and we get a lot of caring whenever we come to your home. Thank you very much, sir, and wish you a happy birthday. Wish you a long life from all Sanjay Group family, EcoSense family. You mentored not only me, my daughter Ketki, my son Vedant, and Sunil's two daughters, and we all owe you for our lifetime. Thank you very much. Over to you, Joglekar sir.
Prasad sir, it was indeed not only a speech, but a lot of impact it has come from a guru to a shishya and somebody, an entrepreneur like you. I mean, your presentation reminds me of two quotes. One is Shishya asked the Guru at one point of time, what is most important in the life? And the Guru says the Sangat, a company. So I believe that if the Sangat is good and if it is from somebody like C6H6 with high density, where the density is full of knowledge and experience and passion, it is going to be quite impressive for individuals. I think the echo is coming. Yeah. And the second quote, which I reminds because of your speech and the presentation, is about what is more important in the life, whether it is a speed and a direction. Obviously, the answer comes as a direction. And the direction can come from such a Mahagurus. They are all Padma awardees and they are all assets of India. And either of them are, like by name itself indicates how much of the students they have developed, they are directly or indirectly contributing to the nation building. So thank you very much. If you were to be here, Prasad sir, we would have definitely loved to have a session chairman, Dr. Mashelkar, to felicitate you. But we will be missing this. And please, request is to be on live and see the live streaming so that whatever the summarization, the session chairman, after the two more speakers come up, then you can watch it. Thank you very much again, sir. Thank you. So we have this third speaker. That will be offline. Amol Kulkarni from NCL. Dr. Amol. Can I request him? Yeah. So I'm going to give a brief introduction about Amol. He has come early in the morning all the way from Pune, and he specifically said that I would like to do a presentation offline that talks about the kind of a love and kind of a respect for Professor Joshi. He is a chief scientist in chemical engineering and process development at CSIR NCL Pune. Did his BChem in 1998, MChem 2000, PhD Tech 2003, 1, 2, 3, all three from ICT. He's a complete product of UDCT, now ICT. He did his postdoctoral fellowship at Max Planck Institute, Germany, also at MIT, USA. His research areas is design and development of continuous flow reactors and their applications in pharma and dyes. He is the one who developed the first micro-reactor lab in Bharat. He has done a lot of many scalable continuous process models and being successful. He is also one of the speakers which we have today, again, a Shanti Swarup Bhatnagar awardee, 2020, Vasvik Award again for Amol for excellence in industrial research, Sipla Hamid Award, which was also being given on him, conferred on him. He is also a selection committee member for Humboldt. He is also having 107 papers to his credits, 39 patents, and will go on. And this is what Amol Kulkarni is all about. I request Amol to take up the session for 15 minutes. Thank you.
Thank you, Dr. Joglekar. Thank you very much for giving me an opportunity to be here and present what we are doing in this August gathering. First of all, I sincerely thank Professor J.B.Joshi for allowing me to be one of his students and making us come up to this place. I'm going to give something interesting. I'm going to present something which many of you might have heard earlier, but something which is, I will present something new. For last few years, we have been working on the silver nanowires. I'm sure that many of you have iPhones, and the touchscreen of an iPhone is made of silver in the nanowire form. All other mobile phones have the touchscreen, which is made from the ITO, that's indium tin oxide. What silver nanowires offer is a flexibility. So you can, if you have a flexible touchscreen, then that is where the nanowires will be useful. So for quite some time, this material is has been attracting many people to work on. There are certain bottlenecks. I'm going to present mainly some of the new outcomes. Now, before I move ahead, when I joined Professor J.B.Joshi first as a summer intern in the summer of 1996 for working on photocatalytic degradation of distillery waste, and after that continued to work for many years along with him. These are all some of the things that I felt like we indirectly, directly experienced, taught many of these characteristics of or qualities of a researcher that one should have. And as and when he used to talk to us, I could pen down a few things from time to time. And I feel like many of the students, if you look at all this entire matrix of curiosity, imagination, enthusiasm, patience, youth, persistence, faith, courage, honesty, modesty, working in parallel and taking up challenging problems. All this is what we have learned when we were working with him through some or the other way. Many times directly facing, many of us have faced how do we be patient for over a very, very long time. And we have made him also to be patient because of all of us. Next slide, please. So thank you very much. Okay, now let me come to this main thing. See, when it comes to nanomaterials, we all see many applications that we see every day around, whether it's a quantum dot, LED TV, or the materials, the composites that goes in our dental filling and so on. All of nanoceramics, they all are made from variety of nanomaterials. And as of now, some time back, we did some analysis of how many companies exist working in this domain. And there are almost 521 companies globally who manufacture nanomaterials. 90% of these they use for some of the other applications in the lubricants, in the health devices, and so on. There are some tightly controlled markets like quantum dots, LEDs, nanoceramics, conducting inks, thermal coatings, etc., which are very tightly controlled. And all these markets inaccessible to be entered in the entire very tightly controlled value chain. But that does not mean that one cannot make a entry into that. But most important thing is that this is something where the chemical engineers can find an opportunity to work on the reactions where pH plays a major role. When we write the reaction kinetics, etc., we write in terms of kinetics, we write in terms of concentrations and temperature and so on. Rarely we see the cases where pH also comes into picture. And these are all the cases where pH does play a role in controlling the nucleation kinetics, growth kinetics, and so on. Next slide, please. Yeah. Now, coming to the silver nanomaterials. Silver nanoparticles we have heard during the COVID time because they have antimicrobial properties and so on. And they have a huge market. But more attractive market is for silver nanorods and nanowires. And they all go in printed and flexible electronics. Huge in in the magnitude as well as the growth rates. It goes in variety of forms in the photovoltaic cells, RFID tags, in the transparent conducting films, as in the circuits of the curved OLED or QLED televisions and so on. Most importantly, the amount of silver that goes when you use nanowires is very small as compared to when used in the particle form. Because the particle to particle contact needs a lot more silver as compared to wires contacting each other. Next slide, please. Go back, please. Yeah. Okay, so the key players in this area, there are many multinational companies are there, and they produce in really good quantities. There are top users. You can see some of these top names. They use it for a variety of applications. Many of these applications are not even known to us. Annual demand in 2018 was 5 tons. 2025 it will be 11 tons. But there are some bottlenecks because there is a big gap between the supply and the demand. Lack of large-scale production methods. That's a major bottleneck. Consistency in the wire properties relatively overheat. So you cannot have kind of wires which are say 50 nanometer, a mixture of 50 nanometers and 30 nanometers, or 20 nanometers and 80 nanometers. You can't separate them. So what you need to have is everything of the same kind of wire diameter. You cannot separate these materials when they are of different sizes, because applications demand them to be kind of almost homogeneous. And separation of wires from the nanorods or nanoparticles, because unless you have a particle, you can't form a rod. And if you don't have a rod, you can't form a wire. So it's like extension of the same thing which is going on. So at some point of time when you are making these wires, when you are making particles, it has to stop at that point, and then it has to grow further in the form of a rod, and then the rod has to further grow in the form of a wire. If you continue to make wire, particles, rods at the same time, then what you get a mixture which has no use as such. So we started working on this in sometime in 2016, quite some time back, and we almost solved all these issues. We developed a continuous process for this, filed multiple patents, 3 are granted now, and we have licensed the process also. But more important question is, while the silver nanowires have multiple applications in conducting inks, RFID tags and so on, the most expensive applications is in the touchscreens, which are like transparent silver nanowires, which are conducting. And that is what happens when you have wires below 50 nanometer diameter, below 30 nanometer diameter. The yield has to be high, above 95%, because the precursors are very expensive. You can't kind of generate the waste from this. And more importantly, can you reduce the reaction time further? So in general, this takes in the batch protocols very long time, 8 to 16 hours. When we were working in the beginning, we brought it down to 40 minutes. Now we have got something which is much, much smaller than that. Next slide, please. Why we started working on this? Because even recently when we check the prices, you look at this, per gram price is $200 to $500. Even if you want to buy in kilo, it is not less than $50 to $60 per kilogram. Nobody supplies in that form. Actually speaking, when you inquire with companies, they get cautious. Why are you asking for 1 kilogram kind of questions? There are few labs all over the world who basically certify the quality of wires, and they do not entertain any new sample to be submitted from any new place. The value chain supply chain is completely tightly controlled. They don't let any new entrant to be there. So you look at the per gram prices are like $366, 15,000 rupees and so on. Next slide, please. So we started working on this. When we announced that we have a process in 2020, which is 12 times cheaper than the commercial price. I will show it on the last slide. We had got a call from the US Silver Institute, which basically monitors everything that is happening around silver. They called us and asked, we have heard that you have a process which is much cheaper than what is the commercial price. Can you confirm? So we confirmed that yes, this is the price that we have got. They have a news article, I will show you that. After that, the global prices of silver nanowires fell by 5 times, because that was the profit they were earning. Then we asked few questions, that why we are not able to enter into much smaller wire sizes. Now there is a key question. Anything in the unidirectional growth of any nanoparticle, you have to first form nuclei. So if smaller is the nuclei or smaller is the particle size, smaller will be the diameter of the rod and smaller will be the diameter of the wire. So if you are able to stop the reaction of the nucleation itself or the particle formation at smaller diameter size, you will be able to grow the rods which are also thin, and you will be able to make the wires which are also of very small diameter. So we continued this, and we thought that we can probably explore, why not to explore microwaves, because that will allow me to get some good control on the rates of the reactions. What I want is something to happen fast. Now microwaves in general, they work on the electromagnetic waves. Depends on how you polarize the individual materials in the given solution. And faster you polarize, faster heating happens. We all know that it accelerates the rate of heating. It's fast reaction, high selectivity, low reaction time. We have been working on it for using microwaves for a variety of other applications. So we started working on this. 2 challenges. One is how do we go for scale up? And second is that what kind of reactor will you use for this? So we thought, let's start first and then try to solve these problems one after the other. Next slide, please. We initially tried to do some experiments in the normal batch mode. We designed a microwave which has got 2 magnetrons and which work in parallel mode. So we can run this continuously for 24 hours without in non-stop, because one works in switching mode at any power, any time. Optimize the conditions and found out when do we get the wires. Did some good kinetic studies at different wires, different powers of the microwave as well as the temperatures, because we had a good control on this particular microwave device that we have designed. Next slide, please. We did some studies on effect of power of the microwave on the yield as well as the diameters. We also did some time-dependent studies of when does the nucleation happen and when do we start seeing the wires. We also found that along with wires, we were able to get some particles, and it was difficult to remove these particles from the suspension. Next slide, please. So then we decided to optimize the conditions at a power which gives me minimum time, and that was like you can see here at close to 300 seconds, that's less than 5 minutes, the reaction was almost complete. We were able to get good suspension of nanowires, and the time was maximum up to 6 minutes. In terms of yield, aspect ratio, everything was coming well, but some questions were still not resolved, kind of why it is happening and how do we still make it scalable. Next slide, please. So we did the detailed kinetic study of this entire reaction, how it happens. It starts with the nucleus. Basically, the ethylene glycol basically splits into acetaldehyde and water. Acetaldehyde reacts with this silver nitrate, and then eventually we form the nuclei, which gives kind of monocrystalline silver nanoparticles which grow. So there is these three rate constants come into picture, and depending on how do you control which rate constant, you can either get only particles, only rods, or good quality nanowires, or a mixture of all of them. Next slide, please. So we did some detailed modeling and develop a model that will compare with the data. The most important part is here. When we take ethylene glycol and heat it in microwave, temperature will go to say 110, 120, 130 degrees and so on. It cannot go beyond that because in general, because boiling, it will reach the boiling point. Then how is it that the reaction is happening in such a short time, 4 minutes, 5 minutes? It's practically because silver is getting heated. So the nanoparticles, nanorods which are getting formed, the metal has very high dielectric constant as compared to the liquid. So the temperature at the tip of the nanowire is close to 400 degrees centigrade. That makes the reaction very, very fast and accelerate, because that is what we want. We want the wires to grow very fast. And so microwaves make that happen. And so we, we were able to kind of complete the reactions in a close to few minutes time. And we compared the model and the experimental data for over a wide range of power of the microwave. We were able to get good comparison. Next slide, please. And then now we wanted to make it continuous. Next slide, please. The first important question. How many minutes I have? 5 minutes. Great. Yeah. So first important question. Any material which we want to take from room temperature to 130, 140 degrees will gradually heat, even if it is few minutes. And a solvent like ethylene glycol will undergo kind of a change in the physical properties, because as the temperature increases, your density and viscosity both change along the length of the reactor. How do you take that into account when you design a continuous reactor? Because your dispersion coefficient will change. Your residence time distribution is going to change in the reactor. So then we first decided to study the residence time distribution. Next slide, please. And we did some controlled experiments at different wattage of the microwave as well as at different temperatures, found how the dispersion coefficient changes at different powers as well as the set temperature values as the ethylene glycol enters the reactor and exits from there. Next slide, please. We use IR imaging to monitor the temperature range, temperature change from inlet to the outlet. That allowed us to kind of find out what are the physical properties of the reaction mass. We use those properties to modify the dispersion coefficient, and then predicted how the residence time distribution will change from inlet to the outlet at different conditions. Next slide, please. So we developed a complex model that allowed us to fit the basically RTD curve that we were getting, and we were confident that now we will be able to kind of exactly know in what part of the reactor the nucleation is happening, in what part the rod formation is happening, and where in what part only the growth to make the nanowires is happening. Next slide, please. We came out with a correlation because some of these things we were not having a good understanding. So as Professor Mitragotri said, we have to approximate and find correlations wherever required when you don't have sufficient information of what exactly is happening inside the reactor. So we came out with a correlation, use that to measure, basically compare with the experimentally measured dispersion coefficient versus the model that predicts. Next slide, please. used that model to fit in the axial dispersion model for growth of nanoparticles, did the simulations to find out what should be my experimental setup, what should be my reactor length, what should be temperature, what should be the residence time, and so on. We started with a simple tubular reactor in the system where we wanted to have the reaction to happen in, we were optimistic that okay, if we put a tubular reactor in the microwave, we know the temperature range over which will happen and the reaction will happen. I will get good, a good control on the nanowires that I want to make. Next slide, please. We did the experiments. Theoretically, we should be able to get 100% yield in about 5 minutes time with a good conversion and particles. It did not happen because at this point of time conversion was less because at higher temperatures the ethylene glycol was flushing out. So we had to kind of change the strategy. Next slide, please. Then we did some more simulations to find out that we need to have nucleation separately, growth separately. Next slide, please. Next. So we had nucleation in certain section, growth in certain section, and again wire formation in certain section. We modified the entire setup that we had, and we were able to go next back previous slide, please. Yeah, we were able to go to 100% conversion. The yield was above 90%. Next slide, please. We were able to get extremely kind of dense network of nanowires that was getting formed with a very good control on the wire diameter that we were looking at. Go back, please. Yeah, sorry. Yeah, previous slide. Yeah. So we have been able to run this system continuously for 5 hours without clogging. We were able to make the material in good scale at $9 per gram cost. Next slide, please. So we used it for making ink. So we coated the ink on a slide. We kind of put a simple battery and made a network circuit. You can see LED is glowing. The film is completely transparent. You cannot see what is coated there. So this news came in the Silver Institute, and then they published that we have a cheaper way of making the silver nanowires. Next slide, please. These are the two students who started this worked a lot for almost 3 years to understand most of the things. My student Jaideep Deshpande, he added a lot more engineering contributions to that. And this entire work that I showed on microwave is based on what Jayesh Sonone did. This entire thing was done from the funding from DST's Advanced Manufacturing Technology Scheme and some funding from CSIR. We have been working on many other nanomaterials at large scale. Thank you very much, and I kind of wish you a very happy birthday, sir, again. Thank you.
Hello, yeah. So we have the last speaker for the session number 2. And before we break, that speaker is Dr. Nitin Deshpande. He is also personally here, all the way come from Bangalore today. I will give a brief introduction about Dr. Nitin Deshpande. Currently, he is a CEO and co-founder of Trana Lab Private Limited since he started this activity from 2017. Basically, he did his master's in 1991 in chemical engineering, PhD Tech from 1995 under guidance of JBJ. He also did his postdoc in Birmingham, UK for 3 years. And then he had a good stint of 17 years in Hindustan Unilever under different capacities and different roles. One was as a research scientist, where he developed the pilot grey water recycling unit for the first Suvidha center of HUL. He was also a project leader for the abrasive liquid cleaners for the Japan and dishwash bars for the India. He also played a role as a patent attorney, qualified as a registered patent agent in India under the different areas like strategic management of IP portfolios. He has drafted and prosecuted 50 plus patent applications, won 10 patent oppositions. He also being the innovation manager as seen for the technology scouting and dealing with the architectures. So he also has the gold award for the injury-free site which he has achieved for 3 years at his Hindustan Lever stint, which indicates 3.6 million persons hours without any injury. That's a big achievement. So we have Dr. Nitin Deshpande here to take us through his presentation for next 15 minutes.
Thank you.
Thanks, Nitin.
Thank you. Yeah, full screen. Yeah. Professor Mashelkar, Professor M.M. Sharma, Dr. Mashelkar, Professor M.M. Sharma, Professor J.B.Joshi, Dr. Anil Kakodkar, Professor Pandit, and all my friends and colleagues. I am very happy to be talking. Just go back. Keep. So this is the subject. I think sir does not remember probably having taught formally. I do not know whether he has taught formally this subject, but this is what some of the things that we have learned. I'll talk a little bit about Prana Lab, but what specific things we learned about from him. Next slide, please, one slide. So these are very simple, 4 lessons. First, thinking big and thinking ahead, well ahead of time and really think big. So I may just randomly mention early 80s, CFD work and LDA work both started in LDA lab. That time the computer was of the size of washing machine and the disk was of the size of this laptop, the dimension. And it was not very, people would not have believed that you could do this kind of thing and open up so much area. And now we have seen Vivek Ranade, number 1. He started his entrepreneurship journey successfully with the CFD. Vivek Vitankar has recently got into that entrepreneurship journey, again based on CFD. And at least about 20 students have started their career path with CFD with when the starting point of this washing machine size computer which took several hours to do a single run. So this is something that is really big and it sort of gets imprinted. You think like that. You do not think small. That is something that most of his students you would see how that approach. Many of the greatest people have spoken. That approach is there. This is other one which I see, strive for perfection in every small things and everything. Now, many of these things are not considered to be normally research related. But when you come to entrepreneurship, you value this concept of rate controlling step and controlling resistance. So rate controlling step or controlling resistance can be the custom consignment not coming to your lab. It can be cooling tower not getting repaired. It could be so many things. So even some simple things like that, if you do it very well, at least lab efficiency is about 2 times, 3 times than what it would be otherwise. The other thing is, there is a he immunizes you, basically he gives lifetime protection against chalta hai attitude, chalta nahi hai. So if you have seen, many students will look at it, if he looks at the final printout of your thesis or of your chapter or something, the student is expecting that he is not going to notice a smudge, small smudge on the corner of a print. He is not going to notice, but he notices and you will not get through. So this is just a small, and he is not angry with it. His attitude is more of a Raja Ravi Verma who is giving final touches of the painting. So with that calmness, he is looking at all the topics. So that is one more reason why he does all the things with very large smile all the time. So this is, I have not seen, losing his smile ever. And the other part is, he is a force multiplier for people. So if, this is a military term, so if people are fighting in the night, a soldier which is given a night vision goggle is equal to 10 soldiers from the other side. So that's the kind of thing. He gives this kind of tooling as well as challenges, mental challenges to people to excel themselves. So now I'll come to, and the next slide. So this is the hardest lesson that I have seen from sir. he says that if you address a big problem, do good work, you will never have shortage of any funds or any such things. And many of us who have taken up this kind of journey find this to be most difficult to get that conviction, because when you are short of money, when the projects are not coming, things are not moving, then the thing is either Professor Joshi has to be wrong, but my conviction is Professor J.B. Joshi cannot be wrong. So therefore, the only thing that is, you are not addressing big enough problem, or you are not addressing good enough, you are not doing good enough work. So you go back and restart that process. Thank you. So this is now about Trada Lab. We are trying to create game-changing drugs using macrophage targeted delivery. You heard something like this with Samir's session also earlier. And the word Trana means protection or the defense. Next. So next slide. Thank you. So we are incubated in 2 places, Center for Human Genetics. I acknowledge grants from BIRAC, National Biopharma Mission, Biotechnology Ignition Grant, Agriculture Ministry, Karnataka government, and recently UK funding agency, which is not yet to be named. And I also acknowledge our clients from which who generate money, who don't know that they are funding this research, but who support us through our IP services and wet lab services. Next slide, please. So Nitin and my other co-founder, I must acknowledge, Ganesh, he is a life science expert from IISc Bangalore. I think you have seen our intro. Next, please. So we work in collaborative manner with all of these institutes with actual projects running and not only the signed MOU. So Center for Human Genetics, ICT, we work with Ratnesh, Indian Institute of Science, I'll tell you what, ICR, also IP licensed in from ICR, IIT Kanpur, NCBS, CCAMP, and the best people. Next slide, please. This is our team, small team. It's a mixed team of interns, MSc student, a PhD student, and so on. So these are the people, small team that we have. Next slide, please. But we have very big guns, some of the big guns behind us. So Professor Balram is our scientific advisor, particularly for protein chemistry. We since work in a disease area. Dr. Sanjeeva is the clinical genetics medical doctor, and AMR, and some of the people who have made the journey from the academic to entrepreneur. So these are the people. Next slide, please. We also, our extended expert team, Professor Gurunath, IIT, Professor Saudamini, NCBS Bangalore, and Professor Siddharth for macrophage. And we have started work with Professor Guru Prasad Aisar Tirupati for virus-related work. Next slide, please. So some of the recognitions that we have received recently. Next slide. Yeah, so one slide, one click. So this is what we do. Our science is mannose receptor and macrophage related. So what are macrophages? Are the large eater cells which recognize, eat and kill microbes. They also do autophagy, that is eat and clear our own dead cells and debris and trigger other immune cells. Next, one click. So these cells have something called cellular mannose receptor. This is called mannose receptor, the Y-shaped thing that recognizes microbes and debris, and it binds and takes them in, which is called endocytosis. One click. And this is a recycling receptor. So it keeps on cycling from the cell surface to inside and then goes back. So basically delivers the cargo. So next slide. So what is our technology is this, macrophage targeting molecule. This is my technology. Next, one click. So this is the one which is designed to, selected to bind very, very specifically to the cellular receptor on the macrophage, the mannose receptor. So it binds, and since it binds, it is taken inside, it gets internalized into macrophages, and it goes via non-mannose route. Because it is, although mannose receptor, this goes via non-mannose route. One click, please. Thank you. So what is our technology? In a short, I have MTM. I can attach any cargo to this MTM. And so the platform is I can deliver molecular cargo selectively to the inside of macrophages. This is the basis of the technology. So next slide, please. So now what cargoes we have been working on? The first cargo I'll just mention, large biomolecule is for Gaucher disease. the molecule has to enter inside macrophages to do its job. That's why we started our work 5 years on this. AMR is the another area, basically all anti-infective agents to kill microbes inside macrophages. Cancer tumor imaging can be done because tumor macrophages overexpress mannose receptors, so I can selectively identify them, and potentially certain cancer cells also can be killed because they overexpress mannose receptors. So there is single activity. Next slide, please. So first one I will talk about little bit, Gaucher disease. So this is the disease. All of our bodies produce this glucosylceramide compound during our metabolism process. And this is the enzyme which all of us have, which basically breaks it down to glucose and ceramide so that it is taken care, it is removed from the body. In this disease, this enzyme is either absent or not active. So next one click. So what happens is the substrate accumulates all over the body in all the cells. And all the dead cells eventually go to macrophages. So eventually it ends up into the substrate getting accumulated in the macrophages. So next slide. Next. So this is autosomal recessive. Both sides basically parents have to carry the same gene. And if untreated, this leads to death. This is the next, please. So there is a treatment. This is not a cure. This is called enzyme replacement therapy. The simplest thing, what enzyme is absent or not effective, you make a recombinant of it and push in the body. And that's the enzyme replacement therapy. And these are the costs. So these are three different, one originator, two biosimilars are there. In Indian context, a 10 kilogram child requires 30 lakh rupees worth of medicine per year. And this is required lifelong. And the child becomes 14 years, that cost becomes 1 crore because it's a 3 times. And it's a lifelong. And this in IV is needed every 2 weeks over a 4 to 6 hours. So this is the problem that we have taken up. So next. So the problem is very clear, affordability and this high frequency. So what we are doing is designing the same molecule and modifying it to make it 4 times better. So that can address essentially all sorts of questions in terms of administration frequency goes from 2 weeks to 2 months. Cost can be potentially reduced, side effects can be reduced. And this, if I were to make a biosimilar, it has no business case, no market. Whereas if I do this, there is a potential business case. So next. So how we have done it, I will not go into detail, but I will tell you. So one of the things we have done is we have improved the stability of the molecule. We designed the molecule to improve its stability inside the macrophages against the proteases that would be there, that are there in the macrophages. The second approach is increasing delivery. This is the approach that has generated our general technology. So we started, so traction, we are currently in talks with a large industry player on the partnership of taking it from lab to clinic. Next slide, please. This is, we'll quickly go through this. So this is the problem. 2019, it claimed 1.2 million lives directly and associated with 5 million deaths. In 2030, about 24 million people may get pushed into extreme poverty because of fighting this particular, because of the unemployment. And 10 million deaths expected in 2050, largest single cause of death if it is not treated. Because microbes are becoming resistant and pipeline is getting dry. Next slide, please. So these are the pathogens I found to be surviving and replicating inside that macrophages, whereas the job of macrophage is to be killing them. And these are bacteria, virus, fungi. So we have to work a lot, but currently we are working on the things which are marked in red. We started with TB is the most, and TB I would just mention, it kills 1.13 million people every year. And just to combine, COVID killed 1.2 million in 1 year, that is 2022. So this is sort of neglected disease. And dengue, there is no approved drug. So next. So this is I think I'll just go. So basically we would like to deliver antimicrobial cargo, the known antibiotic inside the macrophages to do its job. So that's the work. Next. And similarly, for dengue, similar thing, no approved treatment. Again, neglected disease, no approved, there is no drug approved for treatment of dengue. People only manage the platelet count symptomatically. So we have recently won a grant from a UK-based organization to develop novel antivirals against dengue, again based on the same platform. So it has started just recently. Next slide. And tumor imaging, I have just put it, I have nothing, we have, because I'm struggling to get the thing radio labeled. What material I have, I need to get it radio labeled with technetium-99. So if we do that, we have potential competition, we can compete well with something that is currently in the market. Next slide. So this is a sort of our typical pharma way of putting things, where what are our sort of work streams, and where hit to lead and lead optimization where we are. And this is just at the overall. Next. So this, again, I come back to this. So this is the lesson I keep on looking at it every day. We need to address a big problem, do good enough work, and hopefully we will not run out of money or the support that we need. And hopefully we are doing both of these, but jury is still out on that, we don't know. Thank you.
Thank you, Nitin, for wonderful presentation. I request the session chairman, Dr. Mashelkar, to felicitate Nitin Deshpande with a memento from Marathi Vignan Parishad and a fruit basket. This entire event is being hosted by both ICT as well as Marathi Vignan Parishad. Yes, sir. Sir, before you come up, I request Appa Deshpande sir to come and felicitate our chairman of the session. Please, sir. Then he will address. Appa Deshpande sir is a secretary of Marathi Vignan Parishad, associated for 50 plus years, author of so many books, and die-hard, kind of science promoter. To Dr. Mashelkar, Chancellor of ICT. Request Mashelkar sir to do the summarization part.
What an inspiring morning. Amazing. JB, this is the right tribute to you, because what was presented was what you stand for all your life: excellence and relevance. Every presentation that you saw had excellence and relevance written in bold letters over here. The session that I was privileged to chair, Parso, of course, I have known him for a long time at Reliance. I was chairing the Reliance Innovation Council, and I remember interacting with him, a young boy with great enthusiasm, great energy, which showed up here. And he showed it to us as to what are the lessons he learned from JB and how they were used by him. But more importantly, this entire process of not only cost reduction, the Max Pro intensification, and in practical terms, how it was used to make ourselves competitive. Prasad's work, Prasad Kokil's work, of course, we'll remember a lot that he talked about, but what we'll take home is the benzene model, C6H6. I absolutely loved it. In fact, I copied it, by the way. And that really sort of represents you. Amol Kulkarni, our own boy from NCL, continuous flow reactors. He has become a, if I may use the word, dada in that area. And among large number of things that NCL has done over the period of time, I can tell you this is going to be a real game changer. What he presented was something very, very specific linked to silver nanowires. But if you look at the expanse of his work, it's a game changer for chemical industry. He didn't talk about it. Neither do I have time to talk about it, but I can assure you that that is the case. And of course, Nitin's work on macrophages and what difference it can make. You know, the basic issue about India is affordable excellence. All right, providing the best of technological solutions most affordably, because normally that's a contradiction, and that's what we actually do. So it was, I would say, a feast, intellectual feast. May I suggest that we give them a big round of applause collectively. Now, JB, I'm going to embarrass you by speaking about you, as many have. You know, I have known JB from his student days, our Mahaguru, Professor M.M. Sharma. Then I am his student, and then our students, and then our students. There is a tree, you know, on which we had a sort of seminar here. So we all learned from him, and that's what we are trying to sort of take forward. JB, lots of people talked about your simplicity, your humility, your modesty. I want to tell all of you, these are attributes which are in short supply today. And I don't have to explain to you why I say they are in short supply. Humility in particular. Leaders must have humility. And his humility has helped us in bringing ICT where it is today. Because the journey, I remember, in a way, I was a student. I came here in 1962, joined chemical engineering, had lectures by Professor M.M. Sharma on mass transfer, thermodynamics, and chemical engineering, thermodynamics, and so on and so forth. Did my PhD with him. And then after I came back in 2004, because that was the time our UDCT became an autonomous institution, ICT. And I was the first chairman of the board of governors. And I remember we had Mukesh Ambani as a member. We had Narottam Saxena as a member. We had Anji Reddy as a member. You know, all our alumni who have done us proud and for whom ICT is at their heart. So 2004 to 2014, that was the journey, and then we became an autonomous, university, deemed university. Now, I remember that journey of making us autonomous would not have happened but for JB. And what was the quality that made it possible? His humility and simplicity. It is not easy to deal with government. It is not easy to deal with lower division clerks who behave, they are more powerful than the minister. To go there, sit silently, spend hours, I remember, to get things done. JB, we owe you sort of a great depth of gratitude for what you did at that time, because this will never be written about. And I know how it was done because sort of one actually sort of witnessed it. I must say that the purpose, perseverance, passion, they represent him because he always had a big purpose. Perseverance, a lot of you have heard about fail, and fail to me is first attempt in learning. And your best guru is your last mistake as well, as long as you learn from that. And that was the message that you kept on giving anywhere. Innovation, compassion, passion also is something that you had. And I coined the term solution engineering. You heard that, all right? And I called him a solution engineer. Do you know how that term came about? That's a very interesting story. This Queen Elizabeth Prize of Engineering, it's a 10 crore prize, it's considered as a Nobel Prize in Engineering. And I have been on its jury for 7-8 years. And I remember when I joined it, I was interviewed on what branch of engineering is going to be the most powerful in time to come. I said not electrical engineering, not mechanical engineering, not chemical engineering, solution engineering. Given a problem, how do you create a solution? And you are among the top few in the world as far as solution engineering is concerned, I would say that. And I say that because not because You did world-class research in multi-phase reactors, which is all being used all around the world. That was at the high end. But you provided solutions on cookers, household cookers. Looked at that making a difference to the society, all right, in terms of not only the cost, but the efficiency and the pollution and so on and so forth. Marathi Vigyan Parishad, by the way, has this motto of Vijnanam Janahitayam, science for the society. Am I right, Deshpande Sahib? And that's what you continue to do. You know, that particular work that you have done for solving the problems in villages of villagers is absolutely incredible. And like you said, scaling. He's a master because solutions are of no use if they don't make impact. And there won't be any impact if there is no scaling. And you have mastered that, and we saw sort of evidence of that. In fact, I would say he's not just a solution engineer, a Gandhian engineer. What did Mahatma Gandhi say? He said there is something for everyone's need, but not for everyone's greed. That means more from less you must get by conserving the resources. And more from less has been the theme. But Gandhiji also said science has to serve the poorest of the poor, so more and more, so more from less for more. His entire work can be encapsulated in that, by the way, more from less for more. In fact, I would say that, in fact, I'm working on something, a new book, where we are talking about constrained creativity, how constraint create sort of greater creativity. I think your work is very sort of typical of that. I would like to end because I don't want to stand between you and the lunch, but all that I would say is that I've enjoyed my journey from 2004 to 2014 as the chairman of the board. I enjoyed my journey from 2014 to 2024 as a chancellor of this institution, and this will be my last formal sort of address as a chancellor of this institution, as a chancellor, all right? Dr. Pandit, you can't imagine ICT without Mashelkar. I'll keep on coming, but as a chancellor on 21st June, there will be new chancellor who is better than me, who will be sort of announced, so that will keep it as a secret at the moment. So it is only appropriate that my journey began with you formally, not as a student, in 2004, all right, when we became autonomous and I addressed the first meeting of the governing board as a chairman, and I'm ending
मेघना सरांना घेऊन ये ना त्याशिवाय चालू नाही शकत. हातूला गेले होते. Hello. Welcome back. We will now start with the session number 3. And for this session, Padma Bhushan Professor M.M. Sharma would be the session chairman. And we have industry speakers who would be talking about their experience and how they got benefited through collaboratively working with Professor J.B.Joshi sir. So, Madam Sandra Shroff was to come, Vice Chairman of UPL, but for some other urgent commitment which is coming up, she has shared her write-up as a response to what she was to speak here. So, I am, with your permission, going to read about the speech which is being coming from Sandra Madam towards Professor J.B.Joshi. So, I read out. Professor Jeshtaraj Bhalchandra Joshi is an esteemed Indian chemical engineer, nuclear scientist, consultant, and renowned academic figure at ICT Mumbai. With a wealth of experience and expertise in the field of nuclear reactor design, Professor Joshi has made significant contributions to the scientific community through his research and teachings. Professor Joshi holds a PhD in chemical engineering and has dedicated his career to advancing knowledge in this field. His passion for innovation and discovery has inspired countless students and peers alike. As a faculty member at ICT Mumbai, Professor Joshi plays a pivotal role in shaping the minds of future engineers and scientists. His commitment to excellence and his ability to simplify complex concepts make him a highly respected figure on campuses. Throughout my experience, I have had a privilege of witnessing numerous interactions involving Professor Joshi. Whether it is be engaging with corporate leaders, academicians, scientists, students, or even the common man, Professor Joshi consistently displays a remarkable level of humility, politeness, and down-to-earth nature in his conversations. It is truly exceptional to observe that despite his prestigious title as a Padma Bhushan, Professor J.B. Joshi, He never fails to make the other party feel as though they are conversing with someone of equal standing. Professor Joshi is undeniably a source of inspiration. This ascertains from the fact that after each interaction with him, individuals are consistently left feeling motivated and enthusiastic about pursuing a new and innovative endeavors. His ability to ignite a spark within people is truly remarkable, and it is a testament to his exceptional character and leadership qualities. Professor Joshi's interactions have the power to instill a sense of purpose and drive in those fortunate enough to engage with him. Professor Joshi's research interests span a wide range of topics, including sustainable energy solutions, material science, process engineering, etc. Through his work, he strives to address pressing global challenges and pave the way for a brighter future. Under the guidance of Professor Joshi, United Phosphorus Limited, UPL Limited, has experienced tremendous growth and success. His dedication to mentoring our engineers and enhancing our processes has resulted in significant improvements in productivity, both in terms of quantity and quality. Through brainstorming, meetings and lab trials and extensive research and developments, Professor Joshi has played a crucial role in transforming our technology and achieving remarkable results. UPL Limited recognizes the exceptional value of research and development initiatives led by Professor Joshi. His guidance consistently leads to groundbreaking and innovative outcomes. What sets him apart from other researchers is his holistic approach, considering not only the scientific aspect but also the economic implications of the project. Professor Joshi's focus on ensuring the team is well prepared and self-sufficient throughout the research process is commendable, resulting it into a successful conclusion to each of his projects. At UPL University of Sustainable Technology, Professor Joshi's mentorship has had a profound impact on our students. They speak highly of his commitment to their learnings and his ability to inspire a passion for knowledge. Many attribute their academic and professional achievements to his guidance. In fact, two of our students have proudly completed their PhD under his supervision, and their exceptional performance is a testament to his mentoring skills. Under Professor Joshi's guidance, we have undertaken various projects focused on sustainability and renewable energy. His expertise and leadership have been instrumental in driving these initiatives forward. Thanks to his visionary approach and unwavering dedication, UPL has been able to make significant strides in these areas. We are truly grateful for Professor Joshi's contributions to our organizations and academic institution. His mentorship and commitment to excellence have not only improved our productivity, but also shaped the future of our students. We look forward to continuing our fruitful collaboration with him and achieving even greater success together. Professor Joshi is not just a teacher or a researcher, but a guiding light in the academic world. His commitment to excellence, passion for innovation, and dedication to his students make him a true asset to ICT Mumbai and the scientific community at large. Professor Joshi is completing 75 years of his presence on this planet. I wish him healthy and prosperous life ahead. Warm regards, Mrs. Sandra Shroff. Thank you, madam. So, after this, the speech from Sandra Shroff on her behalf, which I could narrate, I would now call upon Rao Saheb Patilji, the Managing Director and Survey Server of Technoforce, Nashik, and he would come up and share his experience of collaborative working and about Professor J.B.Joshi. Rao Saheb, please.
We current control. Professor M.M. Sharmaji, Mr. Kakodkar, Dr. Mashelkar, J.B.G., Mrs. Joshi, Pandit Aniruddha, Mrs. Patil, and friends. I think it was around 13 years ago I approached Joshi ji to mentor Technoforce, which was a very small organization, probably the smallest organization he is mentoring. And maybe because of his time limitation, he was a little reluctant. And I had to be very creative to win him over. I will not tell the story, what I argued and what had happened. But after that, it was very enriching experience, me as a chemical engineer, and a very fantastic journey for Technoforce. I think right in the beginning, he suggested that we sponsor a project to ICT. And the project was to simulate the 9 classical textbook crystallizers using CFD. So we had to get so many licenses, which Technoforce provided to ICT, and a 100 node processor. I think that time it was quite a big thing, and it was installed a few meters away from here. And it was, I think, 1-year project, and I will not go in all the details, but just an example. This is one crystallizer which we simulated, and you will see that the circulation from the turbulent energy dissipation is very high, and that can break the crystals and produce secondary nucleation. So Technoforce started thinking about these issues. And I think we studied all the pluses and minuses of all the crystallizers, and then we decided to come up our own design, and we did that. I think in the end, you can see this summary on the right side. The turbulent energy dissipation has come down from 2000 to 0.3 in our design. And it is, I think, and this is probably one of the best crystallizers available in the market today. And it's a continuous crystallizer. This is another example where cavitation is studied for the axial flow impeller. And of course, once you identify the problem, you can solve it using CFD, of course. This is also very interesting application where we wanted to have a entrainment separately in a molecular distillation equipment. Now, the molecular distillation equipment itself works at 0.001 millibar. And then we set a constant, like the pressure drop in the entrainment separate should be maximum 10% of that. That is like 301 millibar. And using CFDs, I think we came up with a very good design. And this is how the products become robust. I mean, one can copy and look alike distillation equipment, but whether it is robust, whether it really, we know like what is happening inside, that's very critical. So I think when we were working on these kind of challenges within our organization, I think we started getting some ICT students getting associated with Technoforce. And in the process, I think we produced about 6 PhDs. And 3 of them practically worked in Nasik full-time and worked in laboratories of Technoforce. And that time, I think our staff strength must have been 60. So 10% is, I think, it's a very good figure. Okay. So still we are a small organization, mainly committed to convert batch processes into continuous. I mean, that's our business model right from beginning, like convert batch into continuous, and these are separation or purification steps. These are now, of course, we have grown a little bit. Still, we are a small organization, but we have about 1,000 plus references. We have a pilot plant in Europe. Whatever we have in Nasik, also we have in Netherlands, and also sales office in Germany. And almost 40% of the turnover is coming from the demanding market, that is Europe. these are some, just a glimpse. Again, a short part distillation equipment. Now, what you have to understand is that this setup has a capacity of 14 tons per hour of distillation, operating at 0.001 millibar. So one thing is that you can get such vacuum and operate continuously at such a low vacuum. And most important thing is the trials were taken on an equipment, pilot plant, which was 10 liters per hour. So to scale up from 10 liters per hour to 14 tons per hour, you need to really understand what is happening. And there I think is spending time with Professor Joshi. He won't know in what way he has contributed. This is the person standing in front just to impress you about the size of the equipment. The Taylor vortices in annular centrifugal extractor was very interesting. I think also produced a couple of PhDs. And this I think we studied it and we have further modified it. Really, we have decoupled the mixing and settling in a very, very interesting way. This is counter-current contactor, liquid-liquid extraction. And how to improve the stage efficiency was the topic. And based on this understanding, this is a very recent example. Like we supplied one liquid-liquid extraction for 7.5 tons per hour. And the trials were taken at a 20 liter per hour, again, in the typical pilot plant. And after commissioning this equipment, because the original inquiry was for 70 tons per hour, 70. And we said, no, we cannot scale up from 20 liters to 70,000 liters per hour. So let's have a pilot plant somewhere in between, okay? And this is a pilot plant for that company, 7.5 tons per hour. And within, I think we designed for 7.4, we got about around 8.5 tons per hour capacity after commissioning. Within months, we got the order for the larger one. And these are the extractors, each 35 tons per hour. They're ready for dispatch. This is come from Germany. I mean, most of my competitors are in Germany. Recently, we entered flow reactors. Recently means during COVID, we used to get a lot of spare time. I used to keep talking to Professor Joshi on phone. And we started in a very small way. What we did was whatever equipment we were making for separation, like thin film evaporators and extractors and crystallizers, why not we converted them into, say, reactors. This is the starting point. And all these are plug flow, very nice plug flow, all this equipment. So it was easy. And we could cover a range of, let's say, a reaction time of less than a minute, thin film equipment, to a couple of hours, crystallizer. We could handle slurries. We can have gas liquid. So I think even these three equipment are quite versatile as reactors also. So this is it's a complete plant for pharma, and it has reactors and downstream separation equipment, which is our traditional business. Probably this is the first Indian pharma plant which is one molecule A to Z is continuous. I think so. Okay. Now, what we find that it is the medium-sized companies which are very aggressive while going for batch to continuous. Small people, of course, they will wait for these things to get matured. Large companies have their own problems, and these are the medium companies, like in pharma, I would say up to 5,000 crore turnover kind of a companies are very aggressive, very committed to convert batch into continuous. Just a case study, like in this case, there are 5 reactions, and there are quite a few separation equipment. So each stage is defined by a reaction. That's the first step. Because reaction, separation, then reaction, separation. 5 stages. Now, what I want to impress upon you is the reduction in volume. So the volume of the batch, which was around 54 meter cube, was reduced to less than 1 meter cube in a continuous flow. And the time was reduced from 162 hours to 11 hours or 12 hours, let's say. So this is the impact. Now, the reduction of 150 hours for this specific case, 45 hours only came from continuous reactions, which is glamorous, okay, and 105 hours came from continuous separation, less glamorous, okay. So, lot of opportunities for this this thing. I think we keep cribbing about the China subsidies and this and that, but the fact is that Chinese people are at least 10 years ahead of us in continuous manufacturing in chemical industry. So, and our experience with whatever few cases we have handled is that at least 20% cost reduction when you convert batch to continuous. Even if there is no additional yield, no chemistry advantage, just by simple engineering, less utilities, less energy requirement, better solvent recovery, and that's enough. And if you get some advantage in conversion, which you many times get, in one case we got a price reduction, cost reduction of 50%. That's exceptional case, but anything between 20 to 50 is possible by converting batch to continuous. Now, many times these microflow reactors are pitched against kettles, batch reactors. And you see there is a huge gap. There is no overlap between these two, as if you either do it in kettle or in microflow reactor. And that's not possible, because not all reactions can be intensified so that the reaction time comes to less than a few minutes. Or microflow reactors have their own problems with multi-phase, slurries. So there is a huge space between these reactors. And with one brainstorming session with Professor Joshi, we came up with a figure of almost 40 reactors are required to fill this gap. And of course, maybe 15, 20 separation technologies. There can be more, but I think separation technologies is quite mature and a lot of suppliers are there. Conceptual level struggle is not there. So we decided to fill this gap. And we are going to make these 40 reactors and have pilot plants so that industry can benefit from this. And I remember now, this was the argument I made to win over Professor Joshi 13 years back, that if you, let's say, give a consultancy to UPL, what will happen? UPL will improve their processes, then what? It doesn't go outside UPL. But if you help us, we'll give services to hundreds of UPLs. And that multiplying, I think that argument was good enough, you know. And then he immediately said, okay, we are with you. Okay, so we are talking about, let's say, 50, 60 pilot plants, or maybe more. Reactors plus separation equipment. Now, we have a pilot plant now which has about 10, 15 pilot plant setups for taking trials. And it's not possible to accommodate all these 14, 16. So we have started construction. This is almost complete now. Maybe another 3-4 months, we'll start shifting operation to the new facility. Now, this is going to be 80,000 square feet or 2 acres of footprint. And this will have all these 60, 70 pilot plants eventually, take a couple of years to establish that. We'll be investing a lot in kinetic studies. We want to bring in university capabilities to industry. So really Technoforce is a intermediary between academic and industry. We want to really connect these two. So all this scattered knowledge in so many places in industry and whatever is relevant, immediate relevance to industry, we want to bring it in this kinetic laboratory And this is going to be the major investment. I mean, pilot plant is very obvious for us. We know how to do it. We are doing it for since existence. And this is something new, and this is going to be very, very exciting for us. For example, recently we are using this inline FTIR, and not only for reaction kinetics, but we are also using for crystallization, for example. Like we have used this to, for example, measure the growth rate of crystals without looking at the crystals, looking at the mother liquor, how the solid is dissipating, at what rate it is dissipating. And it's very, very interesting. I mean, we just keep thinking where else we can use it, and almost every day this device, we are using it. So we also started discussing, like I shared my experiences, like when I go to industry, I talk to customers, and there is a meeting, and there are some guys from R&D, and there are guys from project, same organization, and I see they are not able to talk to each other. And then I said, I think we should, why not train them, so that they at least learn a language. They need not become expert. Neither the project engineer is supposed to design the reactors, neither the R&D guy is supposed to learn chemical engineering. But can we teach them the common language? So we decided why not. So we decided to come up with the training modules, 2 modules, chemists, scientists, and let's say chemical engineers. And the theme is how to convert batch process into continuous. Just to give them the roadmap, just to tell them how to do, what are the steps involved. Especially respect the data. That's missing. Okay. And I think when I started talking to some of my customers about this possibility, they're really excited, and they're really waiting for these 2 modules to come up. And then we again thought, why not we also extend this to college students? It may not be 1 week, say, theory plus practice, because these industry guys will be theory plus practice. In fact, I had gone to my college, I'm from BHU, and I asked the professor, can you recommend some good chemical engineers from the class, final year, so that I will give them free exposure? He said, I don't know. Who is going to stick to the core? So it's very difficult. So I said, forget it, not to talk to college and ask them such a difficult question. We'll go to industry, and any engineer who is still around in the core for 3-4 years, that means he has decided to stick around, and these are the guys who will pick them up. Let the industry sponsor them, and we'll. So for college students, it's going to be maybe a day of exposure or 2 days of exposure, without bothering whether they're going to stick around the core or not. But at least maybe some of them will realize it's not that bad. It looks interesting. So maybe some of them may change their decisions. And this is a picture which is drawn by my grandson, which is 8 years old. And my daughter is chemical engineer, and he was having some books in the house. And he happened to scan through Albert's, and there was a chapter by J.B.J. in that, I think. And he saw some reactors, sketches. And he said, oh, this is interesting. He's 8 years old, 2nd standard. So he drew a reactor himself. I mean, a lot of things are here. I can see some photosynthesis here. Some gas is coming here, and you can see the molecule also. This is not H2, it is 2HO, C9O, some Roman this thing, DO and R. I don't know what this new molecule is. But he also wrote down a molecule. And of course, some carbon footprint, you can see a stack, and I don't know from where he got his ideas. It's not a simple copy, no? A lot of imagination is there. So I think why we are talking about project engineers and chemical engineers, why not school people also? Maybe through Marathi Vidyan Parishad, I think we should try to give exposure to even school kids. And maybe some of them at a very early stage it may trigger something, and they will try to do something what they like. Today the problem is, people get distracted by what packages they get, and they don't care about what they like. So hopefully, these kids at a very early stage, if they get triggered what they like, and they may stick to this, they will select the right course, and probably will get the right students, okay, which are really motivated. So I think we have a lot of ideas and a lot of work to do, and we'll keep working with Professor Joshi to sharpen the tools from time to time. And may God bless him with a long and healthy life. Thank you.
Thank you very much. The name itself of the company is Technoforce. I can see that you become a force for all technologies from the batch to become a continuous, and really appreciate your efforts and plan for training. I would request the session chairman, Professor M.M. Sharma, to felicitate Rao Sahib Patil ji for his fantastic talk. It's a memento from MVP. Thank you both of you. We have Mr. Pramod Chaudhary, Chairman and Managing Director of Praj. He is being patiently waiting online for the address to this event. Can I request the AV to get him on the line, and whether we can see him, and then I request him to virtually.
Yes. Yes, thank you. Very good afternoon. I wanted to be personally present in ICT today. Unfortunately, because of some health reasons, I could not. Encyclopedia of his knowledge in chemical and nuclear field. I got to interact with him on a number of occasions. He is down to earth, good human being, more so of a patriotic and eager for nation building ideas and environmental consciousness. He's been a successful professor and mentor. Many of his students are working for me in Praj. I never got a chance to be in ICT, but people who have studied with him, under him, they talk very high of him, and I can imagine that quality of his education, his teaching has been excellent and long lasting for the students. What has really touched me more is about his role or his contribution to science and society. That is what is really I would like to talk for a while. He introduced me to Vijnan Parishad, Marathi Vijnan Parishad, and the various actions or activities he is carrying out there are very, very interesting, not only interesting, very appropriate. Promoting science awareness among the school-going children is one of the hallmark of his efforts, and conducting the classes on the weekends to create the interest about the students and get them engaged with various science and technology streams. He has tried to integrate science and society. We had a chance to participate, contribute in that area too. The list is long. He's having a very innovative and sensitive mind with respect to especially the rural development work. Very many ideas he has exchanged. That's one area where we commonly believe that for the progress of the country, rural progress has to take place based on technology and science, and that's where we really share common goals. What way we can help increase or add value in the processing of those products, those raw materials, those feedstocks, to create value for the farmers, value for the rural area. I believe that it comes out with a lot of ideas and very, very original ideas which can be supported for benefit of the masses. We have participated in few of such ideas. I'm happy that he is completing 75. Age is just a number, but his mind is very, very alert and very creative. I'm sure he will be able to pursue his passion uninterruptedly for his students, for the country, for the institute, and make it available to one and all in full measures. I wish him a very long and healthy life and contribution to the various aspects of science and technology. Friends, I've seen a long list of experts, luminaries who have spoken about him and his areas, who are directly come in contact with him perhaps. And as I say, comparatively, I am least connected with his subjects in the past. What I have seen him in the recent past, I always feel I wish I had known him earlier. I missed in my life, in my professional life, not to know him earlier. And that's where my sadness is there that I'm not able to leverage or benefit from his alert mind and knowledge and expertise. Anyway, thank you very much for this opportunity. I wish Dr. Joshi good luck and healthy life. Thank you very much. Bye.
Programs at Parishad, so also like projects in our ICT. Thank you, sir, once again. Thank you very much for being with us virtually. Now we have the last respondent from the industry segment, and that is from ChemDisk. So can I request Mr. Tushar and Sunil Dhole? After this, a small correction, Mr. Abhijit from Lakshmi Industries. I think you are also reported on behalf of Ravi. We could not meet, but you will be the next. Sorry for that. Tushar and Sunil, who will come first? They both have come from Pune, from ChemDisk, and they would like to not present, but share their views about associationship and guidance of Professor J.B.Joshi. Please.
Thank you so much. Thank you ICT, thank you Marathi Vidnan Parishad. So we both were traveling till yesterday night, me and Tushar, so we could not prepare any slides, but there is enough content. You very rarely go to the meetings where Padma Bhushan becomes a prefix. It is one of those meetings. So all the respected dignitaries, Dr. Kakodkar, Dr. Mashelkar, Professor M.M. Sharma, Guru of our Guru, Professor Pandit. Probably I am the youngest industry collaborator Professor J.B.Joshi is having. Maybe youngest and naughtiest. So the kind of relationship I have developed with him, I always keep telling him that I am one of those who comes from the IIT system but working with UDCT or ICT. So most of the time I get criticized for the same. But nation building is what matters. Society, service to the society is what matters, and that is what Professor J.B.Joshi has helped us understanding with. So I have been a student of Professor J.B.Joshi and Professor A.B. Pandit in UDCT for a very short period of time, like 3 months time, and then I got a call from IIT Kanpur. I left this place because the scholarship there was higher. But fortunately, the turn of events, I did my PhD and then I worked in Europe and came back to India, worked with Reliance, but then I started my own companies. One of them, a few of them are with Tushar. And during the first wave of COVID, that is when I reconnected with Professor J.B.Joshi. So during COVID, you know that no Indian company was manufacturing the oxygen concentrators. And somehow we had developed some know-how as a ChemDist. So ChemDist is mostly known for the various separation technologies. So jokingly we tell people that except husband and wife, we can separate everything. But if they are separated already, we don't make an effort to bring them back together. So So we came up with this oxygen concentrator during the first deadly wave, and we were struggling with the zeolite media. So very costly media at that time. That is when I reconnected with Professor J.B.Joshi, and we designed a distributor for these zeolite columns. Typically in 10 liter per minute zeolite or oxygen concentrators based on PSA, you need around 2 kilograms of this media. So with the CFD and this distribution design, we reduced that 2 kilogram to 0.9 kilograms. And we kind of commercialized it within 15 days. And we got the order from PM Cares that time, and we could save lakhs of lives in the state of Maharashtra, Chhattisgarh, and Goa. So that is when we started working together. Then, of course, we are also known for, as I said, in separation. So you might have heard about a water purifier called Tata Swachh. It's a household non-electric water purifier, comes from our group. Through that, we are serving around 80 lakh people in India per day. So we are working with JB sir on multiple projects. So one of the very high profile project right now is green hydrogen from bioethanol, which has become also a part of the hydrogen mission by the government of India. We are working on carbon capture to nanourea. We are working on cracking methanol to hydrogen, but without generating CO2. So we crack it to hydrogen plus formic acid. So reflecting on Professor J.B.Joshi in few minutes is like you are asking a PhD student to defend his thesis in 5 minutes. So it's a very, Professor J.B.Joshi is what I personally feel and see is that he is not an individual, but he himself is an institution. He is a subject in himself. So, and by every means, he is a true chemical engineer, not just by practice, but when I say true chemical engineer in the sense, he is always linearly stable, always thermodynamically under equilibrium. And the person I have seen, helping chemical industry and all, you need to have a very, very defined set of clear boundary conditions to make it successful. So that is what he implements in his own life. That's why he is not just by practice a chemical engineer, but he is implementing that everything in his own life. And I have been all this while, when I got this invitation, I have been thinking on what should I compare him with. And fortunately, last week I was on a Himalayan trek. I don't know if there are any trekkers in the hall. I was trekking in Alibedni Bugial in Uttarakhand. And that is when I got a comparison. So you see all these huge mountains with lots of resources, but they are still humble. That's what I compare him with. I remember our very first physical meeting with Professor J.B.Joshi, myself and Tushar. We went to his place. It was raining. And all the students, of course, we are all good friends. So most of them scared us. Be careful about the timing and all that. We reach before time and all. So we reached his place. The meeting was at 3 p.m. We reached at 3:30. And we were like pressing the bell, banging on the door. Nobody was opening the door. So we thought maybe he doesn't like coming early also. So, but after 10-15 minutes, we came to know that we were banging on the wrong door. So he comes out from the other door and he says, "Are ithe kai kartoy tu?" So anyway, lots of things to talk about him. But as I said, I am the naughtiest one. So I would like to end this on a very lighter note, sir. So a couple of weeks back, he was at the ChemDis facilities in Pune. So we were, of course, discussing the scale-up of this hydrogen plant and all. He was supposed to be back to his place by 6 p.m. and ma'am was calling him constantly, and we were still at the office at 7 p.m. And then I asked him, I'll use this in Marathi, "Sir, घरी गेल्यावर काही problem होईल का आता?" He said, "Maar to padel mala." But then I asked him, "It happens every day to me. I'm sure it must be happening to you. So how do you handle it?" So here comes his magnanimous speech, smile, and the thing he said is, "I don't react." Thank you so much, and many, many happy returns of the day. Thanks for your blessings, and God bless you. God bless all. Thank you so much.
So, good afternoon, everyone, all the dignitaries. I will like to, start the session where Sunil has ended it with one more humorous incident what we had. See, all of you know that, Professor J.B. Joshi is like mainly known for his skill, knowledge, and humbleness and all those things. But at the same time, there is a small child also inside him, which makes us like, everybody like when we are interacting with him, we always fear like interacting because that fear is out of respect, because all the knowledge and the work what he has done, when we are standing in front of him and discussing, then it's always difficult for chemical engineers like us to discuss anything with him. What like one incident, like when we are one meeting attending at his home, there was a lot of things written on the board, and we open a topic about some gas induction reactors. And at that time, he literally went to his original nature by explaining on the blackboard. So he started rubbing the board. So we asked, "Sir, can we rub it? Because it doesn't look good, like, we are sitting there and he's rubbing the board." So we asked him, "Sir, can we rub the board?" He said, "No. एक सांगतो तुषार, मला बेस्ट टीचरचं अवॉर्ड मिळालं होतं आणि हे अवॉर्ड जेव्हा मिळतं तेव्हा बरेच स्टुडंट्सकडनं फीडबॅक घेतले जातात. तर त्याच्यातल्या एका स्टुडंटने सांगितलं होतं की सर फळा खूप छान पुसतात म्हणून ते बेस्ट टीचर वाटतात आम्हाला." So this is how he ensured that he break the ice and started the discussion, and that really made newcomers like us from the industry to be very comfortable with him. We really thankful to you, sir, for all the kind and wisdom what you have given to us, and many more projects what Sunil has already covered. We are working with him, and we wish we could have interacted with him much earlier. Then would have been like different level. Thank you, sir. We wish you all the best.
Thank you very much, Tushar, and of course Sunil, both from ChemDisc. Both your anecdotes in the lighter vein added the spice to the entire kind of a backdrop of presentations which were more of technical. And Sunil, your idea of no reaction itself is a good action, is a tip for many of us. So we will definitely try to implement. Can I request Chairman here to felicitate our two speakers from ChemDisc. In the meantime, I request our friend from Lakshmi Organic, Abhijit, who would be representing on behalf of Ravi Goenka ji, because he is on the way from Europe, and I believe at that time he must be in the flight returning to Mumbai. Thank you, Team ChemDisc. Can I request Abhijit, Lakshmi Organics? I think you are going to address on behalf of, or you have, yeah, please. Stage is yours.
Good afternoon, all. I think big dignitaries, Padma Bhushan Professor M.M. Sharma sir, Padma Bhushan Dr. R.A. Mashalkar sir, Padma Bhushan Dr. Anil Kakotkar sir, Joshi sir and madam, and all my sirs and all the friends here. This is a great honor and privilege to stand here and talk about Professor J.B. Joshi. To get this opportunity to speak here, it's a big thing. I think what to start and where to start is the first thing that comes to the mind. Let me begin the journey that Joshi sir has started in association with Lakshmi Organics. That's something what Ravi sir has told me. It started with more than 2 decades before, and it started with oxalic acid, 24 years, 40 years. And it's started with the oxalic acid project. I think it's had a lot of difficulties in establishing during the project at Lakshmi Organics. But with the guidance of Professor J.B. Joshi, this was done. There were numerous projects that were done with Professor J.B. Joshi at Lakshmi Organics. Let it be ethyl 4-chloroacetoacetate, or ABL, the ethoxylator reactor, diketene relocation plant, or first time we produced diketene at Lakshmi Mahad. The new plant was designed under Professor J.B. Joshi's guidance of 40 tons per day, and we are the largest manufacturer of diketene today in India. Multiple projects there were taken for the yield improvements of diketene capacity improvement, furnace design, that was the part. So all these improvements over the years that has been discussed and taken up. And actually, sir's one thing is very good, that he asked students to calculate all the things from the from our company, and he only guides that you do, and again I will check. But that experience you have to come with. The recent projects that we are working on ethyl acetate improvements, I think, sir, there are multiple projects that we are working from last so many years. And I would tell you that Lakshmi has actually got a significant growth has come just because of Professor J.B. Joshi for the Lakshmi Organics. Okay, I will tell about my association with Professor J.B. Joshi, sir. I think in 2003 when I joined UPL, that's the time when I met sir. And it was all the meetings in the evening at 6:30 at ICT, or you say at head office at Mumbai, or at J.B. Joshi sir's home. So a lot of discussion that happens. And same continued at Lakshmi also, alternate weeks from last 6 years at LOIL. A lot of technical discussions. Every time we go with lot of questions, problems, difficulties, and when we come out from the discussion, we feel energetic. We feel the problem is so easy, it can be solved. The guidance that sir gives, it's really helpful. And he always asks to do the calculations and come to the next meeting. Okay, I will tell one story that I remember, which was in my previous organization, when sir has come once to Jagadia. And a whole day that session happened in the evening. We came to the hotel, and I was just helping for the check-in process. At that time, the person after the check-in, sir asked, is there a Wi-Fi at the home, in the hotels, and what's the password, what's the time? So he said, okay sir, this is for 4 hours and this is for whole day, this Wi-Fi. And this is, don't worry, this is on the company. And sir reacted very slowly, said, anyway, this company is mine only. So this was the instance I remember when I was at UPL, sir. A lot of things to learn from him. I think a lot of speakers have told about it. But one thing that clearly I feel is the time management. Sharp the meeting starts at 3:30 means it will start at 3:30. If your watch is stopped, you can please correct it and you ensure that it is 3:30 when sir comes. I think the respect, the time or the punctuality what sir has brought, it's tremendous. He's always ready to guide on any complex subject, any technical discussion you bring to his table. He will always guide you, but in a scientific way, in a calculation manner and everything. That's really great. I think it has been a great learning journey, I would say. I would thank Professor J.B. Joshi from my heart. I wish sir a very healthy and happy life further. and I wish to get the continued blessings from him every day of my life. Thank you.
Thank you, Abhijit. Please convey our thanks to Raviji, because on his behalf you could come and address it. And I only can say that you are from Lakshmi Organics. When Saraswati meets Lakshmi, possibly the only thing which is only flourishment. Thank you for that. Can I request the chairman of the session to felicitate Abhijit from Lakshmi Organics with a dry fruit basket and a memento. Thank you, sir. Thank you, Abhijit. Before I request Professor M.M. Sharma to come and do a summarization about this industry speakers session number 3 and his own address on behalf of this event, I would request Vice Chancellor ICT, Professor A.B. Pandit, to felicitate Professor M.M. Sharma, thanking him for his time. Since morning he is being here, a guru of Professor J.B.Joshi, Dr. Mashelkar. You might have heard about the Intel processor, but somebody who is with sharp memory and tremendous storage space, we are going to definitely hear him out now, far beyond Intel intellectually. Can I request Sharma sir, please? Sir, you going to see?
House is full. Isn't that a great tribute to Jaisraj? It has been an exhilarating experience today. Since morning, everybody is in place. Accolades. I dare say the JB will have problems in holding on to these accolades at the end of the day. Mrs. Joshi, Anirudh, his JB's son, his wife. First of all, presentations were very interesting. UPL, you saw the turnaround because you heard the presentation, and also the written message from Sandra Schoff. His association with UPL has been long, and it's not an easy industry to deal with agrochemicals. I'm very happy that he has made such major contributions to make the company more and more profitable, except in the recent past, for which he is not responsible. What do you say? Well, the other presentation, I'm particularly struck by the entrepreneurship of Mr. Patil. What you have done in Technoforce is really laudable. I had not met you, but I did induce people to go and get something done in your establishment, particularly on liquid extraction, because industry people, even if they tell them that this will work, they still want proof. It's amazing that with all these advancements, they would insist on pilot plant. When I would say, I am reminded of a very early topic in Institution of Chemical Engineers, UK. The topic was dropping the pilot. Since JB has done a lot of work on CFD, CFD is the one which is avoiding pilot plants. And I am very happy about it, because pilot plants cost a lot of money, you waste a lot of time. And at the end of it, the uncertainty still remains, by the way. And except when you are doing something for marketing, that you want to test market the product, is a different story. Lastly, you also heard about the young people who have come up and come in a very ingenious way. Yesterday I was addressing them on Rotary Club. Since he mentioned about PSA, I said, everybody in the society hears this name, RO, PSA, but you ask them what do they stand for. He said, wo mat pucho. And PSA is one of the greatest contribution of chemical engineers, and the first major contribution out of simulation. in the history of chemical engineering. Without simulations, you couldn't have designed pressure swing adsorption. Then came vacuum singlet. But many interesting things. New materials are coming. You're getting MOGs and COGs, and thing is going to change. You're going to get adsorbents which will reduce the weight from 0.9 kg to further, because you will get areas going up to 10,000 square meter per gram. 3,000 is already there. So the presentations were very, very, very good, and I am happy to see. The tributes that have been paid to JB are not only very, very pertinent, he deserves much more than that. I am going to talk on something different. I take you back, my association is 55 years ago. 55 years. Huh? So I'll give you the first important description. Here is a diminutive, shy, bit of a nervous fellow entering my room, professorial room, which I occupied for 33 years. I looked at him and I found him physically weak. I said, something is wrong. I didn't discuss the subject that he was to discuss with me. I think it was his design paper. So I said, you better take more nutrition. Then I talked about the second incident in presence of his wife. He was living in Chunabhatti. I said, JB, you are making good money. Why are you living in Chunabhatti? You must go to a much bigger place. Simplicity, he didn't want to. So I used some strong words. I said, if you don't take a decision today, I'll lock you up in this room in my house till you yield and say that you are going to take. And those of you, many of you said they have gone to his residence in Hindu colony. Of course, forget about the appreciation. The fact that he moved to a bigger place where he could have a board and all the discussions which might not have been possible in Chunabhatti. So that was another major outcome. Now I take you back, because he's one person, when we had the post of demonstrator, which was then called associate lecturer. So he was demonstrator, he was lecturer, he was reader, and he was professor. He went for postdoc 2 years, earned enough money to invest into his Chunabhatti flat. And his first student, Anirudh Pandit, I made him wait for 4 months till he returned. And it's a different history. For me, it's a day when I'm really basking in the glory of Jayashraj. But the person who should have been here to talk about this consulting, unfortunately for some reason couldn't come. That was Bombay Oil Industries, Mariwala. And I want to quote that example. Kishore Mariwala being my great friend, I said, I have a young chap who is very good. You take him for this 2 months vacation assignment. He had an electrolytic hydrogen plant making fatty amines in Bhandup. So JB's career started there. His first assignment was rigorous material balance in the whole company. And he endeared himself so well with Mariwala that all his life he has had, and as a tribute to Kishore Mariwala, and out of his own graciousness, he gave a large sum of money to Indian Chemical Council to institute an award in the name of K.V. Mariwala. That must have continued maybe from 73 till now. Look at the length of time he has been associated with a company. Now I'll take you back to the time when he was doing PhD work. Because hardly anybody will be able to give all those anecdotal part which I am telling because of my very long. We had a 1 meter diameter acrylic column, 3 stages, 1 meter plus. He was the first one to use radioisotopes. And in those days, the technology was such that you had to bring those big lead thing. Later on, technology changed. And that piece of work which originally Ramesh Mashelkar started on bubble columns, he took up. And many of you wouldn't know the first instance in the history of chemical engineering where the predicted value of backmixing was matched with experimental results. Theoretical predictions were matched to start with the horizontal bubble column kind of device to the standard vertical bubble column. But the anecdotal and incident part was, here is a tall column and here is a tiny fellow in front of it. So it was the most amusing thing. And the acrylic columns were being fabricated by B.S. Rajpurohit in Devnar. So he would go there and see that columns are done post haste, not per normal schedule, because being an ex-UDCT person, my lifelong friend, UDCT started using acrylic equipment only after 64. There was no acrylic equipment and we started, and those days, foreign exchange problem was so acute. My God, we couldn't get the adhesive, the resin. So if I was going abroad, so one of the things we'll bring from abroad was the cement for acrylic columns, which, having worked in Cambridge, they were graciously giving me half a kilo or a kilo, which I'll bring and use in the column, because even Rajpurohit's company couldn't import. The youngsters today do not know what kind of difficulties we went through in doing research. How to get more out of an existing rotameter. So just change the flow, different material of construction from acrylic to more dense materials, and change the range, and then how do you calibrate? Ramesh did Mashelkar, large size bubble columns. But still bigger columns were, nobody in the world had operated the soap fill meters of that diameter, no one. We had no ways of measuring, so we said, let's try. So we used soap fill meters, I think going up to 10 centimeters, unheard of. So necessity is mother of, you don't cry. I think engineering teaches you to solve a problem, get things done, make things work. That's the motto of engineering education. The other point I want to emphasize, I am never tired of repeating that in this very auditorium, the DNA of, and how it is epitomized by JB. Excellent teaching, excellent research, excellent scholarly writing, and superb consulting. So I must give you one or two anecdotes of consulting work. He started in that small way with Bombay Oil, and he became the most expensive and the richest consultant in chemical engineering. I want to give you an instance of what used to happen in this highly rated Bombay University. And the then Vice Chancellor, I am arguing with him that why are you putting limit on our consulting fee? My example is very simple. You are next door to the High Court. The advocates come and start stopwatch. And what fees they charge? Here you are taking away 1/3 from our income. Out of the remaining 2/3, in those days almost 45% was going in taxes. So why are you, what is it coming in your way? We have restrictions of the time a person can spend. We succeeded in convincing, and we got rules revised, so the consulting fees became much higher. So I said it was good occasion to strike further. I said this is the authority given to the director, that up to this limit, except for himself, he was always the scapegoat. He had to take every permission from the Vice Chancellor, but all other faculty members in UDCT I could sanction as a director, then director. So I said, now it's a good thing. I said, sir, why you want to put a limit? Within this limit you have permitted us. Why not any amount? So first case was JB. And the letter that I wrote to the university, why this higher fees should be permitted to this great consultant, I think that wording, probably he has a copy. It is worth framing. University had no option but to sanction much higher consulting fee than the upper limit was always already more than 2.5 times the original. And we are talking of something still higher than that. And the university then had no excuse not to grant on the basis of the letter that was written from here. So, where is the journey? Journey from a summer placement to the serious examples that you saw today of consulting. I am truly amazed at the range of topics for which he has been consulting. But towards the end, I want to applaud two major achievements of his. First, garnering massive sums of money to put up a big hostel. I have a grudge because when I graduated doing masters, I couldn't get accommodation because there was no hostel accommodation. So I applauded him. That is very good that you got donations to put up this big hostel and solve this problem. Then getting donations after donations, but that apart, but working so hard to get the deemed university status. It was a landmark achievement in the history of UDCT. And it was not an easy job. You know, it's one thing to give a lip service that yes, you should be independent, yes, you should become. And Bombay University was scared that once the UDCT is out, their rating will go down drastically. So, silently they would work against it. But publicly they will say, yes, you should. Against all these, he was able to steer through because he doesn't fulminate. You know, when somebody is aggressive also, he'll still be cool. That is a very remarkable. But somebody told me that he does get angry. Since I have no experience of seeing him being angry, I can't say. But some people told me that, and some have reputation. I had a bad reputation that you are going to my room, don't forget your name. Somebody narrated, I said, I'm not that oppressive. Similarly, they used to tell, not easy to go and meet J.B.Joshi. I was wondering how can somebody be making statement of that? Like, it's so easily approachable. But students have their own imaginations. So they have all, oh, he's very strict. You can't meet him. Like that. I mean, and that the story goes on. You know, particularly in hostel, word of mouth. You know, ye hua, wo hua, you know. So JB, it has been a wonderful day. You got kudos. You deserve many more kudos. And you have been supported by your dear wife. She takes care of your, because if you tend to forget something, she's there to remind you. Because I noticed in last few months and some few years, last 2-3 years, that you have a constant advice from your wife to be on, to remember certain things. So I compliment you, Mrs. Joshi, for being a rock behind this fragile looking person, but is not fragile. So my own tributes to the genius of J.B.Joshi. I wish him, because he had gone through patches of bad health, so I wish him very good health and continue to work. And what he has done in the Marathi Vignan Parishad, Deshpande will, he's turned around that completely, taking science to remote villages in Maharashtra. What a model he has created. And it is not by the way, it is from the bottom of his heart, having come. So that reminds me that when he got Padma Bhushan and he went to his village, the villagers were so fond of him that they took him for an elephant ride. And I was wondering, on the elephant, somebody is sitting the comparison didn't look too good. But his greatness looked very great. So JB, all the best to you. Mrs. Joshi, all the best to you. Anirudh, where is Anirudh? Okay, good. And his wife, they are there to greet you. And he shuttles between Pune and Bombay. There are many more anecdotes I can tell you because of this long association which continues uninterrupted all these 5 years. But all I can do is to wish him best of health, and please contribute more and more on the various fronts. You cannot find a person who would have consulted in cooker at one stage, or the biorefinery at the other stage, or doing the design of large size contractors, and that too confidently. I was very impressed with the statement. He says, when Reliance people asked him, he says, if it doesn't work, I'll give up, give up practice. I thought that was the best way to convince the chap. I think very remarkable of him to say that. All the best to you, JB. Great.
Thank you very much, sir. As usual, it was like a blessings to all of us, a guru talking about our guru. And as you rightly said, he is not fragile, he is agile. So thank you very much. And that makes us to the summarization of session number 3. And I think we are very close to the time schedule now. And we will have a 15 minutes of a tea break. And subsequent to the tea break, outside this venue, we will reassemble and we will have the last session of the day, where the chairman of the session would be Vice Chancellor Professor A.B. Pandit, and that would be no much of technical sessions. It was possibly like homely kind of responses, and there are a couple of surprise speakers who have come all the way. We will tell more about that. So we will take 15 minutes break. Yes, we will have a group photo. Photographer hints me about session number 3. So Abhijit from Lakshmi Organics, Chemdesk, can I request all the dignitaries? Base. Hello. Yeah, welcome back. Now we are at the absolutely pinnacle of the main thing which is very important for this. The session is not a technical session. There are no presentation except the one. But all the respondents are from Joshi family. And as I said in the morning, there are a couple of surprise speakers. So I'm going to call upon them and I would request them to occupy the chair on the dais. And the session chairman is Vice Chancellor Professor A.B. Pandit. I would also request him to come up. So I will take the names, the respondents who are going to speak. And the communication which I will be making in next half an hour will be on a hybrid mode. Some English, some Marathi, so that it becomes very homely. You will appreciate because I am calling the name of the speakers. First one, who is already occupying the seat. Where is Anirudh? Anirudh was here some time back. Please come. Dr. Anirudh Joshi, Junior JBJ. A complete IITian, the great entrepreneur, Atreya Innovations, the name which you must have heard from Prime Minister's Mann Ki Baat, lot of rewards, recognition nationally by the Government of India, as also from the international fraternity. And I would also call upon then Sudhir Panse sir, Professor Panse, who is the Vice President of our Marathi Vidyan Parishad. He would be also representing as a respondent of one area where Professor J.B.Joshi is the president of. So Panse sir, from Sathe College, retired long back. At that time the principal and then also head of the Department of Physics. Then I will call upon Sri Sahasrabuddhe, who is a friend of Professor J.B.J. Is he there, Sahasrabuddhe sir? Maybe outside, I will just check. Then Shyam Asolekar sir. Shyam Asolekar sir. He was to also be a respondent. If he is around, okay. Then sir's elder brother, Moreshwar Kaka Joshi. Kaka, please. So as I said, there is the emotional linkage which is happening to this session. All people who possibly formally would not have said something about, as Professor M.M. Sharma talked about many things and anecdotes, so we will be very eager to understand at a personal level as from the family of Joshis. Then as I said, there are two surprise speakers. And the one is two teachers who taught Professor J.B.Joshi in his native place in Masur. So can I request them to come? Tamankar madam, Sau Pratibha Prabhakar Tamankar, and Jnaneshwar Bhoj, who is 93 years young and he is still there. He is the eldest person, eldest respondent, and you can see he is still walking without stick. So he has come all the way from Masur. मॅडम तुम्हाला आणि सरांना दंडवत. तुम्ही या सर्व गरम परिस्थितीत हवा इतकी विचित्र आहे पण तुम्ही एवढं प्रवास करून आलात. कृपया आपण स्थानापन्न या. So these are the two teachers who taught Professor J.B.J. before M.M. Sharma sir, so at the school time. So they carry a merit by virtues of tutoring in the school days and the age. 93-94 year young Dhaneshwar Bose sir. So I again request whether Shyam Asolekar sir is there around or Mr. Sahasrabuddhe. They also inform us they will be respondent. If they are there, just volunteers can tell me. I will request them to come up. Professor A.B. Pandit, yeah, you haven't seen. So I also request you to come up, or you would like to do the overall things from here. So he will be the chairman for the session. This is the last session. We had session number 1, session number 2, which was purely technical. Session number 3 was also on industry. And I must also keep you posted and welcome Sandra Madam, Vice Chairman of UPL. She is very much here. And thank you, Madam, for coming. I'm sorry, your speech already on your behalf, I read it out to the audience. But if you still want to address in a minute or two, you are please welcome, if it is so. So thank you very much for coming. And now I will request each one of them to talk about in their respective positions or with the relativity index or relationships index, what they feel about. So first I request Anirudh, then Panse sir, नंतर काका, नंतर भोस सर आणि मॅडम, तुम्ही जे तुम्हाला व्यक्त करायचं आहे, सरांबद्दल सांगायचं आहे, आम्हाला हे खूप खूप आवडेल. कारण बाबा नेहमी मुलाबद्दल सांगतच असतात, पण आज मुलांनी बाबांबद्दल सांगायचं आहे. अनिरुद्ध, प्लीज गो अहेड.
Hi everyone, distinguished scientists and JB family. What a memorable day so far. After all technical sessions, I'm here to start with the non-technical one, and it's really non-technical one. So, my wife Meghna, both my daughters Aryavani and myself, we have prepared most of these points. And many of the slides, many of the pointers are from the, granddaughter's point of view. So it's more like Azoba, J.B.Joshi, Azoba, त्या पद्धतीने जास्तीत जास्त मांडायचा प्रयत्न केला आहे. बाबांचा आमच्यावर वेगवेगळ्या पद्धतीने प्रभाव कसा पडलाय, कसा झालाय, म्हणजे माझ्या चाइल्डहुडपासून, मेघना आल्यापासून, मुलं आल्यापासून, त्याचं एक छोटंसं काइंड ऑफ 7-8 स्लाइड्स आम्ही बनवले आहेत. बरेचसे पॉईंट्स त्यातले कवर झालेत, कारण म्हणजे जशी आम्ही घरची फॅमिली आहोत, तुम्ही सगळे बाबांची त्या बाजूची फॅमिली आहात, जिकडे बाबा जास्त वेळ घालवतात, त्यामुळे पॉइंटर्स सगळे सिमिलरच आहेत, सेमच आहेत. पण द वे शर्मा सर ऑल्सो गेव सम ॲनेक्डोट्स, मी थोडं लहानपणीचे मुलींचे काही पॉइंटर्स देणार आहे. ऑफकोर्स टू स्टार्ट विथ टाईम मॅनेजमेंट, आय थिंक आम्ही जेव्हा सगळेजण गप्पा मारत होतो तेव्हा प्रकर्षाने जो पहिला मुद्दा आला तो असा होता की आर्यवाणीचे असं कधी कधी उद्गार असतात की आम्ही खेळतो त्याच्यापेक्षा आबा जास्त काम करतात. सो आय थिंक जास्त पण काम करतात आणि जास्त गोष्टींचे पण काम करतात. मी एकदा गमतीत त्यांना म्हटलं होतो की तुम्ही जसे वेगवेगळे खेळ खेळतात त्यांच्यासाठी हे पण सगळे खेळच आहेत. आणि आय थिंक UDCT, बार्क म्हणूया किंवा वेगवेगळ्या इंडस्ट्रियलिस्ट बरोबरची कन्सल्टन्सी म्हणूया, आता परिषदेचं काम सुरू केलं आहे. प्रत्येक स्टुडंटकडे आणि प्रत्येक फॅमिली मेंबरच्या वेगवेगळ्या समारंभाला सुद्धा ते आवर्जून उपस्थित राहतात. आय थिंक गॉड नोज की त्यांना कुठून हा सगळा वेळ मिळतो, एवढी एनर्जी मिळते. बट ही मेक्स अ पॉईंट की प्रत्येक ठिकाणी ते स्वतःहून आवर्जून उपस्थित असतील आणि पूर्ण वेळ देतात. आय थिंक ही एक गोष्ट शिकण्यासारखी आहे. टाईम मॅनेजमेंट मध्यंतरी मला वाटतं पानसे सरांनीच टाईम मॅनेजमेंटवर पुस्तक त्यांचं जे होतं, तर आमच्या घरी जी पण मंडळी यायची सगळ्यांना ते टाईम मॅनेजमेंटचं पुस्तक आय थिंक ते देत होते. सो आय थिंक वन ऑफ द मोस्ट इम्पॉर्टंट थिंग्स टू लर्न फ्रॉम हिम इज टाईम मॅनेजमेंट. दुसरं खूपच वन्स अ सायंटिस्ट ऑलवेज अ सायंटिस्ट. आम्हाला असं कायम वाटतं की जसं मॅट्रिक्समध्ये झिरोज अँड वन्सच्या स्वरूपात दिसतं, त्यांना ते जग असं प्रॉब्लेम्स ऑपॉर्च्युनिटीज अशा सगळ्या दिसतात. सो त्यामुळे कुठेही गेलं, म्हणजे आपण जंगलात गेलो, कोकणात गेलो, घरी गेलो, बाहेर गेलो, कुठेही गेलं तरी त्यांना त्या अपॉर्च्युनिटीज दिसतात. अँड आय थिंक दॅट इज वन ऑफ द, आणि मला वाटतं नितीन पण म्हणालंच, थिंक बिग, आणि प्रत्येक ठिकाणी मोठ्या सोल्युशनने ते सॉल्व करता येतं. माझं जे आत्ताचं प्रोफेशनल आयुष्य आहे ते सुद्धा अशाच एका ऑपॉर्च्युनिटीमधनं निघालं. ही वॉज नॉट वेल अँड ही टूक आयुर्वेदिक ट्रीटमेंट and he saw that the Vaidyaraj with whom he was working, he did Nadi Pariksha to find out the root cause of his disorder basically. And he thought that there is some fluid dynamics which is happening at the pulse area. And that is how, he asked me to solve it. I did my PhD and now the company is based on that PhD research and so on. So I think that problem statement into opportunity and now to the further journey is what is going on. एका ठिकाणी ॲज अ सायंटिस्ट ते हरले. सो एकदा माझ्या मोठ्या मुलीने आर्याने केक बनवला होता. मला वाटतं एक 5-6 वर्षापूर्वीची ही केस असेल. आणि नुकतीच आईने परमिशन दिलेलं की मायक्रोवेव्हवर काम तू करू शकतेस, म्हणजे त्याच्यावरनं तू केक बनवू शकतेस. आणि तिने ते रेडी मिक्स काहीतरी ते युजून ते वापरून केक बनवला आणि आव्हानकडे घेऊन गेली. आणि तो ऑब्व्हियसली पहिला दुसऱ्यांदाच बनवला असल्यामुळे तो केक थोडासा खराब झाला होता, थोडासा लुसलिशीत झाला होता, त्याचे तुकडे पडत होते. तर आबांकडे गेली आणि म्हणाली की असं असं केक असं असं झालं आहे वगैरे वगैरे. तर आबांनी सुरू केलं की असे पार्टिकल्स, असं पाणी कमी घोटवलं असशील किंवा जे काय असेल ते. सो ही स्टार्टेड एक्सप्लेनिंग ऑल दोज थिंग्स टू हर. आणि ती म्हणाली, बाबा तुम्हाला असं म्हणायचं होतं की ह्याचा तरीही रंग छान आहे आणि चव छान आहे. So explanation was not needed, right? So that is what, so I think एखाद दोन ठिकाणी ते त्या पद्धतीने, पण I think that is what he does. जेव्हा ते ह्या फील्डमध्ये नसतात, when he is not doing chemical engineering, he is doing this. Basically he spends all his time with Arya and Vani, make sure that त्यांच्याबरोबर नाटकं बघतायत, मूवीज बघतायत, खेळतायत and so on. So when in doubt, choose the kids. I think this is what he does, because otherwise he's clear. So it's not clear. He chooses the kids to play. आणि मुली त्यांना वेगवेगळ्या गोष्टी शिकवतात. पत्त्यांमधले नवनवीन गेम्स, नवनवीन इमोशन्स. यू कॅन सी हिअर दॅट, म्हणजे त्यांना बरेच कलर्स कळतात. आय थिंक वॉट ही नोज इज अ लिमिटेड कलर्स. So teaching from lots of colors to games to everything, I think that is what is important. जे कधीही घडलं नसेल, सो ॲब्सोल्युटली, म्हणजे मी कधी बघितलं नव्हतं. सो एकदा गाणी लागली होती आणि ह्या मुली तर नाचतच असतात कंटिन्युअसली. तर एकदा त्यांनी ॲक्च्युली बाबांना उठवलं आणि नाचायला सांगितलं. अँड टू आवर सरप्राईज ही डान्सेस वेल. So upon so that was something specifically, I mean, no need to say, but this specifically slide is from Meghna, that kasha paddhatine, I'm so sorry about this. आय थिंक सगळ्याच स्टुडंट्सनी हा पॉईंट क्लिअर केला आहे, हाऊ ही हॅज चेंज लाईव्स ऑफ सो मेनी पीपल, स्टुडंट्स, अदरवाईज अँड सो ऑन. So not just with the chalk, but the challenges also. I think Nitin explained about dreaming big, going big, and so on. Again, we all talked about patience, purity, perseverance, and so on. म्हणजे मी ह्या सगळ्यावर बोलणार होतो, पण ऑलरेडी खूप बोलून झालं आहे. आज मला ॲक्च्युली वेगळा एक छोटासा पॉईंट सापडला. मी तिकडे थोडासा मागे बसलो होतो. ऑनलाईन आल्यात, सगळ्यांना त्या समजल्यात, करता येतं. त्यामुळे बऱ्याचशा गोष्टी त्यांनी ऑनलाईन सुरू केल्यात आणि आय एम व्हेरी हॅपी दॅट ऑल 4 आर टेकिंग गुड केअर ऑफ हिम. मगाशी एक स्लाईड शो चालू होता, पण तरी हाऊ ही एन्जॉयज फूड, मूवीज, गेम्स अँड सो ऑन. मी एक छोटंसं 5-6 मला वाटतं 10-12 फोटोज ठेवलेत. आय जस्ट रन थ्रू.
शर्मा सरांनी उल्लेख केला तो जो पिरियड होता की ज्या वेळेला ही इन्स्टिट्यूट ही ॲटॉनॉमस झाली आणि मग ती युनिव्हर्सिटी झाली, त्या सगळ्या काळामध्ये ॲडमिनिस्ट्रेटिव्ह ऑफिसर त्या कॉमेंट्समध्ये पेपरचं कौतुक होतं. पण त्यात एक कॉमेंट अशी होती की अशा प्रकारच्या केमिकल रिॲक्टर्समध्ये काय प्रक्रिया घडतात हे समजून घेणं हे फार कठीण काम आहे, हे आम्हाला मान्य आहे. पण तरीसुद्धा त्याचा प्रयत्न देखील करू नये असं तर नाही ना, अशा अर्थाचं वाक्य होतं. जे बी सांगतायत की त्या वाक्याने त्यांना एकदम झटका बसल्यासारखं झालं की प्रयत्न तर करू नये असं नाही ना. म्हणून त्यांनी असं ठरवलं की त्या रिॲक्टरमध्ये काय घडतात प्रक्रिया याचा आपण शोध घ्यायचा. आणि ते सांगतात असं की त्यानंतर जवळजवळ वर्षभर ते त्या विषयाचा विचार करत होते की हे काय घडत असेल, कसं घडत असेल. त्याच्यासाठीचा कुठलाही रेफरन्स, कुठलंही आधीचं केलेलं डिटेल काम असं नव्हतं, कारण केमिकल रिॲक्टर्सचा इतका डिटेल ॲनालिसिस करणारा असं तेव्हा अभ्यास झालेलाच नव्हता. ह्या सबंध वर्षभरामध्ये ते तेवढ्याच गोष्टीचा विचार करत होते. पण त्यांच्यावरती शर्मा सरांना विश्वास एवढा आणि त्यांची स्टुडंटना गाईड करण्याची पद्धत अशी की त्यांना डिस्टर्ब केलं नाही. सापडेल असं वाटलं नव्हतं. बंगलोरला गेले तेव्हा तिथे एक प्रोफेसर या विषयातले दुसरे तज्ज्ञ इंडियातले, पुन्हा नाव आठवत नाही, कुमार नाव असं, हां कुमार, तर ते बंगलोरमध्ये गेले, त्यांना भेटले आणि त्यांच्याशी चर्चा करत होते की असा असा प्रश्न आहे आणि त्या रिॲक्टरमध्ये काय घडतं हे म्हणले मला कळण्यासाठी काय करू. त्याने त्यांना सांगितलं काही संशोधनाचा भाग आहे, त्याच्यामध्ये रिॲक्टर हा त्याचा खरा पाया आहे. हे त्यांचंच म्हणणं आहे. रिॲक्टर हा न्यूक्लिअर रिॲक्टर असेल त्याच्यावरही ते काम करतात, किंवा तो घरामधला कुकर असेल ज्याच्यावरही ते काम करतात, किंवा चुलीमध्ये जळणारं ज्वलनशील जो पदार्थ आहे त्याची एफिशियन्सी वाढवणं असेल, तोही रिॲक्टरचाच एक प्रकार आहे. तेव्हा सगळ्या गोष्टींमध्ये रिॲक्टरचं सायन्स आहे. हे रिॲक्टर सायन्स समजून घेण्याची जी काही पद्धत आहे, त्याच्यामध्ये जे मूलभूत काम केलेलं आहे ते त्यांनी त्यांच्या PhDच्या काळामध्ये केलं. हा एक भाग. आणि दुसरी गोष्ट अशी की एखाद्या प्रश्नाकडे बघताना तिथे काय घडतं हे समजून घेणं, हा जो काही त्यातनं त्यांनी धडा घेतला तो ते प्रत्येक ठिकाणी वापरतात. म्हणजे ते केवळ संशोधनाच्या विषयात नाही, एखाद्या कारखान्यामध्ये आलेलं काही डिफिकल्टी असेल, एखाद्या रिसर्च वर्कमध्ये आलेला प्रॉब्लेम असेल, तर तो प्रॉब्लेम नेमका काय आहे हे समजून घेणं हे तर आवश्यक आहे, ते तर करतातच ते. पण आम्हाला असा अनुभव आहे की मराठी विज्ञान परिषदेसारखी संस्था चालवताना काही ठिकाणी प्रॉब्लेम येतात, काही ठिकाणी प्रश्न समोर उभे राहतात. जेबींचं पहिलं वाक्य काय असतं, तो प्रश्न आधी समजून घेऊया. कुठल्याही गोष्टीचं उत्तर काढताना ते सोल्युशन इंजिनियर यासाठी आहेत की ते सोल्युशनच्या मागे नंतर धावतात, पहिला प्रश्न समजून घेण्याचा प्रयत्न करतात. आणि हा प्रश्न समजून घेण्याचा त्यांचा जो काही स्वभाव आहे, तो स्वभाव त्यांची संशोधन यात्रा सुरू झाल्या काळापासून त्यांनी पुढे कायम ठेवलेला आहे. आणि म्हणून त्यांच्या संशोधनाला इतकं यश आहे आणि त्यांना इतके विविध प्रकारचे त्याच्यामध्ये सन्मान मिळालेले आहेत असं मला वाटतं. त्यांच्या संशोधनाचं आणखीन एक वैशिष्ट्य आहे. आणि ते केवळ संशोधनाचं नाही आहे. माझ्या आधी आत्ता आपण जे बघितलं, जे सगळे शॉर्ट्स बघितले, फोटो बघितले, ते काय, ते इथे जेव्हा त्यांच्याबरोबर मी काम करत होतो आणि ते डायरेक्टर म्हणून काम करत होते, तेव्हा विविध प्रकारचे ॲडमिनिस्ट्रेटिव्ह काम करत असताना प्रश्न येतात. या सगळ्या वेळेला जेबींच्या मनाचा जो प्रसन्नपणा असतो तो कधी ढळला नाही. आणि हे मी म्हणत नाही, हे तेच सांगतात. आम्ही दोघांनी काही कॉलेजेसमध्ये विद्यार्थ्यांना गाईड करण्यासाठी म्हणून त्यांनी वैज्ञानिक संशोधनाकडे येण्यासाठी, इनोव्हेशन करण्यासाठी म्हणून काय करावं याच्याबद्दलची काही लेक्चर्स घेतली. म्हणजे मी गाड्याबरोबर नेण्याची यात्रासारखा होतो. खरं त्यांनीच घेतलं आणि विद्यार्थी त्यांनाच रिस्पॉन्ड करत होते. आणि त्या प्रत्येक वेळेला त्यांनी सांगितलं की तुम्हाला जर संशोधनामध्ये यश मिळवायचं असेल तर मन प्रसन्न ठेवा. मी त्यांना एकदा म्हटलं की तुमचा हा जो संशोधनासंदर्भातला नियम आहे, हा जो विचार आहे, हा फार पूर्वी एका संतांनी इथे म्हणून ठेवला आहे, त्याची मला आठवण येते. तुकारामाचं वाक्य आहे, मन करारे प्रसन्न सर्व सिद्धीचे कारण. काही आयुष्यात मिळवायचं असेल तर मन प्रसन्न हवं. जेबींचं दुसरं वैशिष्ट्य असं आहे, पहिलं वैशिष्ट्य म्हणजे प्रश्न समजून घेतला पाहिजे, दुसरं वैशिष्ट्य म्हणजे मन नेहमी प्रसन्न ठेवलं पाहिजे. आणि अत्यंत कठीण काळात सुद्धा ठेवलेलं मी बघितलेलं आहे. ज्या वेळेला इथे ते डायरेक्टर म्हणून काम करत होते तेव्हा काहीमध्ये एक असा प्रश्न तयार झाला ज्याच्यामुळे खूप कठीण परिस्थिती निर्माण झाली. त्या सगळ्या परिस्थितीला त्यांनी शांतपणे धीराने तोंड दिलंच, पण मन इतकं प्रसन्न होतं त्या सगळ्या काळामध्ये की त्याचं कौतुक वाटावं. त्यांचं टाईम मॅनेजमेंटचा जे सेन्स आहे तोही असा खूपच छान आहे. म्हणजे 10 मिनिटाची वेळ असली तरी त्यांचं सहजपणे वाक्य, 10 मिनटं भरपूर वेळ आहे, आपण हे काम करूया. त्यामुळे 2-5 मिनटं आहेत, 10 मिनटं आहेत, त्याच्यात काय काम होणार असं कधीच ते बघत नाहीत. आणि या पद्धतीने ते काम करत असतात. त्यांच्या बाहेर जाण्यावर आणि एकूण सगळ्या ॲक्टिव्हिटीजवर थोडा कंट्रोल ठेवण्यासाठी आता अथॉरिटी नेमलेली आहे असं कळलं. एक ते आजचे खरे उत्सवमूर्ती आहेत, तरी त्यांच्याबद्दलची एक तक्रार आहे. आणि आपण सगळेच सुहृद आहोत, त्यामुळे ती तक्रार इथे सांगायला हरकत नाही. आणि अथॉरिटीजकडे जाहीरपणे मी त्याच्यासाठी ॲप्लिकेशन देतो आहे. जेबींनी आत्तापर्यंत आयुष्यामध्ये जे काम केलं, मुख्यतः जे संशोधन केलं, त्याच्या संदर्भातलं एक पुस्तक लिहावं अशी कल्पना आहे. मी मगाशी जे सांगितलं की त्यांचं PhDच्या वेळेलाचे अनुभव वगैरे हे ते त्यांच्याबरोबर बसलेल्या चर्चेतनं आलेले आहेत. तेव्हा हे संशोधन यात्रा, त्यांची संशोधन यात्रा, या पुस्तकाचं काम आम्ही सुरू केलं. सुरुवातीला काही काळ, बहुतेक तो काळ हा जेव्हा सगळे आजारी पडून घरात होते, त्या करोनाचा पिरियड होता, त्यामुळे त्यावेळेला त्यांनी वेळ काढला आणि काही आमचे सेशन्स झाले. नंतर थोडीफार सेशन्स झाली, पण पुढे पुढे ते इतके बाकीच्या कामामध्ये गुंग होऊन गेले की ह्या कामासाठी वेळ काढणं कठीण झालं. मला तर काय ते जमेना. मग अपा देशपांडे माझ्या मदतीला आले. अपा देशपांडे अतिशय सॉफ्टली बोलतात, हसतात, त्याच्यावर जाऊ नका, ते भयंकर टास्क मास्टर आहेत. पण अपा देशपांडेंनी प्रयत्न केला. म्हणजे जेबींची चूक नाही, ते इतक्या कामामध्ये इतके बुडलेले आहेत की त्यातनं तो वेळ काढणं त्यांना कठीण होतं आहे. तरी पण असं मला वाटतं हे आपल्या सगळ्यांनी टाळ्या वाजवून त्यांना सपोर्ट द्यावा माझ्या या म्हणण्याला, की या कामासाठी त्यांनी वेळ काढावा. आणि हायर अथॉरिटीकडे अशी विनंती आहे की त्याबद्दल त्यांना सांगावं. म्हणजे खरं आज आयडियल झालं असतं, ते जमलं नाही. 1 वर्षानंतर पुढच्या वर्षी जेव्हा त्यांचा वाढदिवस असेल तेव्हा त्यांच्या संशोधन यात्रेचं पुस्तक आपण पब्लिश करू. त्यासाठी परत सगळे जमू. जेबींना खूप खूप शुभेच्छा. धन्यवाद.
खूपच छान पानसे सर. टाईम मॅनेजमेंट तुम्ही टाईम परफेक्ट घेतलात. सरांची तक्रार श्रेष्ठींपर्यंत पोहोचवलीत. त्यामुळे नक्कीच आपल्याला पुढच्या वर्षी पुस्तक मिळेल. आणि आता मी काकांना विनंती करतो, मोरेश्वर काका, सरांचे सख्खे मोठे भाऊ, हिज एल्डर ब्रदर. सर तुम्ही
सर्वांना नमस्कार करतो. माझे अनुभव असणार ते म्हणजे पहिली गोष्ट म्हणजे सायन्सचे असणार नाहीत, सायन्स अँड टेक्नॉलॉजीमध्ये असणार नाहीत, शास्त्रीय विषयाचंही असणार नाहीत, अगदीच घरगुती कॉमन वगैरे असे असतील. आणि एखादा अनुभव तर असं असेल की त्या संदर्भात माझ्यावरही टीका होणारा असेल. आमच्या बंधुराजांचं लहानपणापासूनचं वैशिष्ट्य काय की ते मित्रांच्यात फार लोकप्रिय होते आणि फक्त अभ्यासाच्या संदर्भात लोकप्रिय होते. त्याला एक छोटीशी पार्श्वभूमी आहे. घर संस्थात्मक होतं, तो आत्ता विषय नाही. पण वडील गावातली एक 25-30 मुलं घेऊन गावातल्या नदीवर जाऊन आंघोळ घालायचे आणि त्यांना मनाचे श्लोक शिकवायचे, दासबोध, ज्ञानेश्वरी वगैरे हे शिकवायचे. आणि त्याचा आमच्यावर सगळ्यांच्यावर परिणाम झाला होता. त्याच्यावर परिणाम तो जास्त झाला होता. परिणाम झाला होता म्हणजे काय, त्याला निरनिराळ्या ठिकाणी सांगितलं की तो ज्ञानेश्वरी म्हणून दाखवायचा, दासबोध म्हणून दाखवायचा, गीता म्हणून दाखवायचा. म्हणजे त्याचं ते पाठ असायचं. आणि ज्ञानेश्वरीचा श्लोक तर त्याच्यासारखा विद्यार्थी कसा आहे हे सगळ्यांना माहिती आहे. तो नुसतं पाठ होत नाही, तो बोलायला लागल्या लागल्या मुरायला लागतो आणि तो मुरायला लागल्यानंतर तो काम करायला लागतो. असंच त्याचं आयुष्य लहानपणापासून आहे. म्हणजे आमचं गाव इथून 200-250 मैलावर किंवा 300 किलोमीटरवर, आता काय सगळे संदर्भ बदललेत, खेड आहे. पण तो मुलांच्यात अतिशय लोकप्रिय फक्त अभ्यासाबाबत. खेळण्याबाबत वगैरे इतकं काही त्याची प्रकृती लहानपणापासून थोडीशी साधी आशक्त म्हणून वगैरे अशी वगैरे. एकदा असा प्रकार झाला की मुंबईवरून आम्ही आमच्या गावी येत होतो आणि त्या काळी त्या कोळशाची इंजिनं असायची. यानं थोडंसं बाहेर बघितलं आणि त्याचा कण डोळ्यात गेला आणि त्यामुळं स्वारी काही दिवस आजारी पडली. काही दिवसांनी तो कण निघाला, पण अशक्तपणा थोडासा त्याचा तो राहिला. त्यामुळं त्याची 2री ती 4थी एकातून दुसऱ्या वर्गात जायचं ह्याच्याऐवजी सगळ्या शाळेनं हे केलं की हे परीक्षा न घेता 2रीतून 3रीत कशाला, 2रीतून 4थीत बसवूया ना. आश्चर्य वाटेल त्या छोट्याशा गोष्टीचा परिणाम वास्तविक परीक्षा न घेता 3रीत बसवणं हाच मोठा काय प्रमोशन अमुक तमुक काय म्हणायचं ते होतं. आता त्याचे शिक्षक आहेत त्यामुळे त्याला ते सगळ्या गोष्टी सगळ्या त्यांनाही माहिती आहेत. पण त्याचा असा उपयोग झाला. ह्याचा सारांश असा आहे की त्याच्या पुढं असलेल्या, आता सायन्स अँड टेक्नॉलॉजीमधलं मला माहिती नाही काही, पण प्रत्येक गोष्टीची समस्या ही आव्हान म्हणून स्वीकारण्याची त्याची लहानपणापासून सवय आहे. 7वीच्या वेळेला परत काय आजारीपणं होतात, खेडेगावात असतं, काही सोयी नसतात. त्याच्या वेळेला परत झाला तर त्यावेळेला त्या हायस्कूलचे टीचर आले आणि त्या म्हणले पुढच्या वर्गातल्या प्रवेशाचं सर्टिफिकेट मी तुला देतो. असं म्हणजे त्याच्यासाठी ती स्पेशल केस केली नाही. त्यांनी सांगितलं अरे ती परीक्षा ही तू उत्तीर्ण आहेस, अशा गोष्टी ह्या किती त्या काळात व्हाव्या. घरात कायम 30-40 मुलांचा मुक्काम असे. घर मोठं, आता खेडेगावातली घर आमचं कसं होतं तुमचं हा संदर्भ नाही. आणि तो सांगेल त्या पद्धतीने एक एक शब्द त्याचा ऐकून घेण्यासाठी मुलं आसुसलेली असायची. त्याचा एक शब्द कानावर पडला, कदाचित ह्या गोष्टींचं आमच्या ताम्हनकर बाईंना माहिती असेल, खिरे आमच्या भोज सरांनाही माहिती असेल. मुद्दा असा की तो म्हणजे तो घोळकाच असायचा आणि सगळ्या मुलांना त्याच्याकडून काहीतरी ऐकून घ्यायचं असायचं. 2रीतून तो जो 4थीत गेला त्यावेळेला सगळ्या मुलांनी त्याचा 2रीतून जाताना त्या काय खेड्यातली शाळा काय 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 निरोप दिला, समारंभपूर्वक निरोप दिला. तर ते समारंभपूर्वक म्हणून मसूर काय, ते फुलं काय 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 काय. मुद्दा असा की तेव्हापासून त्या गोष्टीला अर्थ होता आणि त्याचा अर्थ तो जसा जसा पुढं जाईल, म्हणजे बहुधा महत्त्वाच्या प्रत्येक परीक्षेला त्याला अडचण आली होती.
इथं तो UD-CTला आला आणि UD-CTला आल्यानंतर पहिलं वर्ष संपता परत काहीतरी तापाचा झाला प्रकार. तर काय असा का झाला आणि तसा काय झाला असं काही नाही, अशक्त स्वभाव होता. तर वाचता येत नव्हतं. मग आमची दुसरी एक पुतणी होती, ती आपल्या मेडिकलला होती, तिनं वाचलं आणि ह्याला मात्र चांगले मार्क्स मिळाले. त्या सगळ्या ह्याच्यात ह्याला चांगले मार्क्स मिळाले. फर्स्ट टू सेकंड इन UD-CT. नेमकी परीक्षा वगैरे मी सांगितली तरी ती चुकीची असेल म्हणून मी त्याचा काही उल्लेख करत नाही. एक गोष्ट मात्र एक सांगता येण्यासारखी आहे. तो पुण्याला आल्यानंतर तेव्हा इथे एक पिंगे क्लासेस होते, ते माहिती आहेत. प्रचंड मोठे क्लासेस होते, पण त्यांच्या मुलीला शिकवण्यासाठी त्यांनी ह्याला घेऊन गेले. काही त्याचं त्यांनी दिलंही नाही, घेतलंही नाही. ते म्हणले, अरे तू घरात येणं हे आमच्या अभिमानाचं आहे. म्हणजे तो काय शिकवत होता हे कळण्या इतकं काही मला माहिती नव्हतं. माझी क्षेत्र निराळं, मी बुद्धिमान होतो का वगैरे वगैरे हे अजून वादाचे मुद्दे. पण ते त्यांनी त्याला घरी नेलं आणि ते शिकवलं. तो शिकवत असे. कराडला असताना म्हणजे तेव्हा 11वी असायची. 11वी झाल्यानंतर FY, PD, FY वगैरे असे काहीतरी ते मुद्दे असायचे. तेव्हा तिथल्या प्रत्येक चांगल्या क्लासेसवाल्याने सांगितलं की तुझ्याकडून आम्ही काही घेत नाही, पण तू आमच्या क्लासला ये. हा काही गेला नाही, पण ते शिक्षक मात्र ह्याला विचारायचे. तो काय मुद्दा असेल तो मला कळायचा नाही, मला अजिबात कळायचा नाही, पण ते व्हायचं आहे. अजून एक आमचा मात्र तो थोडा भावनिक मुद्दा आहे, बंधुराजांच्या बाबत नाही आहे. तो अशक्त असायचा. पहिल्या वर्षी MM सरांनी त्यांना बोलवून घेतलं. आय डू नॉट नो वेदर ही रिमाइंड्स इट टुडे ऑर नॉट. आणि त्यांनी त्यांना विचारलं की अरे तू अशक्त काय आहेस? तो म्हटलं माझी भूकच कमी आहे वगैरे. तर वास्तविक तुम्हा एक सायन्स टीचर दुसऱ्या सायन्स टीचरशी किती आदराने बोलतो हे मी पाहिलेलं आहे. ते त्याला म्हणले त्यातलं काही नाही, मी तुला सांगीन ते तू रोज ॲडिशनल खायचंस. आता तो म्हणाला मी खात जाईन. नाही म्हणले, हे मी सुचवलेलं आहे ना, तर त्याचा खर्च मी करणार. आता त्या काळी सगळ्यांच्याच परिस्थित्या जशा असायच्या तशा असायच्या. पण तेव्हापासून पहिल्या वर्षापासून शिक्षक विद्यार्थी म्हणून काय नातं असेल माहिती नाही, पण भावनिक आहे. वडील आणि मुलगा म्हणून नातं MM शर्माने आमचे बंधू आजपर्यंतही तसंच. नंतर असं झालं की साधारणतः 2000च्या आसपास त्याला अजून काहीतरी त्रास झाला, प्रकृतीचे त्रास. अहो इतके संशोधनाच्या बाजू तुम्ही समजून घ्यायच्या, आम्हाला फक्त एक माहिती आहे की तो आजारी असायचा केव्हा तरी, आणि 50-60 वर्षात 4-5 वेळा असणं साहजिकच असतं. त्यावेळेला तो म्हणाला की तू कोणाकडेही जाऊ नकोस, तो पुण्यात एक वैद्य म्हणून भट म्हणून एक वैद्य आहे, तू त्यांच्याकडं जा. वास्तविक ते भट वैद्य आमच्याकडं अनेक वेळा येऊन गेलेले. मी त्याला सांगितलं होतं, पण मुंबईवरून पुण्याला येई वगैरे इतका काही मी त्याला सल्ला दिला नव्हता. ते तिथं गेले, पहिल्या लहानपणापासून येणारे. आणि पुढची जी काही मी 5-6 वाक्य सांगतोय ती तुम्हाला खरी न वाटणारी आहेत. तिथं गेल्यानंतर त्यांची पद्धत होती की 10-12 मेडिकलच्या किंवा आयुर्वेदाच्या मुलांना उभं करायचं आणि प्रत्येकाला नाडीमधले बारकावे शिकवायचे, त्यांच्याकडनं विचारून घ्यायचं. बंधुराज आणि आम्ही 2 जण गेलो. तर ते वैद्य म्हणाले, आता आमच्यापेक्षा वयाने ते मोठे होते, ते म्हटले की ज्येष्ठराज तू फार उशीर केलास रे. तर आता फार उशीर केलाचा आम्ही काय अर्थ काढायचा की तुला जे आजारीपण आहे त्यासाठी तू फार उशीर केलास आणि आता मी दुरुस्त करतो वगैरे हा अर्थ. ते म्हणले जेव्हा मी मसूरला तुमच्याकडे येत होतो तेव्हाच मी निश्चित केलं होतं की माझं सगळं नाडीचं जे तत्त्वज्ञान आहे, तंत्रज्ञान आहे, त्यांनी उभं केलेलं आहे. ते डिस्टंट नाडी म्हणजे दूत नाडी, एखाद्या माणसाचं नाव सांगितलं की त्याचे सगळे रोग सांगत, त्याच्या घराण्याचे रोग सांगत. ते म्हणले माझं सगळं हे ज्ञान हे तूच एकटा पुढं नेणार आहेस, हे तू जेव्हा तिसरीत होतास, आय डू नॉट नो स्टँडर्ड 3 काय मुलं समजावून घेतात, तिसरीत होतात, तेव्हाच मी निश्चित केलं होतं की माझं सगळं नाडीचं तत्त्वज्ञान हे तुला द्यायचं. तर तो म्हणाला तर रिॲक्ट व्हायचं या बंधुराजाने चट्ट दिशी कळेना. आम्ही अशाच इम्प्रेशनमध्ये होतो की आजारी म्हणून तो उशीर वगैरे झाला असेल वगैरे वगैरे. आणि त्या दिवशी त्यांनी सांगितलं की माझ्या मुलाला मी सांगतो. आणि त्याने मुलाला सांगितलं. आता सर्वसाधारणपणे PhDला जेवढा वेळ लागला तेवढ्या ह्याला ते सगळा विषय नवीन असल्यामुळं वेळ जास्त लागला. वास्तविक PhD गाईडचा मुलगा म्हणून लवकर व्हायला पाहिजे होतं, पण ते तसं झालं नाही. ह्याचं कारण ऑफबीट विषय होता. आज त्याचं जे आहे की फक्त हे लावलं की त्याच्या आयुष्याचा सगळा बायोडाटा आणि त्याचा काय डायग्राम असेल आयुष्याचा प्रकृतीच्या दृष्टीनं तो उभा राहतो. मसूरला एका प्रदर्शनामध्ये प्रचंड मोठं प्रदर्शन होतं आणि आमचे मुख्यमंत्री मी त्यावेळेचे मुख्यमंत्री देवेंद्र फडणवीस ते म्हटले मी फक्त अनिरुद्धचा स्टॉल बघायला आलेलो आहे. तर त्यांनी तेवढा स्टॉल बघितला आणि गेले. तो स्टॉल म्हणजे त्यानं केलेलं काम आता त्यानं सांगितलं. आणि त्याच्याही पेक्षा महत्त्वाची गोष्ट म्हणजे त्या कामाला उशीर लागला, कारण ते काम चट्टदिशी ॲकॅडमिक लेवलवर विद्यापीठ लेवलवर कसं कोण ॲक्सेप्ट करणार की असं केल्यानंतर सगळं कळतं, असं केल्यानंतर कळतं असं आयुर्वेदातले लोक मान्य करत नाहीत. ते ह्यानं केलं आणि करून दाखवलं. आज ह्याचं काम जागतिक पातळीवर आहे. ही फार मोठी गोष्ट आहे. मला सांगा एखाद्या दुसऱ्या मुलाला सांगितलं असतं की तू ते कर तर त्यानं काय विचार केला असता, ह्यात वर्ष मी देणार किती आणि ॲकॅडमिकली मला फायदा काय. हा मी म्हणजे सर्वसाधारण प्रश्न आहे, पण आमच्या अनिरुद्धनं इतकं काम केलं. आणि त्यातले डॉक्टर सांगतात की तुमचे बंधुराज किती मोठे आहेत आम्हाला माहिती नाही, पण ह्यानं केलेलं काम हे युगाला टिकणार आहे. ह्यानं काम केलंय म्हणजे काय केलंय हो, ह्यानं काम केलंय म्हणजे भारतीय शास्त्र आहे त्याचं फक्त ग्रामर कॉम्प्युटरवर बसवलं आहे. वातपित्त कफ, सप्तधातू, त्रिदोष, पंचमहाभूत हे शब्द सगळे नवीन असतील, पण ह्याच 3 गोष्टीवर म्हणजे हाताच्या ह्या गोष्टीवर सगळी भारतीय शास्त्र बसणार. ह्याच्याही पुढे जाऊन सांगतो, अजून त्याला ते मान्य नाही आहे. येणारं जे शास्त्र आहे आर्टिफिशियल इंटेलिजन्स त्याचं भारतीय स्वरूप चा पाया ह्याचा तयार आहे हो, ह्याचा तयार आहे. हे तुम्हा मंडळींनाच कळू शकेल, तुम्हा मंडळींनाच कळू शकेल. कुठल्याही भारतीय शास्त्राचा पाया हा त्रिदोष, पंचमहाभूत आणि सप्तधातू ह्याच्यावर शिवाय प्रचंड लागतं. ह्या 3 गोष्टीवर काही होत नाही, पण ह्यानं ते बसवल्यामुळं हा मिरॅकल आहे. आणि ही गोष्ट फक्त आमचे बंधुराज ज्येष्ठराजच करणार आहे असं त्या वैद्यांनी हा तिसरीत असताना, आता तिसरीत असताना मुलगा काय करणार तेव्हा त्यांनी निश्चित केलं होतं. आणि तो जेव्हा आला तेव्हा ह्याला दोष दिला, अरे किती उशीर हा म्हणजे जस्ट ट्राय टू अंडरस्टँड. म्हणजे इतक्या गोष्टी ह्या माझ्याही समजण्याच्या पलीकडच्या आहेत. शाळेतली गोष्ट एकच त्याची मला माहिती आहे की प्रत्येकाने वर्ष संपताना प्रत्येक शिक्षकानं ह्याची एक वही घरी घेऊन गेले होते, आमच्या लक्षात असू दे म्हणून. हे सगळ्यांचं होतं. आता अजून एक प्रसंग आहे, तो खरं माझ्या बदनामीचा आहे, पण मी तो सांगणार आहे. आणि तो आहे सर माशेलकरांच्या बाबतचा. माझा मुलगा त्यांच्या हाताखाली त्यांनी PhD केली, बंधुराजांच्या संदर्भातलं. पण थोडी त्यानं एकदा मला सांगितलं की बाबा मला आज बरं नाही आहे, माझे हे कागद तुम्ही ऑफिसमध्ये पोचते करा. म्हणून मी माशेलकरांच्या ऑफिसमध्ये गेलो. त्यांचा माझा परिचय, मी पत्रकार व्यवसायानं. पत्रकाराबाबत तुम्हालाही सगळ्यांना सांगून ठेवतो, कधीही जवळ घ्यायचं नसतं, अंतर ठेवायचं असतं. कधीही जवळ घ्यायचं नसतं. अंतर ठेवायचं. राजकीय लोक असेल, शास्त्रज्ञ असू देत, अमुक तमुक. आता त्याला मी कागद दिल्यानंतर ह्यांच्या PA-कडे दिले मी ते, तर तो PS सरांच्यावर ह्याच्यावर रागवला. म्हणला, अरे पत्रकारांच्याकडे तू हे कागद दिलेस, तुला माहिती आहे का ते कागद असे बघतात आणि त्याच्यावर बातमी करतात आणि तुझं सगळं वाया जाईल रे, तुझं वाया जाईल. आणि ही काय पद्धत झाली का? पुरेसं बदनामीकारक आहे ना. पण सरांच्याही दुसऱ्या तिसऱ्या दिवशी लक्षात आलं, अरे तू JBचा पुतण्या काय माझा तो भाऊ माहिती होतं, हा माझा मुलगा हे माहिती होतं, पण असं काही एकत्र झालं नव्हतं. मुद्दा असा आहे की ऑफबीट मुद्दे आहेत, पण त्यावेळेला अजूनही मसूर भागामध्ये इतक्या शाळा त्याच्या मागं लागल्या आहेत की आपल्या कॉलेजला तुझं नाव देऊया, अमुक करूया, तमुक करूया, काय असेल ते वगैरे वगैरे. पण त्यावेळेला सुरू झालेला तो रथ किंवा रथाची येजा पद्मभूषण झाल्यानंतर आमच्या गावातल्या लोकांनी काय हत्तीवरून मिरवणूक काढली होती. आता खेडेगावात हत्तीवरून मिरवणूक हे कसं समजावून घ्यायचं ते मी आपल्यावर सोडतो. मुद्दा असा, अजूनही त्याची प्रगती सुरू आहे. आमच्या घराण्यामध्ये प्रत्येक पिढ्यामध्ये एक 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 माणूस असा होतोय. त्या सगळ्यांचा मुहूर्तमणी ठरावा असे आमचे बंधुराज आहेत. एवढंच व्यक्त करतो आणि थांबतो.
काका, खूप ऐकत राहावं असंच वाटत होतं आम्हाला, कारण 70च्या कार्यक्रमाला तुम्ही येऊ नव्हतं शकलात प्रकृती अस्वस्थामुळे, पण आज ती सर्व भरपाई तुम्ही केलीत. आणि माझं भाग्य की मी तुमच्या बाबांना, काकांना पाहिलेलं आहे, त्यामुळे मसूर आश्रम आणि त्यांनी पण अनिरुद्धच्या मुंजीत मला आठवतं एक वाक्य सरांबद्दल केलं होतं की हे एक वेगळंच दैवी काम आहे. हे शब्द मला आता तुमचं भाषण ऐकताना, मनोविचार ऐकताना आठवले. आणि जशी राणी माशीभोवती मधमाशाची पोळी असतात तसंच थोडं जाणवलं त्या सरांच्या भोवती सर्व ती मुलं मित्र जमायचे. तर ती तेव्हापासूनचीच एक एनर्जी आणि ऊर्जा आहे. खूप छान वाटलं. आता मी आपल्या या अख्ख्या हॉलमध्ये सगळ्यात मानानी आणि वयानी वयस्क ज्यांनी सरांना शाळेमध्ये शिकवलं, प्राध्यापक ज्ञानेश्वर भोज, 93 इयर यंग, त्यांना मी बोलवतो आहे. आणि सर तुम्ही तिथेच बसा, कॉर्डलेस माईक देतो आहे तुम्हाला, तिकडनं आपल्याला बोलायचं आहे. संदीप, हां चालेल. अच्छा, ती फक्त पायरी आहे.
नमस्कार. माझा परिचय सांगतो. मी ज्ञानेश्वर आत्माराम भोज, राहणार मसूर, तालुका कराड, जिल्हा सातारा. शिक्षकी पेशा. मी मूळचा वाईचा. ...1960 साली शिक्षक म्हणून मसूरला आलो आणि त्यावेळेस मला संस्थेने श्री शिवाजी विद्यालय मसूर इथं शिक्षक आणि बोर्डिंगचं काम दिलं. आणि त्या मसूरच्या भागामध्ये वेगवेगळ्या विषयामध्ये संगीत, ज्योतिषकला याच्यामुळं माझा परिचय जास्त वाढत गेला. तसं मसूर हे 7-8 हजार लोकवस्तीचं गाव, छोटंसं गाव. आणि 1960 साली ते खूपच उजाडास होत. नंतर वाढत 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 चांगलं झालं. मसूरला स्वातंत्र्य लढ्यात योगदान देणारे लोक, आध्यात्मिक बैठकीचे लोक
चांगले आहेत. संत रामदास स्वामीसुद्धा तिथं भिक्षेला येत असे आणि मारुतीची स्थापना सुद्धा मसूरला त्यांनी केली आणि 11 मारुतीपैकी एक मारुती मसूरला आहे. तिथं 4-5 चाफळ म्हणा, शहापूर म्हणून एक आहे तिथं शेजारी गाव, असे 2-4 मसूरलाच आणि त्या विभागात मारुतीची स्थापना केली. आणि आज सुद्धा एक मारुती महारुद्र मारुती मसूरमध्ये सज्जनगडाची नातं सांगणारा आहे. समर्थांनी स्थापन केलेला मठ अजूनही मसूरमध्ये त्याचा ठेवा आहे. हिंदू धर्म रक्षणासाठी विनायक महाराज मसूरकर यांनी मसूराश्रम ही संस्था स्थापन केली. खूप लोकांना हिंदू धर्माची दीक्षा दिली, भारतभर प्रसार केला. ज्येष्ठराजच्या बालपणीच्या काळात मसूरमध्ये वीज वगैरे काही नसे. कोयना धरण झाल्यानंतर 62-64च्या दरम्यान लाईट आली. पाण्यासाठी मग आड, विहीर, ओढा अशाशी संबंधित तिथं पाणी आणावं लागायचं. ज्येष्ठराजचं 1ली ते 7वी इयत्तेपर्यंत मराठी शाळा, लोकल बोर्ड, जीवन शिक्षण मंदिर इथं पूर्ण केलं 7वीपर्यंत आणि 8वी नंतर हायस्कूलला आला आणि श्री शिवाजी विद्यालय मसूर इथं त्यानं 11वीपर्यंत शिक्षण पूर्ण केलं. 8वीमध्ये असताना माझ्याकडे त्याचा गणित सायन्स विषय असायचा. तो गणित वगैरे इतकं भूमितीचं प्रमेयचं पाठ करून एकदम शिकवल्यानंतर पाठ म्हणून दाखवायचा. ती बुद्धिमत्ता चांगली आहे. मॅट्रिक झाल्यानंतर महाविद्यालयीन शिक्षणासाठी सायन्स कॉलेज कराड इथं कॉलेज पूर्ण केलं. विद्यार्थी म्हणून तो आदर्श होता. तल्लख बुद्धिमत्तेचा, एकपाठी उत्तम स्मरणशक्ती असणारा, भूमीचे प्रमेय शिकवल्यावरचे प्रमेय जसेच्या तसे पुन्हा सांगणारा, शांतपणा आपल्या तत्वाला आढळ असायचा. त्यासाठी जरूर तर विरोधही करायचा. कणखरपणा त्याच्या मृदू स्वभावात आहे. असा हा ज्येष्ठराज आणि मसूरकर जोशी परिवार आमच्या मसूरचे भूषण आहे. आता माझी 90वी चालू आहे. गेल्याच महिन्यात माझं हृदयाचं ऑपरेशन झालं. ज्येष्ठराजने तिथं 75 गाठली आणि त्या 75च्या सोहळ्याला तो पाहायला मला मिळावं हे माझं मी भाग्य समजतो. मनातले बोलण्याची संधी मला या संयोजकांनी दिली, याबद्दल मी त्यांचे आभार मानतो. ज्येष्ठराजने भावी काळात आत्तासुद्धा काही त्यानं पहाटे उठून व्यायाम केला पाहिजे. मी सुद्धा रोज व्यायाम करतो. माझी बोटं अशी थरथर थरथर कापायची. म्हणजे हे काय झालं, हे आपल्याला काय झालं. आणि गेल्या महिन्यात माझं ऑपरेशन झाल्यानंतर माझ्या कानात आवाजच यायला बंद झाला. हृदयाचं ऑपरेशन केलं आणि कानानं ऐकायलाच कमी यायला लागलं. आता त्याला काही इलाज नाही, 90 झाली त्यामुळं ते होणार, आपण ते धरून चालायचं. पण बाकीचं आहे ते सांभाळलं पाहिजे. तर याच्यासाठी मी रोज पहाटे व्यायाम करायचो. मला वागतासुद्धा येत नव्हतं, आता मी उड्या मारू शकतो का, तर रोज मी पहाटे व्यायाम करतो. हे असे हाताचे असे रोज करतो, पहाटे तासभर व्यायाम करतो. त्यामुळे ह्या वयात सुद्धा मला चांगलं पळता चालता येतं. फक्त रोज नियमानं व्यायाम केला पाहिजे, नाहीतर ते खरं नाही. सर्वांग सुंदर व्यायाम करायचा, एका खोलीत आपलं करत बसायचं. हे हाताचे मनगटं, हे व्यायाम, हे बोटं, लिहिता वगैरे आता मला मी चांगला आहे, चित्र वगैरे काढतो. हे कशा करता, तर आपल्याला माणसाला म्हणजे प्रत्येक व्यक्तीला सुखाचं मरण आणि मरणाचं सुख पाहिजे. ते ह्याच्यासाठी व्यायाम हा केला पाहिजे. ज्येष्ठराजनं 100 वर्ष पूर्ण करावीत ही माझी इच्छा आहे. एवढं बोलून
सर, आत्तापर्यंतच्या सगळ्या पेपर्सला लाजवेल असं तुमचं भाषण होतं. खरंच सांगतो सगळ्यांना पटेल. आणि तुम्ही बहुतेक शाळेतलं प्रगती पुस्तक वाचल्यासारखं पण आम्हाला वाटलं. त्यात तो अहवाल असायचा, टिपणं असायची. तुम्ही त्या ब्लॅक अँड व्हाईट काळात आम्हाला घेऊन गेलात. आणि खरंच असे शिक्षक आणि असे त्यामुळे विद्यार्थी घडले. आणि आम्हाला आमचं भाग्य की असे सर्व मान्यवर आम्हाला बघायला मिळत आहेत. आज या हॉलमध्ये 5 पद्म अवॉर्डीज आहेत. आणि तुमच्या नावातच नावच ज्ञानेश्वर आहे, माऊली आहात. त्यामुळे असे शिक्षक आम्हाला मिळणं आणि आम्हाला तुमचं ऐकायला मिळणं हे आमचं भाग्य आहे. सरांसाठी एक जोरात टाळ्या झाल्या पाहिजेत. मी आता तामणकर मॅडमना विनंती करतो त्यांनी यावं. एक सर झालेत, आता बाई पण येत आहेत.
आजचा अतिशय अगदी अलभ्य लाभ आमच्या दृष्टीनं असा हा सोहळा, एवढे सगळे शास्त्रज्ञ समोर जमलेत, आमच्या विद्यार्थ्याचं एवढं मोठं कौतुक होतंय, हे सगळं बघायला मिळणं हे सुद्धा खूप मोठं भाग्याचं आहे. आणि हे भाग्य आम्हाला का मिळालं, तर आज ज्येष्ठराजने आठवण ठेवून आम्हाला बोलावलं म्हणून. त्यामुळं पहिल्यांदाच तुमची आम्ही प्रथमच आभार मानते. आणि नंतर मी शाळेतलं तुम्हाला ज्येष्ठराज आणि आम्हाला त्याच्या संबंधीचे आलेले अनुभव हे सांगते. 1961 सालचा जून महिना होता. नोकरीचा माझा पहिला दिवस. 8वीचा वर्ग होता. एक चुणचुणीत हुशार विद्यार्थी प्रत्येक प्रश्नाच्या उत्तराला हात वर करत होता. याच विद्यार्थ्याचं नाव ज्येष्ठराज जोशी. मसूर गाव, आता सरांनी सांगितलं त्याप्रमाणे 6-7 हजार लोकवस्तीचं. गावाच्या सीमेवर ओढा आणि ओढ्याला लागून आमची शाळा. शाळा म्हणजे एक वाडा जुना. आणि या जुन्या वाड्यात विद्यार्थी मात्र उत्साही, शाळेतील वातावरण मात्र प्रसन्न. त्यामुळे शाळेची इमारत जरी कशीही असली तरी शाळा ही अत्यंत आनंद देणारीच होती. संध्याकाळी घरी आल्यावर असं लक्षात आलं की ज्येष्ठराज जोशी यांचं घर म्हणजे मसूराश्रम. आणि मसूराश्रम आणि आम्ही राहत असलेलं म्हणजे आम्ही भाड्याने जे घर घेतलं होतं ते लिमयांचं घर, या 2 घरात फक्त एक भिंत होती. आणि काही काळानंतर ती भिंतसुद्धा नाहीशी झाली आणि आम्ही दोन्ही कुटुंब अगदी एकत्र झालो. मसुराश्रमातील काका काकू म्हणजे ज्येष्ठाचे आईवडील. त्यांचं आणि आमचं नातं अतिशय जवळचं. रोज आमच्या गप्पा व्हायच्या आणि त्यांचा आम्हाला खूप मोठा आधार असायचा. म्हणजे सांगायला खूप आहे, पण आपण थोडक्या वेळामध्ये या सगळ्या गोष्टी जाणून घ्यायच्या आहेत. त्यामुळं ज्येष्ठाचे काका काकू, इव्हन आमचे आईवडीलसुद्धा तिथेच असायचे. कारण माझी नोकरी असल्यामुळे माझी आई तिथे यायची, माझे वडील यायचे आणि आम्ही सगळे एकत्रच असायचो. दुसरी गोष्ट म्हणजे ज्येष्ठाची मोठी बहीण जी सौदामिनी, ती माझी खास मैत्रीण झाली. रोज तिच्या आणि माझ्या खूप गप्पा चालायच्या. ज्येष्ठाच्या घरी सुसंस्कृत वातावरण होतं. काका काकू दासबोधाचा त्यांचा खूप अभ्यास होता. गावातल्या लोकांना दासबोध शिकवायचा. दासबोध जे शिकायचे, अभ्यास करायचे, त्यांना काही बक्षिसं द्यायची. मुलांना नमस्कार घालायला लावायचे आणि नमस्कार घातलेल्या मुलांना खाऊ द्यायचा. अशा प्रकारचं त्यांच्या घरातलं वातावरण हे अतिशय चांगलं होतं. आता विशेष गंमत वाटायची मला म्हणजे ज्येष्ठाच्या घराची बाहेरची जी खोली होती, असा सोपा टाईप मोठी खोली होती आणि तिथे आम्ही सगळे गप्पा मारत बसायचो. यावेळेला विद्यार्थ्यांना अभ्यासासाठी स्वतंत्र खोली नव्हती. स्पेशल कपाट, स्पेशल टेबल, स्पेशल खुर्च्या काही नव्हतं. मला विशेष गंमत वाटायची, त्याच बाहेरच्या खोलीत ज्येष्ठराज तन्मयतेनं अभ्यास करत असायचा. कसं त्याचं लक्ष लागतं आणि इतक्या तन्मयतेनं तो अभ्यास करतो की वर्गामध्ये कधीही पहिला नंबर त्यांनी सोडला नाही. हीच गोष्ट सातत्यानं टिकली. SSC झाल्यानंतर तो कराडला सायन्स कॉलेजमध्ये आला. सगळीकडे त्याने आपलं यश हे असंच मोठ्या प्रमाणात मिळवलं. पुढे PhD झाला, प्राध्यापक झाला, संशोधक झाला. परदेशात कीर्ती मिळवली. आपल्या देशात संशोधनाच्या माध्यमातून देशसेवा केली आणि पद्मभूषण या पदवीने तो पुरस्कृत झाला. राष्ट्रपतींच्या हस्ते त्याचा पुरस्कार झाला. या सगळ्या गोष्टींचा आम्हाला होणारा आनंद हा फार मोठा होता. आणि नुसता आम्हालाच झाला असं नाही, तर मगाशी सांगितलं तसं ते जे छोटं गाव आहे, त्या गावाला, मसूर गावाला खूप आनंद झाला. त्यावेळेला काय केलं गेलं, मसूर गावामध्ये ज्येष्ठाचा मोठा सत्कार, तिथे ग्रामपंचायत आहे, मंडई भरते तीच हे आहे जागा, आणि त्याच जागी ज्येष्ठाचा मोठा सत्कार गावामध्ये घेतला गेला. गावामधल्या लोकांनी गुढ्या उभारल्या, गुढ्या तोरणं उभारली, प्रत्येकाच्या दारात रांगोळ्या घातल्या. पाहण्यासारखा सोहळा होता तो. आणि या पुरस्काराच्या वेळेला मोरेश्वरचा वाटा खूप मोठा होता, कारण तोच आमच्या घरी आला होता आणि त्याने आम्हाला या कार्यक्रमासाठी निमंत्रित केलं. आणि त्यावेळी ज्येष्ठराजची हत्तीवरून मिरवणूक काढली आणि ती बघायला आम्हाला खूप खूप, असं काय शक्य आहे का सांगा की. म्हणजे शिक्षकाच्या आयुष्यात हा केवढा मोठा भाग्याचा क्षण आहे की विद्यार्थी हा पद्मभूषण व्हावा आणि त्याचा एवढा सत्कार व्हावा. हे किती लहान गाव आहे ते, हे बघितलं म्हणजे तुमच्या लक्षात येईल की तिथल्या भोळी लोक आहेत, माणसं आहेत, त्यांना काय कळत नाही जास्त. पण हा मोठा आनंदाचा क्षण होता आणि त्यावेळेला सगळ्या गावाला अतिशय आनंद झाला. त्यावेळेला विशेष सांगायची गोष्ट म्हणजे ज्येष्ठराज किंवा ही मंडळी गावातल्या शाळेतल्या शिक्षकांना विसरली नाही. कुणाच्या हस्ते पुरस्कार झाला ते विशेष कौतुक वाटलं मला की त्यावेळेला आमच्या शाळेतले मुख्याध्यापक होते गजाभाऊ साळुंखे. ज्येष्ठाचा त्यावेळेचा पुरस्कार गजाभाऊ साळुंख्यांच्या हस्ते झाला आणि तेव्हा आम्हाला सगळ्यांना तिथं बोलावलं होतं स्टेजवर आणि त्यांनी आम्हाला नारळ आणि काहीतरी फूल दिलं. त्याचा आम्हाला एवढा अभिमान वाटला की तो क्षण आयुष्यामध्ये कधीही विसरता येणार नाही असा आम्ही जपून ठेवला होता. आता त्यावेळेला जे सत्काराचं भाषण झालं ज्येष्ठाचं, सगळ्या गोष्टी अगदी जपण्यासारख्या होत्या. ते भाषण खूप मोठं झालं, खूप छान झालं. पण त्या भाषणात त्यांनी एक गोष्ट सांगितली होती की हा पुरस्कार माहेरचा पुरस्कार आहे. माझे बाहेर खूप पुरस्कार झाले, पण आईने मुलाला वरण भात जेवायला घालावा तसा हा पुरस्कार आहे, इतकं या पुरस्काराचं महत्त्व आहे. आणि आणखी एक गोष्ट महत्त्वाची सांगितली की संशोधनाचा हेतू केवळ पैसे मिळवणे हा नव्हे, तर देशातील गरीब जनतेची सेवा करणे हा आहे. मला अंगावर शहारे आले की सर्वच करतात, मंडळी शिकलेली मंडळी असतात ती करतात, पण एवढी जाणीव ज्या विद्यार्थ्यामध्ये आहे असा विद्यार्थी या शाळेचा असावा याचं मला खूप खूप कौतुक वाटलं. यानंतर आम्ही त्याला आमचं तिथून जवळ एक 9-10 मैलावर कराड गाव आहे. आमचं तिथं घर आहे आता, कारण मी लग्न झाल्यामुळे तिकडं त्याच संस्थेत पण इकडं आले. तर कराडला आम्ही त्यांना बोलावलं, तर आले दोघं सहकुटुंब आले, मोरेश्वर पण आला. खूप आनंद झाला आम्हाला घरीसुद्धा. मग आमच्या मुलांनी त्याला एक प्रश्न विचारला की या यशाचं गमक काय. तर त्यांनी काय सांगावं की बुद्धी, हुशारी, प्रयत्न हे सगळं आहेच, पण याच्या जोडीला नम्रता हवी आणि ती नसेल तर प्रयत्नपूर्वक मिळवायला हवी. मी तो ज्येष्ठाज लक्षात ठेवलेला आहे. आणि मला कुठेही भाषणाला बोलावलं, शाळेत मी अजून जाते, मला आवडतं माझ्या शाळेत, तर मी मुलींना किंवा मुलांना हे सांगितल्याशिवाय राहत नाही. ज्येष्ठाज जोशी काय म्हणले की नम्रता हवी आणि ती आज त्या गोष्टीची खूप गरज आहे असं नक्की वाटतं आपल्याला. आज ज्येष्ठाज अनेक विद्यार्थ्यांना संशोधक बनवतोय, मार्गदर्शक करतोय, पण त्यावेळी तो गावाला विसरत नाही. या यादीत अनेक इतर मुलं असतील, पण मसूर, कराड, सातारा हे विसरत नाहीत. त्याच्या PhD मध्ये बघा तुम्ही, भरपूर मेजॉरिटी या लोकांची असते. आणि मला आणखी सांगायला थोडंसं हरकत नाही की माझा नातू हा सुद्धा सध्या ज्येष्ठाजकडे PhD करतोय आणि तो इतका सरांच्यावर खुश की काय बोलायचं नाही. म्हणजे घरातल्या लोकांचं आमचं काही इतकं ऐकत होतं असं मला वाटत नाही, पण सरांचं मात्र खूपच तो ऐकतो. म्हणजे ज्योत से ज्योत जगाते चलो अशी जी काही परंपरा आहे ही शिक्षकाच्या आयुष्यात घडली पाहिजे आणि ती ज्येष्ठाच्या आयुष्यामध्ये ही घडते आहे, त्याचा आम्हाला अभिमान आहे. आणखी एक सुद्धा ज्येष्ठाच्याबद्दल सांगायचं विशेष म्हणजे ज्येष्ठाज ज्या शाळेत शिकला 60 वर्षापूर्वी, त्या शाळेला तो आजही विसरलेला नाही. आजही म्हणजे खरंच आजही दरवर्षी जून महिन्यामध्ये पहिल्या टर्मला आणि दुसऱ्या सेकंड टर्मला ज्येष्ठाज त्या शाळेला देणगी देतो आणि तिथल्या मुलांना वह्या पुस्तकं, गरीब मुलं असतात आणि ती गरीब मुलं असतात त्यामुळे मराठी शाळेमध्ये मुलांची येण्याचं प्रमाण खूप कमी झालं. आता इंग्लिश मिडियमच्या शाळा चालतात, पण आमची ती मराठी मिडियमची शाळा विद्यार्थ्यांची संख्या वाढते, कारण असं लक्ष आहे लोकांचं. त्यामुळे ज्येष्ठाज न विसरता दरवर्षी आणि मध्ये मध्ये येऊन भेटतो सुद्धा, त्या मुलांचं कौतुक करतो. ही जी काही प्रवृत्ती आहे ती सुद्धा त्याची कौतुक करण्यासारखी आहे. सर्व जे कुटुंब आहे त्या कुटुंबियावर त्यांचं प्रेम आहे आणि यामध्ये त्याला पत्नीची साथ आहे. आपली शांत सोज्वळ स्वभावाची, कुटुंबाला पूरक मदत करणारी अशी पत्नी लाभल्यामुळे जोशी कुटुंबाचा ज्येष्ठाज आणि ज्येष्ठाची पत्नी हे आधार आहेत हे मला कळतं, कारण मी त्यांच्या सगळ्यांच्या घरी जाते. सुनंदाच्या घरी जाते, सौदामिनीच्या घरी जाते, आणि त्यामुळे मला हे कळतं की ते सगळेजण काय बोलतात. तेव्हा दुसरा एक महत्त्वाचा भाग म्हणजे योगायोग असा की माझी 75 झाली 9 वर्षापूर्वी. त्यावेळेला माझ्या मुलांनी ज्येष्ठराजला बोलावलं होतं. 75ला मोठा कार्यक्रम केला होता, टाऊन हॉल घेतला होता, आणखी काय गायक गाणी अमुक तमुक. पण त्या सगळ्यापेक्षा त्यांनी ज्येष्ठराजला बोलावलं होतं कार्यक्रमासाठी आणि त्याच्या हस्ते तो पुरस्कार घेतला. हे मला अतिशय आवडलं होतं. आणि आज म्हटलं ज्येष्ठराजनी मला आठवण ठेवून आम्हाला बोलावलं, ही फार मोठी भाग्याची आणि आनंदाची गोष्ट आहे. आज म्हणून आमचे भोज सर, आम्ही दोघंही वाईचेच आहोत, वाईहून यायचो. खूप कष्ट होते त्यावेळेला सगळ्या गोष्टीचे. वाईहून यायचं, गाडी करायची, मग रेल्वे करायची, मग टांगा करायचा. रस्ते नव्हते, गाड्या नव्हत्या, पण या सगळ्यात जे जे काही झालं त्यात कधीही दुःख कुणाला वाटलं नव्हतं. आनंदी आनंद होता. आणि आजसुद्धा आपण आम्हाला बोलावून हा आनंद आम्हाला पुन्हा मिळवून देण्याची जी काही संधी प्राप्त करून दिली त्याबद्दल आम्ही कृतज्ञ आहोत. त्याचा वाढदिवस विद्यार्थ्यांनी साजरा करावा हे सर्वात मोठं यश आहे. शिक्षकांच्या आयुष्यातलं किंवा प्राध्यापकांच्या आयुष्यातलं हे सगळ्यात मोठं असतं. आई, मुलं, आपली घरातली माणसं करत असतात सगळ्या गोष्टी, पण शिक्षकाला जर विद्यार्थ्यांनी असा कार्यक्रम केला तर त्याच्या इतकं मोठं भाग्य नाही. आणि असं भाग्य आज त्याला लावलं आहे. 75व्या वर्षी कृतार्थ जीवन ज्याचं झालेलं आहे, ज्याला सगळं मिळालेलं आहे, अशा ज्येष्ठासला अजून खूप काम करायचं आहे. काम काही संपलेलं नाही आहे. आणि मला वाटतं त्याला ती आहे, उर्मी आहे काम करण्याची. तेव्हा तुमचं सगळ्यांचं प्रेम, आमचं सगळं प्रेम, आपले सगळे आशीर्वाद हे त्याच्या पाठीशी राहतील आणि त्याचं आयुष्य चांगलं, सुखाचं, आनंदाचं. भोज सरांनी सांगितलं त्याप्रमाणे व्यायाम केल्यानंतर आणखी खूप तब्येत चांगली राहील, असं चांगलं आयुष्य जाईल. आणि आम्हाला ते बघायला आम्हाला किती दिवस मिळेल तेवढा आम्हाला आनंद वाटेल. आणि म्हणून बोरकरांच्या शब्दात मी असं म्हणेन की देखणी ती जीवने, या लोकांची जीवनं कशी आहेत? देखणी ती जीवने जी तृप्तीची तीर्थोदके, चांदणे ज्यातून वाहे शुभ्र पाऱ्यासारखे. अशा प्रकारचं शुद्ध सात्विक जीवन लाभलेल्या आमच्या विद्यार्थ्याला आमचे खूप खूप आशीर्वाद. धन्यवाद.
खूपच छान मॅडम. मग तुम्ही असं दोघांनी बोलत राहावं, तुम्ही आणि भोज सरांनी आणि आम्ही वर्गात बसलो आहे असंच एक वाटतं आहे. हल्लीच्या काळामध्ये एवढी शुद्ध आणि प्रामाणिक मराठी ऐकायला पण मिळत नाही. आणि तुम्ही एवढ्या तयारीने आलात आणि सरांबद्दल जे सांगितलं त्या भावना खूपच उत्कट होत्या. विद्या विनयेन शोभते हे आम्ही कायम सरांकडनं शिकत आलो आहे. आणि त्याची पेरणी तुम्ही त्या 60 वर्षापूर्वी दोघांनी केलेत आणि इतर सरांनी. त्याबद्दल खूपच कौतुक आणि तुम्हाला धन्यवाद सर्व आयोजकांतर्फे. मी आता पंडित सरांना विनंती करतो की त्यांनी सर्व रिस्पॉन्डंटचं मानचिन्ह देऊन सत्कार करावा. प्रथम अनिरुद्ध जोशी, डॉक्टर अनिरुद्ध जोशी. तू असा येईल फोटो? पानसे सर. मोरेश्वर काका. कृष्ण बलरामच्या जोडीसारखे तुम्ही आज सांगितलं, खूपच. मान्यवर भोस सर. त्यांना जोरांनी बोल. आणि तामणकर मॅडम. किती योग आहे बघा बाई, तुम्ही सरांना शिकवलं, आज तुमच्या नातवाला सर मार्गदर्शन करतायत, त्यामुळे मास बॅलन्स होतोय. मी पंडित सरांना विनंती करतो, त्यांनी 2 शब्द बोलावेत.
Professor Sharma, Dr. Mashelkar, Dr. Kakodkar, all those who have gathered here, Kishore Bhai, Sandra, Shroff Madam, Mrs. Joshi, Mrs. Kakodkar, Smita, all my friends and those who have been eternal students of Professor J.B. Joshi. As long as he is there, he is available, very similar to Professor Sharma. This 4th session today was more like expressing ourselves in terms of not only what we think, but what other people think of Professor Joshi and how it validates our own thought process. Aniruddha talked about time management as well as importance of family time and how the logic of time management can also be extended to time series understanding in terms of Nadi Taranga and how it can be linked with the general and overall health. And Moreshwar Kaka also made a reference to that, saying that the basic form of inner understanding, which is responsible for inner health, which is the spiritual health. And as you would see from this entire today's session, there were a couple of major points which we can take away. One is the importance of a spiritual base for whatever you do. The early moorings and learnings from our scriptures like Jnaneshwari, Dasbodh, Manache Shlok, they are the teachings when learned in our earlier life remain with you for the rest of your life. And when you are able to imbibe those, you continue to behave as such. And that is what brings in the humble nature, the inner understanding, and the basic ability to ask the right question, which itself provides half the answer. Many a time, it is difficult to understand the question, and that's why if you are in a position to understand the question, many a times the answer offers itself. It was very nice to see and hear from Sir's teachers, as what you see today, where that original teachings and original thinking process comes from, those who have learned from such schools, especially Marathi medium schools, in those years, in 60s and 70s, you will see there is a big difference between the thought process of those students and the thought process of modern students today. I'm not saying that it is bad, but it is important for us also to remember those old days, because those, in my opinion, were the true learnings, because there were no distractions. And when you don't have so many distractions, what you think is a thought which has come from within rather than coming from external influence. If you are able to internalize your surroundings, and that is what I have learned from Professor Joshi, observation is critical. Questioning and thinking about that observation is important. And then you see the difficulty which comes out of that observations, either for you or the people around you, and whether you have the capability to solve those difficulties, and whether you can take up those issues and offer the solution as a solution engineer. All this has come out very nicely, but with a philosophical touch in this fourth session. On my personal front, I'm not going to give a big talk, but whatever I am because of Professor J.B.Joshi and Professor M.M. Sharma. Whatever I have learned, all the guidance has come from these two people, and I'm eternally grateful for that. And I'm very, very grateful for giving me this opportunity to express my gratitude to Professor Joshi and Mrs. Joshi. And I would like to say something on behalf of my wife as well. She has conveyed to you both that she came into ICT as a daughter-in-law of ICT and eventually turned into a favorite daughter, seeking for shabashki from both of you, and she'll remain like that. Thank you very much, sir, for all what you have given, and we hope you will continue to do that for us. Thank you.
Thank you, Professor Pandit. It was apt summarization. As you rightly said, the last session of the day was more also on the philosophical front, and it was like a homely kind of thing. जसं मी म्हटलं तसा घरगुतीसारखा त्याला खूप छान स्वरूप आलं. त्याबद्दल खरंच धन्यवाद. Because 60s and 70s was the schooling where focus was more on bringing the values, not value. 60s and 70s possibly was the teachers where the wisdom was something which is coming to the students, not just the knowledge. आणि असे शिक्षक आलेत, त्यामुळे असे विद्यार्थी आणि आमच्यासाठी असे शिक्षक घडलेत. त्यामुळे पुन्हा एकदा सगळ्या घरच्या लोकांचा धन्यवाद. आपण आपली जागेवरती स्थानापन्न होऊ शकता. There is one announcement which definitely yes. Sorry. Yes, please. No, that is required, sir. Request Pandit sir to be felicitated by Apa Deshpande sir as a session chairman. And being a vice chancellor of the ICT, entire facility, infrastructure, involvement, supports is definitely coming because of him. I have one small request, Smita madam, if she is around, Dr. Smita Lele. Yeah. Yes, please be available. And as we also have Sandra madam here, the vice chairman of UPL, I will also request Pandit sir to do the honors and our memento and felicitation of Sandra madam. Volunteers? Yeah. पुस्तक सर. Right. Please. सांगतो. Thank you for coming, Sandra ma'am. I request Sharma sir to be there itself for some time. We have one book which is being written by Dr. Smita Lele in Marathi, Anandi Jivanache Vignan. And she being requesting Professor M.M. Sharma, Padma Bhushan Professor M.M. Sharma to release the book. And that copy of the book will reach all of you in absolutely no time. Our volunteers will do that. Anandi Jivanache Vignan. So it means science of being in a happy life. Anandi Jivanache Vignan. And then I would also request Kondekar sir. Sir, yeah. Appa sir. Yes, yes. So I would request Mashelkar sir. Kondekar sir would request you to release the quarterly bulletin, Parabrahma and Purna Brahma, with the hands of Dr. Mashelkar. Appa sir. Thank you very much. I think we are nearly on as per the schedule. Now the most awaited part which will be happening soon is about felicitation of Padma Bhushan Professor J.B.Joshi, and the honors would be done by 3 Padma Vibhushans, Professor Sharma, Dr. Mashelkar and Dr. Kakodkar. Okay, sir. Can I request Joshi sir and madam, the felicitation, the most looked after the session. Keep your cameras ready if you would like to take us now, because it will be going live on the YouTube. It will be uploaded subsequently. It will be also released through JBJ's channel. But we are lucky enough to witness it offline. Yes. And Professor Joshi very clearly told me that Bose sir आणि तामणकर मॅडम तुम्ही पण या त्यांच्या सत्कारासाठी यावत. त्यामुळे सर्व सरांचे शिक्षक ICT मधले आणि मसूरचे आणि काकोडकर सर. शर्मा सर, माशेलकर सर, काकोडकर सर, भोस सर आणि तामणकर मॅडम या 5ही जणांच्या मान्यवरांच्या हस्ते सत्कार होईल. पंडित सर आपण सोबत राहू शकता सर तिथे. आप्पा देशपांडे सर आपण पण परिषदेतर्फे. आणि या सत्काराबद्दल थोडक्यात कल्पना देतो. सरांचा तारखेने द ॲक्च्युअल बाय डेट 75th year birthday was on 28th of August. But as today being a Sunday, 28th of May, I'm so sorry. I am also being on a jet lag through being talking since morning. And today being a Sunday, we are doing it at ICT. And there are a couple of things which you must have seen. There was a surprise element of a Rangoli, 2 teachers being got from the native place, lot of visual displays being made. And you will see something more, which will be a part of a felicitation. So first let us take the photograph. So I would request all chief guests and dignitaries to felicitate Padma Bhushan Professor J.B.Joshi with a shawl, Shrifal. Aniruddha, you want to take photo? Aniruddha, action replay. Then we will also have something very interesting to be the citation, which I will read out as Deshpande sir very clearly said. This citation is in Marathi. I will read out the way it is. Then it will be conferred on. Yeah. Before that, Bose sir आणि तामणकर मॅडम आपल्या लाडक्या विद्यार्थ्याचा सत्कार करतात. Okay, so the citation you can see all here. So now we have a citation. I request all guests to be there itself. Citation is like the one which you can see, and I will read out what is being mentioned on that. Padma Bhushan प्राध्यापक डॉक्टर ज्येष्ठराज भा जोशी सर, आपण वयाची 75 वर्ष पूर्ण केलीत त्याबद्दल आपले अभिनंदन. समाजाला, शेतीला, राष्ट्राच्या संरक्षणाला व देशातील कारखानदारीला उपयुक्त अशा मौलिक संशोधनाचा तसेच हजारो विद्यार्थ्यांकडून सुजाण नागरिक व यशस्वी संशोधक आणि उद्योजक घडवणारा आपला 75 वर्षाचा एक समृद्ध जीवन प्रवास आहे. मराठी विज्ञान परिषद अँड ICT बोथ. So on behalf of them, I request Mashelkar sir to present the citation to Joshi sir. Then there is one more surprise. We have seen the Rangoli. Now you can see a portrait, color portrait of Professor J.B.Joshi. I would request Kakodkar sir to present to Joshi sir. Then as you know, behind every successful person, there is a head office. And there is a strong madam, which we have been seen for last 40-45 years. I would request Kakodkar madam, please, to felicitate Joshi madam. And I think on Sunday they are going to have their wedding anniversary. Am I right, madam? Correct, na, Anirudh? Yes, correct. Next Sunday. So, yeah. Appa sir, I think felicitation party is over. Yes. Thank you very much. Now, the most important thing, what we are very eager to hear is a response speech from Professor Joshi sir. पाण्याची बाटली, sir. इथे उडी ठेवा.
थोडे पितात. My esteemed and revered teachers, Professor Sharma, Dr. Mashelkar, Dr. Kakodkar, the two teachers who have come from my native place, Bhoch sir and Tabankar madam, my other mentors, Shri K.V. Mariwala and Mrs. Sandra madam, all my industry friends, in particular my research collaborators and dear friends. Maybe first of all I'll say that my simplicity and keeping feet on the earth was praised too much. I'll respond to that first. Why my feet are on the ground. When I got Padma Bhushan and I came back home, my son said, Baba, your Padma Bhushan is outside the home, not inside. You have only one promotion and one recognition remaining in the life, and that is when you become Azoba. And that promotion is under my control. I can tell 10 things like this. That is why my feet are on the ground. Both of them, not even 6 hours lapse of time, I'm brought on the ground by my wife as well as son together. And what he said predicted that your promotion will happen when you become Azoba, that became really true. I was so happy, I'm also so happy. My young granddaughter, she took one dinner plate and took one big spoon and hit the dinner plate. That was a noise, of course, but she liked it. Since she liked it, she did it several times. And it was a big bang, almost big bang. And in that tune, he asked me to dance. She asked me to dance. And I really danced. I forgot who am I. I'm Azoba, of course, I'm grandfather. That much I remembered. So there are many, many stories, and humble. I'm on the ground. My protein deficiency was discussed earlier. Definitely, I'm going to say it again. My weight was 43 kilograms in final year. And Sharma sir identified it. And he gave me 50 rupees. And the protein cube was available in 2 rupees. So that was a month's stock. And then again, I was supposed to go to him and eat protein every day. How much care he has taken. Later on, he told the story. He little bit softened it. The real story is, he told my wife to put under lock and key. And if this fellow makes any noise, you phone him, I will fix him. That was the real sentence. And then I take
now my son, daughter-in-law, they praise me that how this particular investment you have done and how much it is useful to our family. But this story I have told them, but this is the story behind that investment. That was otherwise I was going to be under lock and key. My PhD was a real balance between theory and experiments. As he said, 1 meter diameter and 3.6 meter length. That reactor was installed in Advanced Center building. Once he visited and said, "Arey, where are you, J.B.? You are not seen here in front of the reactor." I was such a small person. The intuitiveness and the readiness and the curiosity for developing relationships between design objectives and fluid mechanics, that started from then. When I developed the new correlation between backmixing and the fluid mechanics inside, that developed a lifetime, you can say, lust for developing such relationships further and further. Then I was supposed to find out design characteristics of self-inducing, gas-inducing reactors. And I completed that work again in 1 meter diameter vessel, smaller one, 50 centimeter, 40 centimeter, and developed correlations for gas induction. Sharma sir told you about my beginning of relationship with Shri KVM. I very proudly told him that I have a lot of hydrogenation was ongoing. Therefore, I proudly told him that I can reduce the time of hydrogenation. Let us implement gas-inducing reactor. And on my saying, he really prepared a pilot plant. But pilot plant gave rate of induction 2 liters per second, and the desired one was 50 liters per second. This was very easy to understand. He also understood. The pilot plant was done. But the desire to know the relationship between fluid mechanics and reactor design, here the rate of induction, I started thinking about it. And after understanding that relationship, I not only got 50 liters per second, I got even up to 200 liters per second, 500 liters per second, and then it was immensely successful. But if that pilot plant was not done for 2 liters per second, no development would have occurred. Though laboratory was 1 meter diameter, what was done in Bombay Oil Industries was 1.5 meter diameter. And then in the first experiment, it was not successful, it was a failure. How many things I should tell about him? He had cracking of castor oil in mind. And that was done in batch mode. I'm talking about late 70s. That was being carried out in batch mode. And 60-70% polymerization would occur, and only 20-30% would be the product. Again, fluid mechanics and design. The reaction time, if it is more than 2 seconds, the polymerization should occur. Therefore, it was important to design the reactor where residence time is only 2 seconds, and after 2 seconds, reaction temperature was 350-400 degrees centigrade, and after 2 seconds, it should be quenched, otherwise polymerization should occur. So converting batch into continuous and a micro reactor of 2-second residence time and a capacity of 20 tons per day, that I had done, but I did not know that I am designing micro reactor or doing process intensification or converting batch to continuous, but I started doing that. This really entered into a lifetime agenda. I forgot one thing about my house in Dadar. It costed me 1.5 crores at that time. I was earning, as sir told you, but I was not earning per year that much. And Sandra madam and Shri Ravi Goenka and Shri Ravi Mariwala, they helped me at that time and quickly made 1.5 crores ready at that time. So I have not thanked my industry collaborators in an ample way, but today I think I'll take this opportunity, right from Bombay Oil Industries and Indian Organic Chemicals and Lakshmi Organics and Alkylamines and Chemicals and Technoforce and many more. So I thank them profusely. They gave me the opportunities, they believed me, and now today I have a confidence. If experiments are done at 1 liter scale, I can design a reactor of 1,000 meter cube, 1 million liters, even a multi-phase reactor. So enough experiments should be done at 1 liter. These days, I am taking the comprehensive help of computational fluid dynamics as well as artificial intelligence. So all these tools put together are giving me, these days I am getting many, many more assignments. I only take care that I am able to give sufficient time, but I am not afraid of anything. This lifetime agenda started from, I don't know, whatever 5 years, 10 years are remaining, I will continue that agenda. I'll tell a little bit more sometime later. I'm a real fortunate person. Nobody in this world, from my age of 20 till today, Professor Sharma is my guide, mentor, teacher, boss. From my age of 50 to 60, Dr. Mashelkar was my guide, boss, when we attend the deemed university setters. And from 60 onwards till today, Dr. Kakodkar is my teacher, mentor, boss. And 3 Padma Vibhushans having your boss over a long period of life, I don't think anybody, none of them also would have such bosses. And how much I have gained from them, different qualities. And when Dr. Mashelkar was guiding me for getting autonomous status and deemed university status, whenever I was going to tell him any success, that I have done a good job, I have to go to him and tell him I have done a good job. He had given me complete freedom. So he would give me marks, 99%. You have done such a good job, so you get 99%. I was very happy, delighted, and went back. And one of these days he gave 100%. This means all our 99% something was not up to the mark. Then I started introspecting, what was wrong in all our. So whenever it was 99 or 100, 99 means something more work is to be done, some more understanding has to happen, some more people have to be contacted, more money to be collected. Something was missing. That was the meaning of 99%. and 100% is when all these things are. During that period, he was saying, you are down to earth, you speak nice, you behave nice, and you are the only person who can bring autonomy. I was feeling really good that I am the only person, there is no other person. That was not correct, but I was feeling that. And with that zeal and enthusiasm and energy, I worked together. But behind that energy, there was real driving force. And he was always available. He was the Director General of CSIR, taking care of 38 laboratories. And whenever I phone, he's available. And, sir, can you please come next Wednesday? Oh, yes. I'm telling you, one of these days, I will tell you the entire success story of deemed university. But these are the forces. Sharma sir has been always available, not only for this project, plenty things. When I took up the directorship, Dr. Kakodkar invited me and said that there is a list of DAE problems. And there were 13 problems to begin with, which started about 2001. Important were reducing the cost of heavy water, then simulating advanced heavy water reactor, simulating fast breeder reactor, and another set of problems. And my colleagues in chemical engineering, together with students, I must explain to you, whatever I have achieved, more than 95-96% is contributed by my collaborators. Mine is 4-5%, whatever is there. Now, I'm trying to solve social problems through PhD students. I'll elaborate it a little later. But they are joining enthusiastically. They are not worried about what will happen after PhD, whether I'll get job, I will not get job, what will be the kind of job. And after joining, they are doing, let it be fruits related, waste related. So the students is the real strength of my journey. I wanted to start thanking ICT. Great ambience. I don't think anybody can take credit for. The institution gives so much that the person becomes creative. The ambience itself is creative. So I thank my mother institutions. I also thank organizers. I'm not finishing my lecture. I'm thanking organizers who have done a wonderful job today, painstaking efforts. The heads of Nehru Science Center have come. They are also my collaborators, and collaborators from a variety of institutions. So then he offered me, Dr. Kakodkar offered me Homi Bhabha chair. And what he told me, that we have a hidden agenda for you. Nothing explained, only appointment letter and no agenda. Anyway, I had, the HBNI was founded then, and I could realize the number of guides in BRC or in general, IGCAR, the number of guides are not sufficient, equivalent to availability of students or problems. So making new guides, by making co-guide for initial 5-10 years, making 10, 20, 25, 30 guides, that was one hidden agenda. See, the way in which I have an hidden agenda. So I pick up myself what is. The second one he said, note down what he said. And I will also copy him one of these days. In TIFR, lot of good work people are doing. They are extraordinary scientists. They solve any problem of physics equivalent to anywhere in the world. But they need to contribute to the atomic energy program. Next sentence. JB, I have failed in doing this. Can you do this job? You get such energy, such energy. Not that he could not do, but for me, like Dr. Mashelkar, for feeling a lot of energy and enthusiasm. And then I did that to whatever I could do. And then so out of such hidden agendas, there are so many things. And I learned so many things that is, in my opinion, science is easy. Money is easy. Place is easy. Library is easy. What is not easy is handling people. So that's what he taught me. That is talking to the people right from Sharma sir. That was not direct teaching, but the way in which he was bringing institution, I would not say from negative, but at least from zero to the pinnacle, in such a way that he was selected for naming the Lifetime Achievement Award of US Institution of Chemical Engineers. UK. Why? I was very close to that committee because I was providing the information. Big names were being taken. I don't know whether I should say those names, but real big names. But those names were endowed with facilities. And they had names like Cambridge, they had names like many other universities. But this professor has no background. I will say the negative background was there. But in that, he brought it from almost zero to whatever is today. So the manhandling, the people are of different, right from top to bottom to junior level, but getting things done, that was. Once he told me, we have been on many committees together. So in one of the committees, I asked him leave of absence. Why? Because a project proposal from ICT was to come. And I may get favorably inclined to that proposal and approve it. So he did not agree. But I did it second time. Then he said, if your mind is clear, there are no bad intentions, and if you don't have selfishness, why do you worry? For a person like me, I don't know, I should say Sir Kakodkar sir, my apologies. He said that for me also, there are charges of money laundering. Forget it, don't worry. It will happen in lifetime. Many times it will happen. Just don't worry. If your mind is clear, no selfishness, just go ahead. Similar sentences have been written in the writings of Swami Vivekananda. I took it in those words And then I did not say at that occasion or in similar occasions or wherever I am chairman also, I don't worry, I don't worry. That gas inducing, I must tell you a little more. I developed it under the guidance of Professor Sharma and under the mentorship of Sri Kavi Mariwala. And then it was commercialized right from 100 liters to 50,000 liters. But none of them even distantly indicated that we guided you. That entire commercialization and money earned from that, 100% came to me, 100%, nothing. So this is a learning, no? Then you reciprocate to your students in the similar manner. So this I learned with Bombay Oil Industries, that is how to develop friendships with variety of people for getting the things done. I had to face some difficulty at the beginning, and I was Seth Kadmi, so I had some resistance. But he told me to keep patience, and in between, I had gone to USA for 1.5 years. So what plant people used to do is to teach me. Instead of getting guidance from me, advice from me, they used to teach me. Some kind of ragging. So what I did was, really I know nothing, so you are teaching, it is good for me. And I was asking them questions that I don't understand this, I don't understand this. They were thinking about it and teaching next time. And then I was asking additional set of questions. And those answers, whatever they were getting, they were implementing in the plant. I was not involved while implementing. Then I went to USA for 1.5 years and came back. And all these plant people, they came to me together saying that while we were teaching you and you were not available for learning from us, we did no progress. Only in your presence we did progress. So this strength of developing confidence in design and scale up, it added up one by one. Where is it? I'll tell you a little bit about my childhood. My father, he was more interested in philosophy and teaching, as everybody has told, to the village people. But he had two small businesses. One was converting sugarcane juice to jaggery. So it included steps like crushing, evaporation, and for evaporation some fuel was required. So he was taking me with the installation, and during burning, most probably bagasse, somewhere from some locations blue flame was coming. Some locations yellow flame was coming. Later on I realized, after I started research work here, yellow flame means 500 degrees. The blue flame means 1100 degrees. And the burning efficiency is directly proportional to the color of the flame. Obviously I was not knowing. So after evaporation, some scavenging of non-wanted materials, followed by cooling and solidification. So the installation of crushers in level and evaporation, whatever were the empirical understanding at that time. So I used to observe that he was taking me on bicycle at various places. But that problem, Mr. Koke told in the morning, we did computational fluid dynamics of household cook stove. Those who have come from villages, they can visualize the cook stove. The biomass is introduced from one side, again yellow flame together with lot of smoke comes out on one side. The room is full of smoke and the housewife, with the help of a pipe, she tries to intensify the flame. That is the picture. I did computational fluid dynamics. You please remove. I means my students. They did computational fluid dynamics. I'll tell you about computational fluid dynamics. I started in 1980 and it was not being used, nothing in India. I started. So it is now what, 45 years ago. But Vivek Ranade, Ashwin Patwardhan, Vivek Vitankar, Sachin Matpati, I can keep on getting the names. They are ahead of me and they do much better job. One Reliance senior executive had come to me and there was a problem of CPVC, three-phase reaction, chlorination of suspension of PVC. And to show my greatness, I told that senior person, I don't have time, means that was not truth. In order to show off, I said, I don't have time. You please go to Ashwin Patwardhan, he will do a good job. Anyway, he would have been doing good. Then that executive said, sir, his name came to us first. We went to him, but he is not having time, therefore we have come to you. These are my students. So now also I talk to them politely. Pandit is another example. And many, Smita is sitting here and many students are there. One student, after PhD, he met me and he said me, sir, in last 4 years, you have given me 243 minutes. 243 minutes, that's it. So I was considering what did I do? The point I'm arriving at is the new generation, boys or girls, they are so good. I'm so happy. Take any project, society related, science related, fundamentals related, physics of turbulence related, take any subject, they do a good job. They do a good job. There are some responsibilities of teachers that must be done, but they really do a good job. We have these days started that cookstove story. Mr. Kokil told you that we are going to go to 60%. There is one center of excellence in MIT for global warming. And their report says that 15% of carbon dioxide comes from vehicular pollution. And 18% carbon dioxide comes from household cooking. So that problem is serious. And those cook stoves, 18 crore, their number says there are 18 crore cook stoves in the world. And all of them emitting they added it up, and India has taken an oath to reduce carbon dioxide by 5 gigatons, out of which 1 gigaton comes from cook stoves. So the professors from there, particularly from D Lab, we had published the CFD simulations and all the resistances we included in CFD. And we kept on getting answers, we were implementing and optimizing. We published papers, and therefore, through the contact of KVM and our publications, MIT contacted me. 2 problems. They wanted to implement new technology in Africa, where cook stoves are plenty in number, even more than India. So when they come for collaboration, first of all, I requested them that you put 2 cook stoves in your MIT laboratory, first of all. तर आपल्या घरी चूल असते ना, त्या चुली बसवल्या आहेत MIT मध्ये त्यांनी खऱ्या. And then there is one postdoctoral working on that efficiency. So in the Himalayan front, we took one problem together, that in addition to a cook stove in the kitchen, there is another cook stove in the living room. And we had monitors to measure carbon monoxide, carbon dioxide, NOx, SOx, particulate matter. And then we put those instruments at various locations in Himalayan homes and did computational fluid dynamics of kitchen and living room, and with boundary conditions of cook stove, whatever is coming. There were many complexities because there were doors to the house and windows were there. There was heat loss. So it was complex, but it was done. Notably, what was done was workshops were taken in Himalayan homes, Himalayan region at some places, and they were taught how to build efficient cook stove. That was highly efficient. This program was highly efficient. Then our students went to Nepal and interior of Himalayas, and they did this job. That collaboration is continuing, and again with the grace of, I don't know, I'm supposed to announce or not, but can I announce? Maybe a little later, not today, okay. Something interesting, useful is going to happen to ICT. So we did, they also had another technology, MIT, to make coal from biomass. This is being done in India, in most of the jungles, but everywhere the efficiency is less, maximum 12%. And MIT had an efficiency of 15%. So the limitation had come to propagate that technology. Anyway, we were in touch. See, when we make a sophisticated equipment for pyrolysis, we can definitely get 30%. Why 10%, 50%, 30%, 35%? But the equipment has to be simple. That is important. So with very simple equipment, and simple equipment had another drawback, that a lot of pollution was occurring. So again, my students, they developed a very simple system with improved energy efficiency and 25 to 30% coal coming out of that. And we are going to implement it now. 2 agricultural universities in India, in Maharashtra, they are collaborating with me to propagate this char as a soil conditioner. RGSTC, under the chairmanship of Dr. what is important for RJSTC and particularly chairman, that if you are observing something, that there is increase in productivity by 20%, 25%, 30%, and I did all the experiments with soybean. Why? Why? And whether there can be some other formulation. So now this new mission is under formulation. So one of these, I think ChemDis people are here. A technology has been developed, has been fabricated by them. This simple technology, there is nothing. Taking drums which are easily available, pipelines which are easily available, so that in 10,000 rupees the equipment is ready. What we realized was, unless we take liquid as a product and solid as a product and gas as a product separately, it is never going to be economical. If you make in 10,000 rupees, then also biomass will cost 3 rupees, 15% is the, and the cost of char will be 18 rupees, 20 rupees. Who can afford? And is the increase in yield of soybean, is it commensurate with the cost of biochar? No. So what we are doing is sophisticated equipment costing 5 crores, but you get 33% char, 33% liquid, and that 33% liquid, we requested Bharat Petroleum to mix it with the feed of crude oil, and it became successful. And since that was successful, they are ready to give 25 rupees per liter for that liquid. And now that coal is becoming free, and now it can be used. Of course, science behind it has to be. So by one more problem I have been saying about the cashew apples in Sindhudurga district. 21 lakh tons of cashew nuts, and there are right now 3 PhD students working on that problem. Separating vitamin B, separating vitamin C, dietary fibers, polyphenols. These simple problems, when implemented and money goes to the right locations, to the farmers, then the per capita income, it is easy to calculate on fingertips that it is going to double of that location. Sorry. So after 2 months, I am going to go to US, and there is a get-together of Marathi-speaking people. Last year, our Dr. Mashelkar was chief guest. This year, I am going to be chief guest. And they have asked me to present opportunities of 36 districts of Maharashtra. And they want to enhance the income of Maharashtra by some percentage by implementation of this. Technology possibilities I will tell, but other whatever is required in terms of guidance of marketing and finance, etc., that will be done by. So for getting a list, Professor Anil Gupta of National Innovation Foundation under the chairmanship of Dr. Mashelkar, they have listed 300,000 innovations, grassroots innovations. I'm going to go through that, what is relevant for Maharashtra, but they have made my problem simple, and Professor Anil Gupta is available for discussion anytime. So I wish to do a good job. This particular, my interaction with young generation, I have been liking. This increase in preparedness of young generation, if nothing happens, say for example, that itself I have been liking. Right now I have about 5 doctorals and 15 PhD students, and I'm able to support myself through my earnings, all these people. And when I get additional problems from 36 districts, I will need equivalent money of another 5 postdoctorals and 15 students. And some overseas organizations, they have contacted me for the help. I'm sure I'll get a lot of money from them and support these additional students. I will continue to understand the relationship between fluid mechanics and design. I don't think journey is completed. Electrolysis for winning titanium under the guidance of the best innovator of the nation, Dr. Gada. Electrolytic conversion of carbon dioxide to ethylene. Understanding of turbulence phenomena and prediction of drag lift forces, as well as interfacial transport phenomena. On NOx, I have been doing work for 30 years, and wherever there is problem in the world, let it be Japan or US or Europe, I am definitely contacted. My student, Naresh Suchak, he earned a very prestigious Kirkpatrick Award for NOx abatement. With the help of Mr. Patil, I'm going to start workshops on process intensification. Professor Sharma very crisply pointed out that if we reduce the cost of production by 15%, then we will be competitive in the world. So with this objective, we will organize several workshops. So finding problems from 36 districts means and solving them. So this is another mission started by Dr. Kakodkar under the title of Silage, and we will do that. So ChemDist, Technoforce, we talk about importing. Technoforce is fabricating equipment and exporting. Regarding biohydrogen, not only we will export technology, but equipment made here, I don't know, this may be more or less for the first time, that the entire technology together with manufacturing, everything will be supplied from India. So maybe I'll stop here. I'll thank all of you again. In particular, I'll thank my wife. Let me tell you about my wife, 2 minutes, 2-3 minutes. Behind a successful man, there is a successful woman. That was said earlier. But if you come to my house inside, behind a successful woman, there is a man. I'll tell you. When I got married, I had gone to my native place. And while coming back, my father was sitting in the train side by side. And somebody asked, Kaka, tumi kutha challai? Where are you going? So he said that I'm going to daughter-in-law's place. I'm sitting side by side. Should I have said no, my son and daughter-in-law's place? Directly said daughter-in-law's place. All my relatives who are sitting here, my nephews, everybody, even my son, he comes to Mumbai, मी आईकडे आलोय असं तो फोनवर सांगतो. I am nowhere. So, behind a successful man, that is, I don't think is a correct. She is successful, and I'm behind her. And she is supporting. She is really a rock. And in all those difficult times, I need not explain to you. Thank you so much. Okay. नंतर घ्या. Sorry for taking long time.
Thank you very much, sir, for your response speech. It was very touchy, and it's a long, long success story, lifespan. Sandra Madam, I could get your bouquet has come. Would you like to right away hand it over to sir? Sandra Ma'am? Would you like to offer him now so that photograph can be taken and it should be, everybody can see it. If you can face the audience, please. Vice Chairman of UPL, Sandra Shroff, Madam. Thank you for coming. Thank you for being waiting for long. Felicitating Professor J.B.Joshi. So we are approaching, friends, nearly 7 p.m. So I request Professor Joshi sir to take the seat and invite Appa Deshpande sir to express the vote of thanks and then declare the conclusion of this event, which we started since morning.
आजचा हा कार्यक्रम इन्स्टिट्यूट ऑफ केमिकल टेक्नॉलॉजी आणि मराठी विज्ञान परिषद यांच्या संयुक्त विद्यमाने असा केलेला होता. त्यामुळे मराठी विज्ञान परिषदेमध्ये जे.बी. जोशी अध्यक्ष म्हणून 2014 साली आले. त्यानंतर काय काय घडलं हे सांगणं फार महत्त्वाचं आहे. पहिली गोष्ट म्हणजे ते मला म्हणले रोज यायला पाहिजे का ऑफिसात. मी घाबरलो, म्हटलं नाही रोज नाही, आम्ही बोलवू तेव्हा यायचं. कारण आम्ही कार्यवाह लोक असताना आमचं स्वातंत्र्य जाणार अध्यक्ष रोज यायला लागले तर. पण प्रत्येक स्थायी समितीच्या मीटिंगला दरमहा ते येतात. क्वचित ते आले नाहीत असं घडलं आहे. पण त्यापूर्वीच्या कुठल्याही अध्यक्षांना तसा वेळ झालेला नव्हता. जे.बी. जोशींनी मात्र हा वेळ दिला. जे.बी. जोशी आल्यानंतर त्यांनी आमच्या उद्दिष्टांमधलं जो चौथं उद्दिष्ट होतं संशोधन करण्याचं, तर ते त्यांनी सुरू केलं आणि ICTमध्ये मुलांचं रजिस्ट्रेशन करून ते प्रत्यक्ष काम मराठी विज्ञान परिषदेमध्ये करायला लागले. आणि 3 विद्यार्थ्यांना PhD मिळाली. आम्ही एक बोर्ड तयार केला परिषदेत आणि आणखीन 3-4 जणांची आता लवकरच PhD होईल. परंतु ह्या 5-6 मुलांची फेलोशिप दरमहा 45,000 रुपये अधिकचा खर्च काही, असं हे जवळजवळ दरमहा 4-5 लाख रुपयाचा खर्च जे.बी. जोशी फाउंडेशनमधून होतो. आणि जे.बी. जोशी फाउंडेशनतर्फे मराठी विज्ञान परिषदेकडं 3 कोटी रुपयाचा फंड त्यांनी जमा केला आहे. तो कसा जमा केला तर त्यांना ज्या ज्या वेळेला कुठेतरी कन्सल्टेशन केल्यानंतर मिळणारी फी ते इकडे जमा करतात. एखादं भाषण दिलं, नुकतं त्याने आयुकात भाषण दिलं तर त्यांच्या फाउंडेशन डेला तिथं त्यांना मिळालेल्या मानधनाचं 25,000 रुपयाचं पाकिट न उघडता, तुम्ही विचाराल उघडलं नाही पैसे कसे समजले, त्यांना व्हाउचरवर सही करावी लागते. त्यामुळे अशी सगळी पाकिटं त्यांनी परिषदेमध्ये आणून जमा केलेली आहेत. म्हणजे पैसे मिळवणारे लोक खूप आहेत, दुसऱ्याला देण्याची प्रवृत्ती फार थोड्या लोकांच्यामध्ये आहे. जे.बी. जोशी त्यातले एक आहेत. महाराष्ट्रामधल्या शाळांमध्ये किंवा भारतातल्या सगळ्या शाळांमध्ये प्रयोगशाळा नाहीत आणि त्यामुळे मुलांना प्रयोग करता येत नाही. विज्ञानाचं शिक्षण इतिहासासारखं धडा वाचून होतं. त्यातून थोडा मार्ग काढण्यासाठी शनिवारी विज्ञानवारी आम्ही कार्यक्रम सुरू केला आणि कॉलेजमधल्या फर्स्ट इयर सेकंड इयरच्या मुलांना शालेय पाठ्यपुस्तकातले प्रयोग शिकवून त्याचं किट देऊन प्रत्येक 2 मुलांनी एकेका शाळेमध्ये 10 शनिवारी जायचं आणि 40 मुलांपुढे प्रयोग करायचे आणि करवून घ्यायचे. असा हा शनिवारी विज्ञानवारी कार्यक्रम करोनापूर्व 300 शाळांमध्ये झाला. म्हणजे 600 कॉलेजच्या विद्यार्थ्यांनी ह्याच्यामध्ये भाग घेतलेला होता. हा कार्यक्रम अजूनही चालू आहे. आणि मगाशी प्राज इंडस्ट्रीचे प्रमोद चौधरी जे म्हणाले मराठी विज्ञान परिषदेला आम्ही काही मदत करतो, तर त्याने 2023-24 आणि आणखीन पुढची 2 वर्ष प्रत्येकी 30-30 लाख रुपये ह्या कार्यक्रमासाठी दिलेले आहेत. याच्यासाठीचा अर्थातच दुवा हा जे.बी. जोशी हा आहे. मराठी माणसाला विज्ञानाची आवड आहे आणि जे.बी. जोशी तुम्हाला दिसतात हे विज्ञान संशोधन करण्यापुरते नाहीत. त्यांना सिनेमाची आवड आहे, त्यांना नाटकाची आवड आहे, त्यांना संगीताची आवड आहे. आणखीन एक सांगितलं तर तुम्हाला सगळ्यांना खूप आश्चर्य वाटेल, सोनाराच्या दुकानात जाऊन तिथल्या दागिन्याचं डिझाईन बघण्याची आवड त्यांना आहे. तेव्हा अशा पद्धतीने वेगळ्या वेगळ्या आवडी जोपासणारे जे.बी. जोशी त्यांनी विज्ञान हे नाटकाच्या माध्यमातून लोकांपुढे जाऊन आवड निर्माण करावी म्हणून विज्ञान एकांकिका स्पर्धा सुरू केल्या गेल्या 8-9 वर्ष त्या चालू आहेत. आपले गुरु M.M. शर्मा सर यांच्या नावाने त्याने 8 वर्षापूर्वी अवॉर्ड सुरू केली 1-1 लाख रुपयाची. कॉलेजमध्ये शिकवण्याबरोबर चांगलं संशोधन करणारे प्राध्यापक आणि विद्यापीठामध्ये संशोधन करण्याबरोबर चांगलं संशोधन करणाऱ्या प्राध्यापकांपैकी एकेकाला असं 1-1 लाख रुपयाचं पारितोषिक दरवर्षी द्यायला सुरुवात झाली. आणि शर्मा सरांनासुद्धा खूप आश्चर्य वाटलं की असा एक समज मिथ आपल्या मनामध्ये असतं की फक्त मुंबई पुणे या ठिकाणचेच कॉलेजमधले प्राध्यापक, बहुसंख्य प्राध्यापक आहेत, माफ करतील मला ते, की तेवढेच लोक संशोधन करतात. तसं नसून अगदी लहान लहान गावातल्या कॉलेजेसमधले प्राध्यापक लोकसुद्धा चांगलं संशोधन करत आहेत. आणि 2-2 बक्षिसं द्यायला आम्हाला आता अडचण पडू लागली, इतकी चांगली संशोधनं समोर येत आहेत. तेव्हा आपल्या गुरुचं ऋण त्यांनी हे 2 पुरस्कार सुरू करून फेडायचा प्रयत्न केला आहे. आणि शर्मा सर तुम्हाला आश्चर्य वाटेल, त्यांच्या मोबाईलमध्ये तुमच्या नावाने जो नंबर लिहिलेला आहे तो सर म्हणून लिहिलेला आहे, M.M. शर्मा नाही. गेल्या वर्षीपासून जीवनगौरव पुरस्कार 2.5 लाख रुपयाचा द्यायला सुरुवात केली आहे. आणि एक पुरस्कार हा फिजिकल सायन्सेसमधला, एक वर्षी जयंतराव नारळीकर, दुसऱ्या वर्षी माशेलकर सर आपल्या म्हणजे यंदाचा, आणि त्याच्या पुढच्या वर्षी काकोडकर. आणि दुसरा पुरस्कार हा मेडिकल किंवा बायोलॉजिकल सायन्सेसमधून, त्याच्यामध्ये कमल रणदिवे, कमला सोहने आणि रावी साठे यापैकी एकेकाच्या नावाने असा हा 2.5 लाख रुपयाचा पुरस्कार द्यायला सुरुवात झाली. आणि गेल्या वर्षी आम्ही तो पहिल्यांदा दिला. त्याच्याशिवाय मराठी विज्ञान परिषदेतर्फे कुठलाही नवीन कार्यक्रम करायचा असेल तर तुम्हाला माहिती आहे की ह्याच्या सार्वजनिक संस्था आहेत ज्यांना सरकारी मदत काही नसते, त्यांना पैशाची अडचण असते नेहमी. परंतु जे.बी. जोशी पैसे कमी पडत आहेत असं कधी म्हणू देत नाहीत. किती पैसे पाहिजेत असाच त्यांचा प्रश्न असतो. मला एका गोष्टीची फार मोठी चिंता आहे की जे.बी. जोशींनंतर दुसरे कोणी अध्यक्ष आल्यावरती आम्ही काय करणार. म्हणजे ही सवय आम्हाला वाईट पडू लागली. पण आपण सुद्धा 20 वर्षांनी आता पुढे नको म्हणालात. तर ह्या दृष्टीने आणि त्यांनी आयुष्यामध्ये जर काही केलं असेल काम केमिकल इंजिनिअरिंगमध्ये तर ते स्केलअपचं केलं. आणि तसंच काम त्यांनी मराठी विज्ञान परिषदेमध्ये सुद्धा कार्यक्रमाच्या संदर्भात आणि पैसे मिळवण्याच्या संदर्भात स्केलअप केलेलं आहे. अनिरुद्धने आत्ता जे काही उपकरण तयार केलं, वात, कफ, पित्त वगैरे, आणि त्याच्याबद्दल बरंच बोललं गेलं. आणि ते जे अशोक भट नावाचे वैद्य पुण्याच्या नारायण पेठेतले, त्यांनी केवळ जे.बी. जोशींची तब्येत बरी केली असं नाही, जे.बींच्या गुरूंची तब्येत बरी केली, B.D. टिळकांची तब्येत बरी केली त्यांनी. आणि हे लोक जगभर फिरून आले आणि उपयोग झाला नाही, पण अशोक भटांच्या ह्याचा उपयोग झाला. तर अनिरुद्धने हे जे उपकरण तयार केलं ते करत असताना जे.बींच्या डोक्यात आणखीन एक वेगळा विचार आला की अशा प्रकारचं उपकरण इंडस्ट्रीमध्ये आपल्याला उपयोगी पडेल का. आणि मग इंडस्ट्रीमधली मशिनरी ज्या वेळेला फेल होती तेव्हा नेमकं काय होतं. प्रेशर आहे, व्हॉल्यूम व्हेलॉसिटी आहे, त्याची टेम्परेचर आहे, ह्या सगळ्या गोष्टीवरती आपल्याला काही उपाय करता येईल का. आणि मशीन चालू असताना प्रेशर थोडं कमी होते, मग मशीन आता बंद पडेल, त्याच्याऐवजी काही करता येईल का. अशा नाना प्रकारच्या गोष्टी समांतररित्या त्यांच्या डोक्यामध्ये सातत्याने चालू असतात. मगाशी जोशी सर तुम्हाला 99% मार्क माशेलकर सरांनी दिले. मला आश्चर्य वाटलं. त्याचं कारण असं की माशेलकर सरांना असे मार्क मिळाले नाहीत. ते ज्या ज्या वेळेला त्यांचं यश सांगायला CNR रावांकडे गेले, बरोबर आहे ना, व्हॉट नेक्स्ट असंच ते म्हणायचे. म्हणजे याच्याबद्दल नॉट बॅड, नॉट बॅड. तेव्हा कारण काही शिक्षक मला असे माहिती आहे ज्यांनी विद्यार्थ्यांना 60%च्या वर मार्कच दिले नाहीत. का रे बुवा, मला नाही मिळाले कधी 60च्या वर मार्क. परिषदेमध्ये वेगळ्या वेगळ्या प्रकारची संशोधनं झाली आणि त्याच्यामध्ये हे आले की मला भीती वाटते. आता आवरा म्हणतात ते. तेव्हा त्याच्यामध्ये म्हणजे J.B. जोशी हे समाजोपयोगी शास्त्रज्ञ आहेत. आपण सोल्युशन इंजिनियर जे म्हणालात त्यामध्ये समाजोपयोगी शास्त्रज्ञ. आणि मग त्याच्यामध्ये जसं त्यांनी याचं चिलखताचं काम केलं भारत सरकारसाठी, त्याचप्रमाणे सांगली मिरज या भागामध्ये द्राक्षापासून बेदाणे बनवतात. आणि जास्त उन्हाचा ताव असेल किंवा आकाशात मळभ असेल तर त्या बेदाण्यावर पिवळे डाग पडतात आणि 200 रुपये किलोचा भाव 20 रुपयापर्यंत खाली येतो. तेव्हा त्यातून त्या शेतकऱ्यांची सुटका करण्यासाठी त्यांनी एक उपकरण बनवलं. PhDच्या एका विद्यार्थ्याचा विषय. आणि आता 2.5 टन बेदाणे एका वेळेला होऊ शकतील इथपर्यंत उपकरण तयार झाले. ते आता बनवलं जाईल आणि त्या लोकांना विकत घेता येईल. पण हे करत असताना त्यांच्या डोक्यामध्ये आणखीन एक वेगळी खंत होती. ती म्हणजे अशी की अशी समाजोपयोगी संशोधनं खूप ठिकाणी होतात, पण ज्यांच्यापर्यंत ती पोचायला पाहिजे त्यांच्यापर्यंत ती पोचत नाहीत. आणि त्यामुळे आता यंदाच्या वर्षी जूनपासून, याच महिन्यापासून इथे ICTमध्ये कोर्स टाटा इन्स्टिट्यूट ऑफ सोशल सायन्सेसच्या मार्फत तयार होणार आहेत, सुरू होणार आहे. आणि काय 25-30 विद्यार्थी घेतले जातील आणि ही संशोधनं लोकांपर्यंत कशी पोहोचवायची त्याच्यासाठीचं ट्रेनिंग त्यांना दिलं जाईल. अशा पद्धतीचे वेगळे वेगळे विचार त्यांच्या डोक्यात चालू असतात. एका विद्यार्थ्याने सोयाबीनवरती काम केलं आणि शेतातला जो कचरा आहे तो जाळला जातो आणि आपल्याला माहिती आहे पंजाबमधून दूर दिल्लीपर्यंत येतो नेहमी. तेव्हा त्याचा बायोचार बनवून ते खत वापरून सोयाबीनचं उत्पादन त्याने 25-30% वाढवून दाखवलं. तेव्हा अशा पद्धतीने लोकांच्या उपयोगाची जी गोष्ट आहे ते प्रॉब्लेम ते आपल्या PhDच्या विद्यार्थ्यांना देतात. म्हणजे मल्टीफेज रिॲक्टर हा एक भाग झाला. पण आता अलीकडे त्यांचा विचार ह्या प्रकारच्या गोष्टींवर आहे. नंदुरबारला मिरच्याचं उत्पादन मोठं होतं आणि त्या मैलोन मैल अशा वाळत घातलेल्या असतात लाल करण्यासाठी. त्या लोकांचा एक प्रॉब्लेम आहे, एकदम पाऊस झाला वळवाचा तर त्या मिरच्या भिजतात आणि क्रिकेटच्या मैदानावर चटकन त्याच्यावरती जे कव्हर घालतात तसं काही इथं घालता येत नाही. तर त्याच्यासाठीचं काहीतरी आम्हाला करून द्या म्हणून हा एक प्रॉब्लेम त्यांच्यापुढे. मग अशी काजूचा उपयोग त्यांनी काजूबद्दल उल्लेख केला. एक 10-15% काजू वापरले जातात, बाकीचे वाया जातात. त्याच्यापासून आता इथेनॉल आणि इतर उद्योग कसे सुरू करता येतील त्याच्याबद्दलची चर्चा त्यांनी प्राज इंडस्ट्रीजशी केलेली आहे. तेव्हा अशा अनेक गोष्टींकडे त्यांचं लक्ष आहे. आणखीन त्यांची शिकवण्याची पॅशन किती आहे. एकदा एका प्रवासामध्ये ते कुठेतरी अडकले, त्या तळ्याकाठी बसले ते 2-4 तास. त्यांच्या सुनेला तेव्हा त्यांनी फ्लुइड मेकॅनिक्स शिकवलं त्या तळ्याच्या काठी बसून. असो तर आजच्या ह्या एकूण कार्यक्रमासाठी मगाशी सांगितलं की भोष सर हे सगळ्यात या इथे वयोवृद्ध आहेत. त्यांच्याशी टक्कर देण्यासाठी किशोरभाई मारीवाला इथं आलेत, तेही त्याच वयाचे आहेत. जोशी कुटुंबियांनी हा सत्कार स्वीकारायचं मान्य केलं, कारण आमचे एक पंडित सुधीर पानसे, हेमंत जोगळेकर आणि मी अशी आमची समिती होती. तेव्हा त्या समितीतर्फे ही विनंती केली, ती त्यांनी मान्य केली. आणि आमच्या चौघांमध्ये जास्त काम हेमंतने केलं, ते आजही तुमच्या लक्षात आलं असेल. तेव्हा त्याचेही विशेष आभार मानायला हवेत. ताम्हणकरबाई आणि भोस सर आपलं वय विसरून आज सकाळी निघाले मसरून इथं आले आणि ताबडतोब कार्यक्रमाला जॉईन झाले. मला नाही वाटत आपल्यापैकी कोणी इतका प्रवास करून आल्यावर लगेच या इथं बसून, पण ते भोस सरांनी सांगितलं व्यायाम. ते झाल्यावरती प्रोफेसर शर्मा, माशेलकर सर, आणखीन काकोडकर, दिवसभर आज तुम्ही वेळ ह्या कामासाठी दिला त्याच्याबद्दल तुमचे आभार. सैन्य पोटावर चालतं, जेवण चांगलं मिळालं, बरोबर आहे ना? आपण सगळे मान्य कराल. सर्व यांचं वक्ते जे आहेत त्यांचे मी आभार मानतो. बाहेर भानुसे बंधूंनी फोटोचा जो काही अल्बम लावलेला आहे दोन्ही बाजूला, मध्ये फोटो काढलेला आहे, त्याच्याबद्दल त्यांचे आभार आहेत. ते झाल्यावरती राजम नावाचे ICT मधले गृहस्थ आहेत, त्यांनी व्हिज्युअल डिस्प्ले आणि रांगोळी काल रात्रभर जागून त्यांनी केली, त्यांचे आभार आहेत. सगळे व्हॉलेंटियर्स हे जोशी सरांचे विद्यार्थी आहेत, 1 डझन व्हॉलेंटियर्स. आणि सारंग जरा थोडा पुढे ये. मगाशी ताम्हणकर मॅडम जे म्हणाल्या की माझा नातू जोशी सरांकडे सध्या PhD करतोय, तो हा सारंग. मराठी विज्ञान परिषदेच्या लोकांनी सुद्धा खूप मोठी मदत केलेली आहे. आणखीन आज दिवसभर आपल्याला चांगली कॉमेंट्री हेमंत जोगळेकर यांनी दिलेली आहे. हा व्यवसाय तुम्हाला आता करायला हरकत नाही असं वाटतं, तेव्हा त्यांना पण एक हे करूया, सत्कार करू, त्यांचं स्मृतिचिन्ह. पिशव्यानंतर आणा, पहिल्यांदा त्या 2 गोष्टी. हां, जोशी सर तुमच्या हस्ते. मला वाटतं सगळ्यांचे आभार मी मानलेले आहेत, पण राहिलं असेल तर पुण्यात एक पंडित वसंतराव गाडगीळ म्हणून आहेत. ते आभार मानताना संस्कृतमध्ये आभार मानतात आणि ते म्हणतात ये आगता ये न आगता तेषाम सर्वेशाम, असं ते आभार मानतात. तेव्हा त्या पद्धतीने शेवट करतो आणि आजचा हा कार्यक्रम संपला असं मी जाहीर करतो. धन्यवाद. आपण सर्व श्रोते फार मोठ्या संख्येने आलात, त्याच्याबद्दल आपलेही आभार.